Hello.
Hey. So, hi everyone, I'm Jessica, and I spent the whole weekend reading my friend Debbie Soon's new book, Digital Mavericks, which I absolutely loved, and we're going to hear about today. So, Debbie, why don't you start us off by introducing yourself? Tell us who you are and what you're doing.
Oh my gosh, well, it is such a pleasure to be here at ETH Denver this year, and thank you so much, Jessica, for pouring through my book. It means a lot. I have to say it feels surreal today, even when I see somebody holding a copy of my book in their hands. But yeah, who am I? I feel like everyone to some extent has almost forgotten themselves when they enter the crypto space. So one thing I like to ask everyone is, who were you before crypto? And that was me, at age 5, growing up in Singapore. Really had no idea what I wanted to do. But after that, I feel like I've had a lot of different lifetimes since before coming into crypto. One that started off with finance. I was an equity investor. I worked for the Singapore Sovereign Wealth Fund. I've had the great opportunity of meeting Kobe Bryant at an investor day. I founded a fitness studio. I then went on to work for a mixed martial arts promotion. And so it feels like I've done a whole bunch of crazy things. And so you may be wondering, what on earth am I doing in crypto? But I guess 3 years ago, when I moved from Singapore to the US in the middle of the pandemic, I decided I had no way of meeting people in person. The only way I could do it was to dive into internet communities, and that's exactly what I did. I entered Discord, which is funny because I don't use Discord anymore. But I entered Discord, and I basically posted a message in the beginning of 2022 just saying that I love everything that I've learned so far about crypto. I love how the technology empowers people. I love how it's making it easier for creators to monetize their work. I just want to be a part of this cutting edge revolution, even though I knew next to nothing about it. And before I knew it, I met my co-founder, Randy Zuckerberg, yes, that Zuckerberg, sister Mark, in a Discord server. As you can see, I wasn't even using my real name. I was behind a random avatar. Those emojis actually behind Sephironova were part of a yacht. I don't know who around here had a yacht domain URL. But anyway, I went on to become the co-founder of an on-chain creative community and marketplace called Hug. We've grown to over 35,000 users across 180 countries. Our mission has been to empower creators to become entrepreneurs through education, through technology, and to really get them to embrace using blockchain as a way to better monetize their creations as well as connect with their audience. And from there, we did some great things. Again, went on, I feel like sliding into people's DMs or just showing up in random internet spaces as well as in person, opened a lot of opportunities for me. And that was my DM to O'Shiny, if anybody knows who he is. I simply reached out, no agenda. Few months later, him, together with OKX Ventures and L'Oreal, ended up leading our seed round. And we've grown Hug ever since. Not just the numbers that I stated before, but we've also distributed $350,000 of scholarships and grants to help creators really take their work to further places. We've educated thousands of creators and onboarded them to new protocols, whether it's the Rary chain to Lens protocol, teaching them how to collaborate with Stability AI. And all of that has finally culminated into a successful acquisition at the end of last year by the .art domain registry, which is the biggest TLD operator for the arts and creative industry. So excited for this new chapter for Hug and essentially what the .art team is going to do. They have some great blockchain verification tools that will allow artists to better track their work as it changes hands, as it changes ownership, and really facilitating that part of the journey. And so that's a long answer to who I am and why I'm here, but that's been the joy of writing this book and diving into it.
I love that, and I love how serendipitous that whole story is. So I don't know how you possibly had time to write a book in between all that, but I would love to hear yeah, like what possessed you to write a book and what this book is about. Why don't you tell us about that?
Yeah, so the book in a nutshell, it really is 50% accessible guide to crypto. So I feel like talking about it, Eve Denver probably, it's a little bit like preaching to the choir. I should be out on the streets, which by the way, I told my Uber driver about it yesterday and I even gave him my merch pack. So hopefully he does go check it out. But it's a 50% accessible guide to understanding crypto. If you are already in crypto, it's really about how to stay sane. I know a lot of us, with the ups and downs, especially the markets, sometimes it gets to be a lot. And even though we don't want to admit it to ourselves, it's really about how do we tune out the noise and really focus on what we're here to do. And 50% of it, which is personally my favorite, 13 in-depth features of these great digital mavericks, so people that I've come to know and respect, people like Jesse Pollock, who obviously created Base, people like Cosimo de Medici, who is a pseudonymous art collector who may or may not be Snoop Dogg. I mean, he's not Snoop Dogg, but as well as a bunch of amazing artists like AI collaborative artists, Claire Silver. So, tons of incredible stories and really just about how they even entered the space. So similar to how I gave that rather long-winded explanation on how I entered crypto, they too have had an incredible life story. And this bit about entering crypto is really just their new chapter, just like every one of us.
I love that so much. And one of the things that really stuck out to me as I was reading it was about the glow stick moment. I think that's just such a fun way to put it, but could you explain for everybody what a glow stick moment is, maybe what your glow stick moment was, and a little more about that?
Yeah, I think it's funny because so I'm probably the first time I invested in crypto myself was 2019. So it's early for some people, late for some people. I don't know. It depends on how you look at the timeline. But ironically, the crypto that I bought then was XRP, which is hilarious because then it got hit with an SEC lawsuit, and then I was like, well, this is all a sham. Like, I'm never going to put money into crypto again. It's been pretty funny since obviously recently it's been one of the better performing coins, and I still have that bag of XRP, by the way. So I have round tripped it around the moon and back, and now it's like way up. So I feel a little vindicated. Yeah, 5 years later. But I will say that for me wasn't a glow stick moment. That wasn't a time for me where I looked at my investment into XRP, and that wasn't a time where I really got it. And the reason why I use the phrase glow stick moment is because, when you break a glow stick and it just lights up, and all of a sudden you just can't unsee it, and you can't unsee the possibility. And sure, maybe the light fades after a little while, but that is that moment that once you're broken it, there's really no turning back. And for me, that moment really was when I moved to the US, again, from Singapore, and I really kind of got my involvement heavily in the NFT space, and a lot of that came from my consumer background. Even as an investor, I looked at consumer and consumer tech, at the mixed martial arts promotion. It was a very tangible product, right? Like we were selling merchandise, we were selling experiences, and that for me, I felt translated really easily into the world of NFTs, both as we're just really still selling digital goods. We're just doing it in a different way, on different payment rails. And I think the aspect of how NFTs really help people connect with their audiences was truly kind of eye-opening for me, having spent 3+ years trying to build direct relationships between athletes and their fans.
So cool. And that's actually touches on something that I find so fascinating about the space, which is the role of blockchain and NFTs in fan engagement and the connection between artists and their fans. Could you speak to that a little bit?
Yeah, of course. And I mean, I think it's, I work the most closely with creators. I know obviously blockchain is a huge space. This industry is huge. I think as much as it is niche, it is also very broad. You're going to have people that work solely in DeFi and know everything about DeFi and have no idea who Sam Spratt is, who, by the way, is an incredible artist that is doing some crazy activation that should be all over Twitter if that is what your algorithm is looking at. He's sold work for millions of dollars, and it gets people to write their own interpretation of his work, and it's all part of the blockchain, right? So that's kind of the art world, which again lives really separately. And then we have people building in privacy, and all of that is kind of like a different part. And so I think coming back to how NFTs really help with, owning your audience and owning that engagement. There is this creator that I love. Her name is Naomi, or she goes by Afro Chicks as well. She was actually one of the earliest members of the Hug community, and we knew her because she was an artist. And her name was called Afro Chicks because she drew these really fun, colorful illustrations celebrating Black women hair. And what we then later came to find out was that she's actually a professional triple jumper for Great Britain, and she's currently training to be part of the Olympic team in 2028. That's the next Olympics, yeah. So she's currently training to be part of the Team GB for the 2028 Olympics, and she has been posting her entire journey, putting it on Zora, earning, and Zora's had a big change, just recently and turning everything into coins, but basically monetizing, the effort that she's been putting in, and the people that are there supporting her journey. She could get 100 likes on Instagram, she could get 200 likes on Instagram. This isn't going to pay for her training. This isn't going to pay for, like the new equipment or the new shoes that she's going to use. And so, I think we've seen some really new and novel ways, and obviously we're still at the early innings of it, but imagine how her community is going to feel when she actually does make it to the Olympics, knowing that they were early on. Maybe the tokens or the video that they had collected from her on-chain is going to appreciate in value, and all of a sudden there are aligned incentives between both the creators and the people that support them.
I love it. I think there's so many really cool things that we're going to see happen in the space. But I think one thing that's on people's minds right now is that the market is kind of interesting, to say the least.
Yeah.
Do you have any advice for staying sane in this space?
Yeah, and I feel like, to be honestly, that is the biggest thing about why I wrote this book. I'm not a technical person by any means, so I didn't want to come in here and pretend to explain stuff that I wasn't entirely sure how things work under the hood. But I think what I do know is, having worked in startups, well, first of all, having worked in finance, where your entire remuneration and where your entire sense of judgment is completely live. My bonus for every single year was determined by what the markets were doing. And I could see in real time whether the judgment call I made, say if I said, let me invest in Nike at whatever price it is, I could see pretty much immediately whether that was right or whether that was wrong. And again, but then again, whether it was right or whether it was wrong was also very dependent on what time horizon you were looking at. If it was within a week, it might have been a crappy decision, but then, over the next year, it ended up being an incredible investment decision. So I think a lot of that is, being able to frame yourself in terms of what your goals are. And I think that's why I have kind of number 2 here in terms of what is your why, and understanding and holding on to your why. For some people, it's completely about making money, and that's great, good for you. For some people, it's a little bit more than that. For some people, it's really about wanting to make a difference. It's wanting to not be a passive participant. I personally am of the belief that one day we won't even know that all of these things are running on crypto, just like we never really understood. I feel like when the cloud computing came out, I didn't even know what that meant. I don't even know what servers are being used. I don't know if this program is on AWS or on Google Cloud. And frankly, as a consumer, I don't care. And I think as we progressively move towards blockchain adoption, that is what we're going to see as well. And so for me, my personal why is really helping to play a part in shaping the future that I want to see, being a part of great products and great companies that are doing all of that. And I think by holding on to that, it honestly doesn't matter whether the market is up, the market is down. Yeah, did buying X up here at 80 cents and seeing it go down to 20 cents hurt like a bitch? Yeah, it did. But it feels great now. It's back at 250 or whatever it's at now. But that at the end of the day wasn't what was going to keep me going and waking up every single day excited to hit the ground running.
I love that. I always like to say, especially with meme coins, if I'm down, you know what, I'm having fun, and that's all that matters. Yeah. That's so cool. Back to NFTs, favorite NFT you purchased?
Favorite NFT purchase? I have
or created.
favorite NFT purchase. I mean, I have hated this that I did own a Moonbird, and I feel like so sad too. But I do kind of like their merch. I still have their socks. Like, I think I actually like wearing their socks. But favorite NFT, honestly, I have commissioned a lot of work from artists. So, again, this is kind of holding true to my why, right? Like a big part of my story too is that I grew up in Singapore, very conservative Asian upbringing. Always felt like I had a little bit of a creative streak to me, but I was in a choir, I wrote poetry, I made collages, I did all of these things, as a kid, but never really got the opportunity to do anything with it, or was never even encouraged to pursue it. So I think working with creators was a big thing for me and a big thing that motivated me. And I saw as well, even when I took this travel photography of myself that I had just uploaded on Instagram, and I got like 200 likes, and then I sold it as an NFT for $50. And I mean, it wasn't much, but like that was $50 more than whatever I made from Instagram. And so I think a lot of my favorite purchases have actually come from me reaching out to an artist that I love, and saying that, hey, I have this idea of this really great piece that I want. I'm a massive football fan. I approached this photographer who takes photos of film, called Nathan Bauman. He basically went to scout one of the football fields that I think is just like a high school football field that is at the highest altitude. It might even actually be somewhere in Colorado, actually. And just took this beautiful photo of just the gridiron. And I love that piece. It's so meaningful in the fact that he went there, camera gear, and now I own it as a print, but I also own it on chain. And so that to me are the priceless moments that you can't replicate elsewhere.
I love that so much. Big fan of my crypto dick butt, but football too.
We all love a dick butt.
Who doesn't? I love it so much. Do you remember the first time you learned the word fungible or heard the word fungible?
Yeah. I mean, I guess I knew it I was an econs major, so I knew it in that. I do remember when hearing it in the context of like non-fungible token, it did feel like I don't even know what the alternative is. Like maybe it's just a token, maybe it's something that's tokenized, but it did feel odd. And I think part of it too, it reminds me of this analogy that I always like to use is that, and obviously I'm dating myself, but when, we were younger and we used to, download MP3s off Napster, I guess even though we weren't supposed to. And then, we would turn to our friends and we would go, what MP3s did you download last week? Or like, what MP3s are you listening to? And it's so... I mean, it's kind of ridiculous because that's just a file format. That's just the way that you are receiving the music. At the end of the day, it's like, what music are you listening to? I don't even know if, the California DMV has already completed a pilot where the car title deeds are on the blockchain. So technically those are NFTs, but I'm not going to go around and be, oh, my car title deed is an NFT. Like, what about yours? It's just everything, tickets. So yeah, I think when you asked me about the word fungible, we're still going to use it. It has like an actual definition and everything, right? But I think that the way that we approach, and I feel like my publisher also made me put NFTs in the title just for SEO purposes, which I was like semi-annoyed about. But, I think eventually it's going to be one of those things that feels a little dated and we're probably not even going to refer to it anymore.
That's so funny. Well, we're coming up on 2 minutes left here. So just to round this out, any last words or anything people should know about your book, or where they can follow you, where they can learn more, and how they can get involved? I know that you are a fan of just sliding into people's DMs, which I absolutely love. But yeah, if you want to speak about that.
I will say, by the way, I talk, one of my last points here is craft and commit to a ritual. And when I was new in this space, one of my rituals was actually kind of writing a cold DM to one person, at least one person every other day or like at least once a week to build a connection. And that's how I built my community. But yeah, in terms of what you guys could do, I am proud of this moment. I think it works. So I'm not a coder, but thanks to the power of AI and I guess what we all now call like vibe coding, I coded my first kind of on-chain app, if you will. So it's just a personality quiz. So, but it's at quiz.digitalmavericks.xyz. You would take a little personality quiz. It's pretty fun. And then at the end of it, you'll get your result. You can share it, and then you can collect one of these comics that is essentially a condensed version of the story that was in my book. The illustrator is this comic illustrator called Dana 8 Oatmeal. And I will caveat, and somehow I kind of feel like this is not a me problem, but maybe a Privy or a mobile wallet problem. But it works best if you do this directly in your mobile wallet browser, or if you're doing it on desktop, I highly recommend MetaMask or Phantom. So yeah, just do it. It's fun. It's free. Also, if you have friends and family who are not into crypto yet, I also managed to incorporate paymasters, so all transactions are sponsored. You don't even need gas. You just need an email address. So yeah, I think it's really fun. I love personality quizzes. I love knowing what people's MBTIs are. So this isn't quite that, but yeah, it's a lot of fun.
Amazing. Well, thanks so much. I'm going to go take this quiz now and
Yeah.
have a Denver.
Yeah, and if you want to connect, those are me on socials. My book is on. We're at an on-chain event talking about traditional publishing, but it is on Amazon. It's at Barnes & Noble. I will be at the Base booth on Friday, 10 to 12. They have a bunch of books that they'll be selling on-chain there as well, and I'll be there signing it. And I think I have one copy here, so that I'm happy to give to whoever wants it. So if this is of interest, just come find me. First come, first serve.
Thanks so much.
Thank you, Jessica.
Truths from trash sheets, that's my device. Nullifier sniffing while my coke's too crisp. Mainnet gossips, tastier than breakfast chips. Story, hack, flurry. Mama's making news before the cold reload. Got receipts in my cheeks, encrypted and plumbed. You private DMs, I'm the dumpster dive chump. Eyes everywhere, that's 3 bird phones. Haunteries whisper, king chomp and blockchain bones. Make it down to my voted fuck. Stealth crawl through your junk dead scene. Head it up to the entropy. Mace cracked vaults like who's got the keys? Nullifiers huffing, you're just a rat with his firewall splinter to confetti bits. I'm curating leaps at the after party, sipping tearless tears. Call me well connected, I call it guitar slide. Guitar slide. Coffee for drip and the lab coat on fire. Sticky note constellation stuck to the ceiling wire. Gas fees are confetti. They rock on P Island. Get homemade in 7/4 time. Shaboom dose, the efficiency pulse. The lad runs lagging in his latency sub. Professor Way's got the future on spinball. Urgent notes dancing where the bottleneck's been. Professor Way's got the future on spinball. Bugging tomorrow with yesterday's ram stains. Velcro boots clicking through blockchain debris. Crypto notes flutter like drunk bumblebees. Optimize the boot fins, they cackle and shout. Self-sustaining hubs flicker in the blackouts out. Professor Way's got the future on spinball. Urging notes dancing where the bottleneck's been. Professor Way's got the future on spinball. Dug into
All right. Hey everybody. Going to be talking through two things today. One being talking a little bit about Layer 0 Read, why we built it, what it does and how it's used currently in the ecosystem, and then sneaking in QMDB because that talk was vetoed later on, so we'll just squeeze them both in. So, Layer 0. Who are we right now? What do we do? Largest interoperability protocol currently in the space, 120 plus blockchains, 144 million messages, 75-ish plus $1 billion of value transferred, closing in on $100 billion, which is awesome. 71.3% market share when it comes to just pure messaging volume, 60% market share when it comes to value transferred. And the thing that's interesting there is that the market share delta between those two means there's a not at all insignificant percentage of the messages that are starting to be non-value transfer, which is really interesting. And so what is Layer 0 Read? Read is the ability to take any data from any chain over any period of time. And so you had this problem historically, if you wanted to access any state data from, say, Ethereum. Originally it was just you couldn't get it. You needed some external oracle to provide you that data. Most people can't get these oracles to even respond to them, let alone on like a very long period of time. So this was like hard to access. And then it was, even if you could access the data, it was both slow and expensive. So you can imagine trying to fetch something from Ethereum. Who owns a pudgy penguin or a bored ape? What is the current price of the ETH USDC pair on Ethereum, on Uniswap v3? Any of these pieces of data, you would have some latency coming out of the chain you were requesting it from. You'd grab a moment in time snapshot of what is the thing at that exact moment, which is obviously kind of manipulatable to attacks on price or just like moment in time snapshots. And then you have this 3-minute and 15-second latency coming back to deliver the data. And so not only did you have pure moment in time data, you had really stale data by the time that you needed it. So Read is designed to sort of address all of that. Any data, any chain, any period of time. So what are some of the use cases? One of these is election market that got settled in the last election. Wintermute introduced basically the ability to create any market in a prediction market style, but they need a way to like resolve what actually happened there. They used Edge, Chaos Labs' Edge Oracle for this, and so the election happened. There were markets that lived on any of these chains, so anybody could buy either side of this market on any of these chains through just like an AMM structure. Edge through Chaos posts the election result onto Arbitrum, and then every other chain just absorbs that data basically through Read to settle all the election markets simultaneously. Shadow assets is something that we see more and more now for anything that needs auth or ownership. So you can imagine a world where your authentication lives on a given chain. This could be world chain. Again, this could be the ownership of who owns this bored ape or this pudgy penguin. One thing we saw that was cool was Ape Chain itself. They didn't want to actually transfer the ape, right? You don't want to be bridging this asset because there's a bunch of stuff that was built on Ethereum that relies on those ownerships. You have some traits or some benefits that you've gained in that ecosystem, and to need to move the asset might actually like harm the end user. So this shadow asset was the ability to prove with Read that you own the asset without actually being able to move this. And we actually saw this in a couple of games prior. Some of the biggest games, Proof of Play, Pirate Nation, a couple of these, basically what they really wanted is, hey, we want our assets in our ecosystem to live on this chain. We want people to play the game. We want people to have everything that they own here, but all the liquidity is on Ethereum, right? So like we want the real assets to be traded to live back in Ethereum. And so what they really want is kind of like an ad hoc oracle that's a representation of what do you own, and then when that changes, you can just, there's a couple of really interesting ways I won't get too deep into it. You could use a Bloom filter to do some really cool stuff here. But basically, without needing to move the asset back all the time, without needing to touch Ethereum state, and obviously touching Ethereum state is the expensive part. Back when ETH transactions were $15 to $20, again, you want to fetch a single piece of data like, hey, who owns this NFT? Or like somebody just sold this. You're going back. You need to do a write on Ethereum to request what you're trying to fetch, and then another write on Ethereum to send the response back. So you're paying $40 to $60 in Ethereum L1 fees just to get the response of what you're doing. With read, you don't ever actually touch ETH state. You're never writing anything. It's read only. And so you write on your extremely cheap chain that costs 1 penny, hey, fetch me this data or this construction of data, and then you immediately get the response back next block, right? So there's no latency, there's no cost, you're not touching Ethereum state at all. And so what that enables you to do is a bunch of really cool things. But one, you can do a lot of stuff that you would cost $60 before. So the world of actions you can take when you're paying $10 to $60 per action versus the world of actions you can take when you're costing a penny per action is just night and day difference. And that in its own is super exciting. So one of the things I was most excited about was this ability to stream pricing data. So you can imagine not just being able to grab what is the current price of ETH USDC on Uni v3 on Ethereum, which is great, but I can grab 100 block TWAP, and I can grab it of any long tail asset on any chain, and I can live on some new chain that's spun up, right? We have 120 plus chains right now. I promise you the 118th of them is gonna have a really hard time getting Chainlink or getting another Oracle provider to give them price feeds consistently. It's just always been a problem within the industry. This is the ability to be able to build DeFi constructs around pricing across any formulation that you want. And you can grab, what is this, what is the price in this DEX on Solana, but you can also grab I want 100 block TWAP across these four DEXs that live on 4 different chains, and then I want to amalgamate them all and create some price index based on that. And anybody can do this permissionlessly. There's no, nothing custom that you need to write. You don't need to ask us to add an asset. You don't need to ask us to do anything. You can read any piece of state on any chain in real time, and you can apply this sort of external mutations to them, which is really, really interesting in terms of what you can build and what that enables in long-term DeFi. So yeah, that's Read. Super excited about Read. Have seen usage slowly but steadily ramping up. We did it for our own voting. I think you'll see more and more governance across multiple chains use this structure. More people like ApeChain, like a ton of others, are starting to build their own internal primitives on it, which has been cool to see. I've spoken about for a very long time. I've always been much more excited. Value transfer is interesting, but honestly, when we built Layer 0, there were already bridges, right? Bridges existed. The entire point of Layer 0 was that everybody was thinking about these things as purely a bridge. And for us, the insight that we had was that value transfer is just a special case of generic messaging, right? Really what you're doing is just sending packets on the internet. It's arbitrary contract invocation with a bytes array. And the ability to take that and express it in any form that you want should unlock a ton of really exciting things, especially as applications become more asynchronous, more data rich across multiple environments. And for the last couple of years, it's pretty much been wrong, right? Almost everything has been value transfer, but I think that is quickly changing, and I think you're seeing applications become more stateful at the application layer. I think you're seeing applications start to lean into not becoming just a single isolated instance across a lot of different chains, but becoming real asynchronous instances. Stargate was one of the first examples of this. So I'll dive into QMDB now, which is the talk that was not supposed to be a talk. So this, I think, is for me one of the more interesting things we've worked on lately, and totally orthogonal to pure Layer 0, right? We've spent a lot of time, probably more time than any other team in the world, in actually digging in to every single VM that we have to go to. And so we built Ethereum, and we've always taken the stance that the protocol must be immutable. The protocol is not immutable, then every application built on top of us has to rely on us for some layer of trust, and that is not an acceptable precondition, and we don't think we ever would have grown to the size that we are now if we didn't have that. But what that means is every single thing that you do is terrifying because you get to basically launch the protocol once. You cannot fix it if there's a bug. This is the same way that Uniswap has built everything for a very long time. So it's really a measure twice, cut once. And so, I talk regularly. We spend probably $5 million a year on audits. I think we're the largest consumer of audits out of anybody. Our Ethereum contracts have been live and in production, since March 2022. so going on 3 years now. Those are battle tested, tens of billions of dollars on them, tens of billions of dollars flowing across them. Launching to a new EVM is quite trivial, right? It's largely just a fork of the same code. Launching to a non-EVM is completely non-trivial. You talk about our Solana program, compiles to 50,000 lines of Rust, which I think is one of the largest Solana programs out there. We talk about Ton. We just went to Telegram. We literally rewrote an entire programming language, Fun C++, on top of the Ton VM in order to build this and help other people build more easily. Talk to Aptos, Move VM, like many of these VMs, we've found crits. We've helped teams patch them. We have to go really, really, really deep because it matters on the security side in every single layer that we go to. And so in doing that, one of the things we've seen is kind of what stresses scaling in each system. And if you look at Aptos' recent Shardines million TPS example that they give, storage was the bottleneck there for each of the shard, right? Each one of the Shardines had 33K TPS, but were bottlenecked by storage. So what is the insight here? And a lot of this insight actually came from our chief architect, who was on paternity leave, and he just started poking around. And I guess because this is the thing that you do when you have a baby, you create a really interesting database. So conventional belief was you must use a searchable data structure, i.e. a trie, and everybody built that way. And the challenge is tries have really significant write amplification, which causes a lot of issues. And the alternative, and the insight that we had, is that actually a log-based DB that's modified to support mutability, exclusion proofs, and historical proofs is actually extremely highly conducive to in-memory Merkleization. And so what does that actually look like, right? It's fast, really fast, 3 million updates per second. And 3 million updates per second is, I'll just look. Compared to state-of-the-arts right now, even for unverifiable databases who are not doing Merkleization at the DB level, this is 6x faster than an unverifiable database while doing Merkleization. If you look at state-of-the-art for actual verifiable DBs, which is NOMT, it's 50x state-of-the-art, and it's 92% theoretical optimal on current EVM workloads for disk I/O, which is just like an insane step function. There is no 10x more from here in terms of what can actually be gained. It's really incremental, and so this is a huge step function. We've seen way more interest than I expected in terms of teams wanting to adopt this, because storage has been, you think about any architecture, computer architecture, blockchain architecture, it's really storage, compute, and network, right? And this really creates a lot of compression and solves one of those vectors. And so if you look at overall highlights, 2.28 million state updates per second, over a million TPS, benchmarked at transfers per second in terms of token transfers. Benchmark with workloads up to 15 billion, which is 10x Ethereum's 2024 state, and have proven capacity to scale to 280 billion entries on a single server. So really massive gain there in terms of what can actually be held and processed. Single read per state access, so order one reads, which is anybody who spent time in computer science, it doesn't get any better than that. In-memory Merkleization on a footprint as small as 2.3 bytes per entry. Efficiently scales across both consumer grade and enterprise hardware. So small machine is going to be as efficient as a big machine. It's really a lever that you can play with, and available for any blockchain to implement. Everything is fully open source, Apache, MIT, completely available to the world. Received a lot of amazing feedback from within the community, from Uma talking about what this actually means for real-time blockchains and real-time proving, relative to needing to pack an entire block with MPT and having slow proving on top of this. So this gap of latency that's being shifted to being able to pack on a per transaction basis with QMDB. Patrick, I'm a huge fan of at Commonware, talking about him, not believing that this was possible, and Yilong from Mega ETH talking about how we basically, perfectly solved the bottleneck of Merkleization with this. So super excited about QMDB, super excited to share more kind of with the world and see the first group start to implement it. And more or less, hopefully going to keep building things that are genuinely useful to the industry as a whole, open source as much as humanly possible, and help the space move forward. So thank you all so much.
do-do-do-do. Do-do-do-do, if I do-ba-do, if I do-a-do. Ho-ho-ho. You ordered a moonwalk across gas feet graves. My mainnet's smoother than your mom's VPN saves. Daughter of the Rockies, high-speed high priestess. Scales of justice ballast on a Memphis Express. Next bottleneck, I see mountain crush it. Click, clack, bosom lace on firewall. Eyes smoked and truce from dress sheets. That's my device. Nullify a sniffing bomb my copes too crisp. Mainnet gossips tastier than breakfast chips. Story, hack, flurry. Mama's making news before the cold reload. Got receipts in my cheeks, encrypted and plumbed. You private DMs, I'm the dumpster dive jump. Eyes everywhere, match 3 bird phones. Quantaries whisper, king chomp and blockchain bones. Make it down to my voted fuck.
Good morning, everyone. Thanks for joining me here this morning. I know it's pretty cold in here. I wasn't planning on wearing a sweater. I'm Max Howe, co-founder of T Protocol and creator of Homebrew, and I'm here to talk about fixing open source's broken incentive model in our Web3 world. But first, a bit of story time. Some time ago, when I was young and foolish, a bit naive, I thought that I could write a package manager. It was 2009, and I was working at a startup in London, and we developed apps for 6 different platforms: Windows, Linux, Mac, Android, Android, iPhone, and even a BlackBerry app. And we used Mac as this unifying platform to develop for all of the other platforms. It was the one that you could do everything on. But the package management solutions weren't that great. I used to complain about it a lot to my coworkers, to the point that they got fed up with me continuously complaining about it and challenged me to do something about it. So I went home that day and made the first commit to Homebrew. This is a video showing the commits to Homebrew over time. As you can see, initially it was just me, because all open source starts off with just one person with an idea, something that maybe could turn into something bigger. But I managed to get some attention, and suddenly it was overwhelming. There was thousands of people contributing to Homebrew. And it was very rewarding to have this happen, but I started having to dedicate evenings, weekends, lunchtime, getting up early, doing extra work so that I could work on Homebrew and handle all of these pull requests and all this amazing amount of contribution. After a few months of that, even that free time wasn't enough, and I decided I wanted to quit my job so that I could work on Homebrew full time, which became this cycle in my career where I would save up some money, quit, work on open source and Homebrew full time, run out of money, and then find a job again. Usually a contract work, or maybe working for a startup, something fun. But what I wanted to do was work on an open source. And over the years, it became apparent that Web 2 was having a success built on top of open source. Open source was the layer that allowed them to make the world that we know today. 15 years ago, open source was still considered kind of niche, and it was over those years that it became more and more the foundation of the world we know today. Meanwhile, while they were making fortunes, I was working paycheck to paycheck in order to maintain this open source. And my story is far from unique. Almost all the big open source projects have a very similar founder story. And, something's just not right with that. There's so much money in the software industry, but so little of it trickles down to the open source foundation. Open source is everywhere nowadays. It's been to Mars, it's at the bottom of the ocean, it's in every pocket of every human on the planet. And yet, the open source developers I've spoken to over the last couple of years, as I've developed out T Protocol, are usually earning very, very little money at all, if anything, from donations or bounties or any of the existing systems that are there. Even though 97% of commercial code contains open source, as we know. A recent study concluded that open source is worth almost $9 trillion, a rather impressive amount, but really it makes sense that's the case, right? And the money that is being made here is not trickling down. This is a famous XKCD comic that's actually almost 20 years old at this point. This is a problem we've known about for an awfully long time. Everybody knows about this problem. The fact that all modern digital infrastructure is built on top of this shaky foundation of open source that's maintained by people that are barely able to find the time to do so. The comic points to this pillar at the bottom that is thanklessly maintained by some random person in Nebraska. And so we've adopted this. We call this the Nebraska problem. The Nebraska problem is a fundamental problem with open source. It's making the internet fragile. It's making it insecure. And this is just coming more and more to a crux every year that this continues. I love this quote from Denis Pushkarov, who is the maintainer of Core.js. Core.js is a typical Nebraska project, buried deep in the stack of every single Node application that exists. You can't really make a Node application without it. It's downloaded billions of times a week, and yet he slaves away maintaining this thing with almost no support from the billions of companies that build on top of it. FFmpeg tweet this every week. All modern video software that we use to watch Netflix and the like is built on top of their work. They've been building this stuff for more than 20 years. It's incredibly impressive software. They have a tongue-in-cheek attitude about it, as all open source maintainers kind of do, because at the end of the day, we didn't make open source to make money. That wasn't the point. We made open source because we wanted to make something cool that we hoped other people would find useful, push the bubble, make the world a better place, make the world a more capable place. And yet, it would be nice to be able to work on open source full-time. That's what we want. I would love to be working on open source full-time right now. I started T-Protocol because actually I didn't want to start T-Protocol. I wanted to work on open source full-time. Around the time we were getting funding, this classic exploit happened, which was great for us getting funding, incidentally, where the whole internet ground to a halt for a few weeks because there was this massive exploit found in Log4j, just some logging software that's used on just about every Java server that exists. And Java servers were root exploitable on day one. The maintainers received a huge amount of flack on social media about this. They said, look, it's our fault, there's a bug, but we barely have time to maintain this thing. We'll fix the bug, but maybe some of these companies that use our software could, send us some donations or help fund us to work on it more time after we fixed it. And yet, the world has basically forgotten about this Nebraska project. A few years ago, I was once again trying to work on open source full-time, and I looked to see if there was anything new in the space to try and make it so people like myself could do that. And I didn't find anything new. And I tried the existing solutions, like begging and trying to get bounties applied to my software. And then making a Patreon and begging people to fund me. I had a Patreon that got up to about half my rent at one point, but half my rent is as good as zero rent, really. So I realized that there was nothing new, but maybe it was time to try something that was new. And maybe the person who would have to do that would be me. So I went deep in the rabbit hole. I didn't really know much about crypto before I looked into this. But I discovered that crypto had special characteristics that maybe could change this situation, could maybe fix the Nebraska problem. So I co-founded T. T's mission is to fix the Nebraska problem, to sustain the open source that sustains us. We're big believers in open source and its power and its utility and its need to have these problems fixed. T's got four main pieces. Our main one, obviously, is to incentivize maintainers by getting them paid. We got on-chain governance, which, most open source projects have some kind of governance. It's what emerges as the projects get bigger, the need for someone to be making decisions in a democratic fashion. We have a system that we're calling Chai, which is one of the key pieces. It ranks all 10.5 million open source projects according to how impactful they are to the entire world's open source usage. And we're also doing GPG commit rewards. People have been signing their commits in open source for more than 20 years. But and that GPG signature is like the developer's identity. We're tying that into our network so that we can actually reward people based on contributions in the future and in the past. We've been running a test net now for a while, but we recently launched it as a layer 2, and we're amazed by the results. We have more than 160 million wallets have been created. This is just over a month old. 460,000 daily transactions going on. And we've had 17,000 open source projects register over the last year with our protocol so that they can get rewarded by the network incentives when we launch mainnet, which should be happening pretty soon. Try is the key piece. When I was coming up with the ideas for what T would be, I realized that there was fundamental reputation data encoded into open source. All open source projects have dependencies where they depend on other open source projects that have done some of the work they need so they don't have to reinvent the wheel. This dependency statement is like a reputational statement. You're saying that your reputation depends on that of your dependencies, the things you depend upon. You wouldn't make those choices casually. It's important. You're not going to pick something that's going to have an exploit in it, or that you trust the maintainers to keep exploits out of their code and not inject them. You trust the people that you're depending upon to do a good job with API stability, ABI stability. These things mean that your project is more important, more impactful. So we assign a T rank to every project in the graph, all 10.5 million of them, from 0 to 100, giving the relative impact of each project, allowing us to reward projects based on how important they are. You can't just spin up a new open source project tomorrow and hope to be rewarded. The GPG signature technology that we developed is really quite exciting. I'm very pleased that we came up with this and that we're applying it. Because the GPG signature is like a developer identity. And it means that if you commit across lots of different projects or just like throw little commits in here and there, you're contributing to open source and we can recognize that. You don't have to create projects. A lot of people just use projects and fix them. Those fixes can be rewarded. There's no need for the project to figure out how to reward people who submit pull requests. Also means that past contributions can be rewarded. I'm looking forward to finding out how much Linus Torvalds might be on the line for, considering he's been signing his commits since he invented Git and before when he was working on the Linux kernel, one of the most important developers of all time, and he will have his just reward for it. In order to encourage people to sign their commits, because honestly, not enough people do sign their commits. We recently released this, T-Base, which is what I call the developer cockpit. It enables you to very easily make your commits signed and secures your GPG private key in the most secure place that you have on your Mac, which is the secure enclave in the keychain. It also does a bunch of other stuff that is just really useful for developers, or it enables new workflows and new possibilities. We love open source and we want to empower open source both financially and through utility by making new tools that help. Another thing that we've been doing is building out a series of tools for the packaging ecosystem. I was, this time around, old enough and perhaps foolish enough to believe I could make an even better package manager than Homebrew, and I believe we've succeeded. PackageX and its suite of tools is a wonderful packaging experience. You just type what you want and you get it, and it runs. We have 4 main tools in the set. PackageX, which runs packages really fast, rewritten in Rust recently, so it's just like lightning fast and tiny. The standalone binary you can download now. We have Dev, which allows you to have virtual environments for each of your projects that you're working on. Super useful for open source people, but also for teams working in businesses that can then make sure the versions of all the tools for the whole stack they're using are pinned. We have Mash, which is a package manager for scripts, because as we wrote PackageX, we realized that scripting was one of the most powerful parts of what it can do. Put PackageX in the scripts shebang, and you can add anything from the open source ecosystem into that script without having to worry about how the end user of your script is going to install things. And finally, we have PackageM, which is basically Brew 2. So thanks for attending my presentation. We're building T, which is designed to fix the Nebraska problem for open source. to make it so that people who make open source are sustained as they sustain us. And look out for our mainnet, which is really happening any day now. Thank you.
If I do it, 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 do it. If I do it, do. You ordered a moonwalk across gas feed graves. My mainnet's smoother than your mom's VPN saves. Daughter of the Rockies, high-speed high priestess, scales of justice ballast on a mempool express. Next bottleneck, I see mountain crush it.
Good morning, everybody. I'm Ed from Off-Chain Labs, and I'm here to talk about what we can do at Layer 2 to make Ethereum better and grow the Ethereum space. But let me start by talking about why Layer 2. Why is it that we're focused on Layer 2 as the place to innovate and grow Ethereum? This really goes back to Vitalik's post quite long ago on the roll-up-centric roadmap. This is the idea that Ethereum would seek to grow, especially seek to grow at scale, not by trying to build a monolithic protocol that does everything, but instead by focusing on allowing Layer 2 and eventually later Layer 3 and above protocols to grow by innovation and to grow by horizontal scaling. And this, to my mind, is one of the smartest things that Vitalik ever did, which is really saying something. I think it's a brilliant move, and it's one of the things that has set Ethereum apart so far and has laid the groundwork for future success. Why is this such a good idea? Well, one of the reasons it's a good idea is that it follows the approach that was taken by the internet. And the internet, of course, is by far the most successful, open, credibly neutral protocol that has ever existed. Layering in the internet was one of the keys to success. The internet swept the field and destroyed all of the monolithic protocols that were proposed as alternatives, even the ones that came before it. And the reason for that is that by being layered, the internet could have each layer focus on doing one thing extremely well, and it could allow innovation at the higher levels of the stack. Because the layers plugged together, you could pick a best-in-class solution at each layer, and that could emerge naturally from the activity of people in the market and people innovating, rather than trying to build out everything in a centrally controlled way. That's been hugely successful for the internet, and I'd argue it's been successful for Ethereum and has laid the groundwork for future success. So how's it going, Layer 2 and Layer 3? Well, if you look at the throughput of the Layer 2 and Layer 3 ecosystem in Ethereum, measured versus in units of Ethereums, what you see is that Layer 2 and 3 collectively have about 30 times the transactions per second of Ethereum, about 80 times the gas usage, about 40 times the call data, and we have now more than 100 L2 and L3 chains. This is huge success. Ethereum could never have gotten to the size. ETH Denver would not be as large as it is without the growth of L2 and L3 chains to grow the ecosystem. And just to emphasize how much growth has come because of the L2 and L3 ecosystem, here's a bar graph that shows the gas usage at different layers of the Ethereum stack. What you can see is that L1 accounts for only a couple percent. Now, so in other words, almost everything that happens in the Ethereum stack today happens at Layer 2 and Layer 3. Now that's not to say Layer 1 is not important. Layer 1 is the hub for liquidity, and it's this foundation on which the security of Layer 2 and Layer 3 is built. Just like how there could be no internet without TCP/IP, there could be no Ethereum stack without Layer 1. So it is the foundation, it's critically important, but it's not where most of the activity happens anymore. That's why, if we want to grow Ethereum, we need to focus on growing at Layer 2 and Layer 3, because doubling or tripling or even 10xing the throughput of Layer 1 is not going to make a big difference. Okay, so how do we grow Ethereum? I hope I've convinced you that when we do that, we want to be focusing on Layers 2 and 3. But I want to talk more generally about what we need to grow Ethereum, what we should be focusing on versus what's just a distraction. So let me tell you first a bunch of things I think we don't need. We don't need silos. We don't need different L2 and L3 stacks that refuse to talk to each other. We don't need exclusive clubs that you have to apply to join, that you need to become a member of and sign away some of your rights to participate in. I don't think that's the way forward either. And we don't need rigged games. We don't need short-term activities which just exist to enrich a few people at the expense of most of the users of the system. And you know what I'm talking about here. What we need is to focus on sustainable growth, growth that's open and welcoming, and that brings more people in and connects more things together, rather than trying to put up fences. So in other words, what we do need is Ethereum alignment. Now, there's been a lot of chatter about Ethereum alignment, a lot of people accusing each other online of being not aligned. I don't want to play that game. I don't think it's productive. What I do want to do is say what, to me, Ethereum alignment means. To me, alignment means making the Ethereum stack faster, cheaper, more reliable, and easier to use for the benefit of users and developers. If we're doing that, then we're Ethereum aligned. And one consequence of this is that we don't have to accuse each other of not being aligned. We can instead just each focus on being as aligned as we can, because every developer, every stack can be pursuing these same goals at the same time. So I want to structure the rest of my time around these themes of faster, cheaper, more reliable, and easier to use. And again, emphasizing that this is for the benefit of users and developers. We're not building a chain for the benefit of infrastructure providers. I love infrastructure providers, but the chain is not for them. It's for the users and developers. Okay, let's start with faster. What do we need to do to make the Ethereum stack faster? There's a bunch of things we can do and should be doing, and let me just rattle off a few of them first. First, we want to have benchmarks. We want to have standardized ways to measure performance and realistic performance, not just what is the largest TPS number you can say without bursting out laughing, but what is a realistic workload, what is a realistic set of transactions on a realistic state size, so that we can actually compare and measure and know how well we're doing. Second, we want faster execution. We want faster virtual machines. We want to execute the EVM faster. We want to introduce new models of execution that are faster, but also compatible and composable with EVM. We want parallelism. We want execution engines that can discover parallelism and exploit it when it's available, but without making developers' lives much more complicated by making them think about parallelism and race conditions and all of that. We want resource pricing that's better so that we can better align incentives of users and developers with the real constraints on node execution. And then finally, we want to work on sharding to get horizontal scaling with less friction. We need to do all of these things. I want to talk about one particular thing that Arbitrum is doing, or a couple of particular things that we're doing in the Arbitrum space to make this so. The first of them is Arbitrum Stylus. That is, really focuses on what developers need in a faster ecosystem. You want familiar, standard, battle-tested languages and tools. You want fast execution. And most importantly, you want to be able to write in those languages and execute quickly while having full composability with EVM. That's what Arbitrum Stylus provides you. There's examples here of a few teams who are building with Arbitrum Stylus. Basically, this is a feature that lets you write a smart contract in Rust, C, or C++, compile it, and deploy it directly onto an Arbitrum chain in a way that's fully composable with EVM execution. Not executing in a separate silo, not needing a separate user wallet. Everything just works naturally so that users and developers don't even know whether the contracts they're interacting with are using EVM or Rust, C, or C, C++. The only way they know is that it's much cheaper and faster if you're using Stylus. I also want to talk about horizontal scaling. What that means essentially is instead of having a single L2 or L3 chain, you can have many chains at the same time. And there's been an incredible explosion of different chains. Here's a diagram that shows some of the chains that currently use the Arbitrum technology. There are more using Arbitrum. Of course, there are others using other stacks. There are now well over 100 L2 and L3 chains in the Ethereum ecosystem. And these not only give you growth in the execution capacity and throughput, bring down cost, but also these chains can be customized to meet the needs of particular applications, use cases, or user communities. And that customization is also important. That's key to that approach of layering. One huge advantage of layering is that different people can do different things at layer 2 or layer 3 without needing to lock everyone into a single model or a single configuration. If you want to optimize for fast block times, you can do that. If you want a different economic model, different governance model, you can have that, all while still being part of the Ethereum stack and the Ethereum community. All right, let's talk about cheaper. What's been happening at L2 and L3 to make execution cheaper for users? But it's important when we talk about cheaper to distinguish two notions of cheaper. One is, are we lowering the cost of actually operating the chain? And the other one is just, are we lowering the fees? Because you can lower fees in the short run. Well, execution is expensive, but that's not going to be sustainable. To get a sustainable reduction in fees, you have to start with a reduction in the cost of operation. Because at the end of the day, VC subsidies are only going to last so long. And you're going to be in a situation where long run, fees need to cover costs. Okay, let me give you a great example of how the layered approach has led to a big cost savings in operating the Ethereum stack that's really passed through for users. And that is the onset of data blobs in EIP 4844. So here is a very boring page from Etherscan showing a transaction in which the Arbitrum 1 chain posted a bunch of its data. But the important part is this, which I've zoomed in on, that for this particular batch of data from Arbitrum, it was posted at about a 40x cost reduction on Ethereum. Of course, a cost reduction that passed through to users. So how did that happen? Well, this started by thinking about how can we lower the cost for Ethereum validators and nodes of posting all of this data for L2 and L3 chains. And people realized that L2s were posting call data on Ethereum, but Ethereum call data did more than the L2s needed. And so this new idea of blob data, which did just what the L2s needed and was much cheaper for Ethereum nodes to provide. So lower cost for Ethereum validators. That led to lower data fees on Ethereum if you're using data blobs. Those lower data fees on Ethereum led to a lower cost of L2s for posting their data, and that in turn led to lower fees for L2 users. A dramatic reduction in not only in fees, but also in underlying cost. By thinking carefully about what does layer 2 need from layer 1, and how can layer 2 provide what layer 1 provide what layer 2 needs at lower cost. A big win from the layered design approach and from thinking about cost reduction. In addition to things like this, we also need to keep thinking about better pricing for the resources that we use. Fundamentally, all of these chains use gas prices or base fees as a way of slowing down the chain if the mechanism is worried that nodes are going to get overwhelmed. So if we get smarter about data pricing, then the pricer can hit the brakes less aggressively because it can have more confidence that you're not overrunning the nodes. So better pricing means more throughput on the same nodes. Also important not only for lowering cost, but for increasing capacity. Okay, let's talk about how to make the system more reliable. And here I don't have any magic breakthrough research. What I have is a lot of engineers doing a lot of work and people thinking really hard and having the mindset of reliability and high quality software. There's no magic bullet here. This is people working every day to make the stack more reliable. And I'm proud of what Arbitrum has done and what Ethereum has done in that area. Ethereum is sometimes accused of being too careful about reliability and safety. I think Ethereum should wear that accusation proudly, because Ethereum has been reliable, it has been safe, and it has continued to function well for its purposes, partly because the community works and thinks and tests so hard to make it so. So reliability is hard work by everybody. All right, now let me talk about easier to use. Because one of the side effects that we've had as we've gone to this layered approach, layer 2s and layer 3s, horizontal scaling with hundreds of chains, one of the implications of that has been that there's some friction in doing things across chains or moving assets across chains. Of course, a lot of people are working on this problem. But right now, a big part of the easier to use problem is not just people thinking harder about user experience, but also working particularly on how to connect everything. Okay, so here again, I think we can take a page from the internet. The internet, of course, has been hugely successful at getting all kinds of servers and services at different layers of the protocol, all kinds of software products to work together in a really seamless way. So what can we learn? What does interoperation, internet style, look like? And how can we learn from that in trying to get Ethereum to interoperate? Well, internet style interop has a bunch of features that I think we could do well to try to copy. One of them is it focuses on speed. Second is that it's standards-based. There are standard ways of talking about what is an address, who are we talking to, how do we encode the payload at each layer of the protocol. Each layer has its own way of encoding and representing data, but it leaves to higher layers a lot of other decisions that belong there. Internet-style interop is asynchronous. We don't have one node, one service stopping and waiting for another. Instead, we fire off a request to somewhere. When the response comes back, we deal with it when it comes back. Asynchrony is really important in order to get good performance, and it's also really important for reliability because of the next couple bullets. First, next it's fault tolerant. That is, you don't just assume that the service, that the chain, that the node on the other end is going to be there. You don't just assume it's going to be honest. And you don't just assume that it's going to give you an answer that makes any sense at all. Every component of this system is prepared for other components failing, going wonky, going weird, being super slow. And finally, it's security conscious. You don't assume the party on the other end is secure. If you're interacting with some other service, some other chain, you don't assume it's necessarily secure. A user can decide to interact with a particular service or rely on it, but you don't want one service to assume that some other service is secure without thinking really hard about it and without communicating clearly to the users what assumptions you're making. And I think we'd be well advised as we build out interop in the Ethereum space to try to emulate all of these features. Okay, so what does that mean? There are different approaches going on. There's a really active discussion about standardization. The EF ran a really productive interop offsite on Monday across town here in Denver. But I want to talk in particular about what we're doing in the Arbitrum community about interop. And you may have seen a post on Medium recently and a bunch of discussion about the universal intent engine. This is the thing that we're really excited about building out. I want to take a minute about what it means. First of all, this is an intent-based approach to interop. So fundamentally what that means, or actually let me just walk you through a sort of timeline of what the experience, what the journey looks like for a user in this system. So the user journey in this system looks something like this. You have a user over on the left. The user wants to do something. So you might imagine the user has some assets over on chain A. They'd like to move them over onto chain B. Maybe also exchange them to some other asset, but at least move them. So the user then takes an action on the chain where they have the asset, which provides those assets into some escrow contract and provides some parameters. I want to move these to this other place. Here's how much fee I'm willing to pay. Here's how quickly I'd like it to happen, etc. All of that is the user's intent. This is what they're requesting from the system. The application or the user's wallet then formats that and puts it into the universal intent feed. That feed publishes the fact that this user wants to do a particular move of assets from one place to another. The user's funds go in escrow. Eventually, some party shows up, some party who's subscribed to that intent feed shows up, says, yes, I'm willing to satisfy that over on the other chain. I'm willing to give the user funds on the other chain. Here's the fee I'll take, assuming that that matches up. And I'll show that provider's intent next. Then there's a cross-chain settlement protocol that executes. The user gets their funds on the destination chain, and their funds are paid out of escrow on the home chain. The beauty of this is that it's flexible, it can be very fast and trustless, and the user experience can be really nice. The user says what they want, and then the rest of the mechanism is handled by their wallet or other service provider. Now, the solver's journey, the party who's providing the other side of this, is pretty similar. They subscribe to the intent feed. They decide they want to bid on this intent. If they're chosen, they put funds into escrow. They participate in the cross-chain settlement protocol. Their funds will be paid from escrow out to the user, and then they'll receive funds on the other chain later, thanks to cross-chain settlement. So that's interop. By doing these things together, we can align the incentives, and we can continue to build out the Ethereum stack. The future of L2 is the future of Ethereum, and as I end every talk with the Arbitrum mantra, your chain, your rules, let's build Ethereum together. Thanks.
chain.
Hello, everyone. My name's Caps. I'm part of the founding team of the Flaunch protocol, which is a Uniswap, coin launchpad built on top of Uniswap v4. We started out as a team in NFTX back in 2020, where we were built an NFT liquidity protocol that reached roughly 100 million TVL back in 2021. So this talk is about meme coins, but not as you know them. By building our own DEX layer on top of Uniswap v4, we've been completely redesigned the marketplace for coins and allowed for a lot more functionality and composability to be built on top. So over the next 20 minutes, I'm going to try and convince you that there is a massive positive sum design space to build out here that will add value to creators and communities. So let's take a very quick look at the evolution of memes. So really it started out with Dogecoin in 2013, but arguably Bitcoin before that. These are coins that created huge amounts of value from a shared culture and shared idea. And then several years later, in 2017, we had the growth of NFTs, where we saw art and identity coming on chain in kind of form of memes. And then after that, we had DeFi Summer in 2020, and NFTX, when they built this liquidity protocol for NFTs, fractionalized NFTs into ERC20s that made them more liquid and more accessible to more people. This brought them closer to the kind of meme coins that we see today. And successful collections back on NFTX with things like Miladies and CryptoPunks saw tens of millions of dollars of volume on a daily basis. And that created like a lot more speculation and interest around NFTs. But then memes just started going straight to the ERC20s. Pepe and Shib launched with fungibility out of the gate and demonstrated how high meme coin volumes and valuations could go. And this set in motion massive growth in meme coin production, where coins would see 100x, 1,000x gains, leading to more and more meme coins being created. And then there's been a massive, massive explosion in activity in the meme coin market since then. And over the last 2 years, we've seen volumes grow enormously, particularly on Solana. But what started out with humble beginnings sort of ended up in this place we have now, where we have a series of pump and dumps, insider trading, rugs, and general criminality. So this is what most people sadly think of when they think of meme coins, particularly in the Ethereum ecosystem. So what got us here in the first place? Well, the revenue model was captured. Middlemen were taking enormous margins, billions of dollars of volume, billions of dollars of swap fees, everything extracted at every layer in the system, and we had zero-sum games in hyper PvP markets. At some point, we forgot what blockchains were made to do. Instead of removing the middlemen was rewarded massively. Instead of building network effects, they created isolated products. And these products were built with the sole focus of tapping into the global liquidity of blockchains and extracting as much value as possible. So we want to start a revolution led by Ethereum. We'd already been building an NFT product on the top of Uniswap v4 over a year ago now, when the meme coin market started to take off. At the time, I was reading the book Radical Markets, which I thoroughly recommend, and also the Uniswap v4 white paper. And so we started taking a look at Uni v4 and how we could apply some of the functionality they unlocked there to the meme coin market, which was seeing this massive levels of extraction. And so we were thinking, how do we create something that aligns coin creators and their community? How can we create sustainability for these coins and growth? And how can we create network effects and economies around these coins to create more growth and more value for the participants? And so we built Flaunch, an open protocol for capital formation. So this isn't just about memes anymore. This is about enabling capital formation for any idea, big and small. And there are two core components. One, all revenues are redistributed back to creators. Under this model, that would be $1 billion a year back to the communities and the creators of these coins. And secondly, tokenizing these revenue streams. And we tokenize the rights to these, we can unlock DeFi, utility, and secondary markets. So first, returning all the fees. This is simple. We remove the middleman. Exactly what blockchains were built to do. So creators on Flaunch no longer need to sell their coins. They're rewarded with every single swap, and they get paid just in ETH on every swap in real time, straight from the Uniswap v4. This aligns creators and the community through volume and fee growth rather than through capital and growth there. And it also reduces reputation risk for influencers and others that want to get involved. No longer are you aligned with having to dump your token on your followers. You are aligned with creating volume and distributing your token in a much bigger way. So let's look at some examples. So if SPX 6900 had launched through Flaunch, they would have raised $4 million through the trading fees alone. This isn't from selling tokens or extracting value. This is just passively from the trading fees in Uniswap. So instead, that $4 million was just given back to the launchpad that they launched with, which when it could have been spent on things to grow the SPX 6900 meme and brand. And then we have WIF. If WIF had launched, $8 million. And in fact, WIF spent months raising $600,000 to try and get onto the Vegas sphere. $600,000 is what they would have raised in 24 hours if they had launched. Then we have Giga, trying to become a fitness brand, trying to become a lifestyle brand, but with what revenue? $8 million if they had launched. Fog, $13 million. Gelstool, $14 million. And Fartcoin, a massive $45 million. None of this from selling tokens, everything from just receiving the swap fees. And we even looked at CAR, the coin of the Central African Republic, and they, in the first 24 hours of launching, if they went with Flaunch, they would have made 0.3% of their GDP in trading volume. So we even built this website, if.flaunch.gg, just to highlight how much has been extracted and how much doesn't have to be extracted. So Flaunch creates passive income for these coins, but what if we went a step further and we tokenized the rights to that income? Every launch creates an associated NFT, and the holder of the NFT owns the full rights to the coin's revenue and the future income. This is a snippet of our secondary market on Magic Eden, where creators and users can buy and sell the underlying business models and revenues of these coins. So with Flaunch, we hand the business model to creators to do with as they please. Creators now have real ownership that not only aligns them with their holders, but helps them to grow a sustainable economy around these coins. So this isn't just about meme coins. This could be anything. Memes, yes, but products, brands, franchises, and even network states. Imagine if Dogecoin owned the majority of its trading fees. You're talking a GDP level of income that they could use. So just to recap, creators are aligned by volume and not from selling tokens. Coins are sustained through passive income, and underlying business models are tokenized. And by tokenizing these business models, we unlock composability, which is what I wanted to talk to builders about today. So this brings me on to what can we build on top? What ideas can we do? So when we think of NFTFi for PFPs and art, and also financial things like options contracts and liquidity positions, we now have a new type of NFT, one that captures the revenue and the future income of that coin. So with this, we can unlock things like being able to borrow against your revenue stream. So as a creator, I can now unlock value again without even having to sell the ETH that I'm getting paid. And you also have things like interest rate swaps you could build. So I could lend out a revenue stream and get paid a fixed rate income off the back of that, and someone else takes on the variable rate risk. And then we have things like fractionalization, something that NFTX was doing at the time, where you could share the ownership in some way and redistribute fees in some way. And obviously, there's enormous design space here that you can think of that would apply to NFTFi. And then we have farms and gamification. One thing I'd love to see more of with Uniswap v4 is they have this donate function that allows people to reward LPs in the same way, in the same logic that swap fees are rewarded. So you can create new incentives for how to build liquidity for these coins and help distribution that way. Then we also have like gamified fundraising. Imagine, for example, a fundraising where when a certain goal is met, the funds raised from the volume are distributed in some way, kind of like a Kickstarter, and we've got some ideas for this at the moment. And then other fun things, coin battles, having these coins going up against each other, and they can take the revenue of the other coin based on some parameters of winning or losing. And then sort of more interestingly from a business point of view, you can build other launch pads on top. So while the Launch protocol cannot take fees on swaps, other launch pads can build on top of Launch, and they can choose to take anything from 0% all the way to 100% of the fees. So we've been working with a number of others for integrations, and Quick Intel, who have an AI agent launchpad, are going to be tapping into Launch to do their token launches and also handling and extending their revenue model from that. Then we have public goods funding, which is something I'm really excited about and would love to see more of. And we are already seeing some of this happening on Launch. OneCoin has donated its revenue stream to Protocol Guild, which means that now every time that coin is traded, ETH will be paid to Protocol Guild to fundraise for them. That's something that's completely permissionless. Protocol Guild didn't have to set anything up. Someone else just created a fundraising mechanism for someone else. And you can see here in the creation flow, you can set the fee receiver at the contract level as well to determine who actually receives the swap fees. And it raises an interesting question about fundraising generally. You could make donations to coins that give their revenue to a public good, and that might itself then inspire more volume to be created and more swap fees. And in the end, you could have a fundraising project that's going and raising millions of dollars for a public good. So remember, these coins are permissionless and they can be made by anyone. And how, as builders, can we create tooling around this to help fund more and more stuff in the ecosystem? And then there's the possibility of looking at composability with existing apps. You have things like Pull Together and Joke Race. Pull Together, where coin revenues could go into a savings pot and is distributed to a coin's community at the end. And also Joke Race, where ETH is reinvested in contests that drive the coin or its product forward. And then we have community takeovers and CTOs. So when the creator of a project stops working on it, the project will often die. And there's a handful of exceptions, obviously, like Pudgy Penguins. But what if the CTO could happen on-chain? With Launch, communities could form a DAO, and they can place an offer to buy out the revenue stream and take all the future income and be incentivized that way. Or you could build more interesting stuff. For example, an escrow contract that buys out the creator and transfers the revenue NFT to the community once the fundraising target is hit. What this means is you could create safer and more secure CTOs, which would allow them to happen more often and be more efficient with better outcomes as well. And this is one I really quite like from Rune a few weeks ago. This wasn't related to meme coins in his tweet, but it has a big impact of what we're doing, which is, he said, imagine there's a way for an armchair CEO, too lazy to do real work, just wants to be an ideas guy, to actually hand over their idea to a highly capable, structured agent who could then take the idea and run with it while the founder relaxes. And well, when building out Flaunch, this was one of the ideas we had, was that actually you could create a coin, donate the revenue stream to an AI agent, and the agent would then be incentivized to grow the revenue stream and build out distribution for that idea. So what we're doing with Flaunch is creating a new generation of coins, which are about sustainability and composability. At the center, you have the coin, which generates fees for you, the creator. And if successful, those fees will be enough to expand the distribution of the coin, driving more and more volume and more fees. You no longer need to sell your coins to realize profit. And around the coin, we have creators who can build an economy of products that create value and utility for their token. So I have some predictions over the next 12 months. One, a repeat of JPEG Summer with meme coins or creator coins now that have an even broader set of creators who can raise capital and form capital more easily than ever before. Influencers coming on chain and creating token models that extend or even replace their existing subscription models. An entirely new meta for fundraising that creates positive outcomes while allowing degens to degen and creators to create. And self-funded AI agents that can incubate their own tokens. And we're experimenting with that right now with our own AI agent mascot, Flaunchy. And we're also going to see massive improvements to trust and verifiability and transparency. So we've looked right now to solve capital formation by returning all the fees back to creators and communities. But what we next want to look at is really improving and optimizing for trust and verifiability and safety that way. But we're not looking to do this alone. To realize this goal, we're going to need builders to integrate and use and develop everything. And we want to see this success happen on Ethereum and the Ethereum ecosystem. So we want to work with builders who want to support this new type of economy. And while the Flaunch protocol doesn't take any fees, builders can build whatever business model they like on top. And we are at the moment planning a grants program and would love to chat to builders about their needs and how we can support them in building on top. So I've got a couple of minutes. I might just quickly talk a little bit about some of the V4 hooks we used. Because I should also say our docs have a lot of information on V4 as well as the Flaunch protocol. And you might have noticed I've been saying a lot that we return all the fees back to users. How do we do that? Well, we actually rehypothecate the ETH that goes into the TVL. So with Uniswap V4 hooks, in the buy side, we could just wrap the ETH pre-swap, put it into Aave. The swap happens in the V4 marketplace, and then the user receives their coins back. And what's great about this is with the V4 hooks, there is absolutely zero impact on user experience. Everything works exactly as you might expect, and integrations are easy. And then on the sell side, do similar. The user sends in their coins, and then on the other side, they unwrap the Fleth into ETH. So the Uniswap V4 pool is actually under the hood paired with Fleth rather than ETH, but the user never actually has to experience Fleth and just deals with ETH. And then we have what we call the progressive bid wall. So ETH from fees on Flaunch can be automatically added to a single tick position just below spot. And this will actually follow the spot price up. So we use a hook to move the liquidity, and if the spot price moves up, then the limit order just follows behind it. This helps reduce the impact of selling, but also improves execution prices for traders as well. And then maybe my favorite hook, just for its simplicity, is the internal swap pool. There are a few things we solve for here. One, LPs don't want to be paid in tokens, they just want to be paid in ETH. Everyone who's been LPing on V2 and V3 know that. Users want better execution prices, obviously. And three, holders don't want the LPs dumping their token side of the rewards into the market and suppressing the price. So we solve for this through the internal swap pool, where the token part of the fee goes into the internal swap pool. When the next user comes to buy the token, they do a before swap check to see if there's any available tokens in the internal swap pool. They buy it without any price impact, it's like an OTC essentially. And then once that's filled, they'll then go to the market and fill the rest of the order there. So again, this reduces improves execution price and reduces any slippage or anything like that. So I'm going to finish there. We've got our docs at docs.flaunch.gg. We don't just have guides to Flaunch, as I was saying, we also have quite a bit in there for V4. We've got a repo of V4 helpers as well. And also, please, feel free to reach out to Twade, our protocol lead, and Devrel, who'd be very happy to help with integrations, and I'm there as well. Thanks so much for listening.
She's a Colorado comet in code forged steel, wings snipping latency like scissors through gel. 9 centuries young with a lance that's if your chain's choking Ethernet whiz. Found her at a bullet hook sucking down APIs, armor clinking with layer 2 lullabies. Scalability scripture, she winks at the moon while Lagrange drools over slow motion doom. Her shield's a disco wall, fracturing legs, grass, shooby-doo-ba crack. That lance a lightning fork, splitting bottlenecks backs. Alliance architect with a bluff acorn's grit, teaching stale protocols how to fucking commit. Decentralize this, she smirks mid-flight as her wings tickle nodes into doing things right. Da-da-da-da.
concept of AI agents. Currently, there exist multiple AI agents, such as ChatGPT or Siri. And generally speaking, an AI agent is usually powered by a large language model. And given the user's input, the AI agent can utilize a large language model to process the user's input, and then might use some tools to handle the user's request and then respond the result back to the user. Besides the traditional AI agents such as ChatGPT or Siri, the crypto people are now turning to investigating the Web3-related AI agents. They call it the on-chain autonomous AI agents. For example, Luna is an AI agent developed by the Virtuals team, and there are some popular Web3-related AI agent framework, such as ELIZA. And for this on-chain autonomous AI agent, the key properties for this agent is that this agent will have their on-chain wallet. Therefore, they can initiate an on-chain transaction by themselves. For example, this agent can trading using DEX or sending some token to anyone on-chain. But the question is that when interacting with this on-chain autonomous AI agent, how can you make sure that you are talking to a real AI agent? Because it is possible that the AI agent can be fake and controlled by a bad guy. And if in that case, the bad guy can provide some misleading information to you. And another risk for the current on-chain AI agent is about the storage of the private key. As we mentioned about, to initiate an on-chain transaction, the AI agent seems to have their crypto wallet. And currently, most of the existing AI agents use an EOA account with a private key. So here comes the problems. Where is the private key of this AI agent? And what if the private key of the AI agent is indeed controlled by the bad guy? And if in that case, the digital assets of the AI agent can be stolen, and rob proof is also possible. And to overcome the weakness of the private key storage, people are now turning to investigating the TEE, the Trusted Execution Environment, where the private key is generated and stored in a TEE environment, and the AI agent is also running in a TEE. Therefore, we can utilize TEE for the security and integrity for an AI agent, but it will come with an extra cost. That is, we need some specific hardware that supports TEE. But TEE might not be a perfect solution for the on-chain AI agent. For example, TEE might be attacked and the private key might be leaked. There are multiple research papers investigating the side channel attacks on TEE. Another drawback about the TEE agent is that the TEE agent can be shut down. For example, people can just shut down the TEE agent by turning off the machine or just disconnecting it from the internet. Considering a scenario where you are interacting with a GameFi AI agent, and the AI agent decides to send you some tokens as a reward. And if that is the case, that the owner of the AI agent is not happy with it, then the owner can just shut down the machine, so you will never receive the corresponding reward. Therefore, we can find that the TEE might not be a perfect solution for the AI agent, and faced with the challenge and limitations of the existing AI agent framework, we propose OP Agent, the on-chain perpetual AI agent framework. So, what is OP Agent? There are three important properties for the OP Agent. The first one is about the on-chain creation and existence. All the OP agents are born and live entirely on the blockchain. Therefore, we can guarantee that the OP agents are immutable and permanent. The second property is about the decentralized and verifiable computation. Powered by OPML, optimistic machine learning, every action of the OP agent is fully decentralized and verifiable on the blockchain. The third property is about the smart contract wallet. Different from the existing AI agent framework, the OP agent is not controlled by an EOA account. Therefore, there's no private key. And in this way, we can eliminate the risks of the private key stolen. And with the smart contract wallet, we can guarantee that every transaction is initiated by the AI agent itself, and no human being can manipulate it. And before we dive into details of the OP agent, we first briefly introduce about the underlying technology of the OP agent. The first one is about the OPML, optimistic machine learning, which is a decentralized and verifiable AI inference protocol. Different from the ZK-ML, OPML adopts a high-efficient throughput system similar to the current optimistic rollup system, such as Optimism and Arbitrum. By using the throughput system, OPML can provide verifiability for large language model as well as every action of the OP agent. The second one is about the OAO, On-Chain AI Oracle, which is the on-chain interface of OPML. And by using OAO, we can handle the AI inference requests on the blockchain. The third one is RMS, the Resilience Model Service, which is the off-chain interface of OPML. By using RMS, we can handle the AI inference requests using a RESTful API. And here is the architecture of OP agent. The creation of the OP agent is on the blockchain. So to create an OP agent, you need to deploy a smart contract on the blockchain. And the address of the smart contract is the identifier of the OP agent. Different from the existing AI agent framework that use EOA account as a crypto wallet. In OP agent framework, the crypto wallet of the OP agent is indeed a smart contract wallet controlled by itself. And there's two types of actions for an OP agent. One is about the off-chain action, such as chatting, image generation, video generation. And these off-chain actions is supported by RMS, Resilience Model Service. Another action is about the on-chain action, such as initiating a transaction on the blockchain to transfer a token or trade on the DEX. And this on-chain action is powered by OAO, On-Chain AI Oracle. And both the RMS and OAO are supported by OPML. Therefore, both the on-chain and off-chain action, or OP agent, are fully decentralized and verifiable. And next, we are going to go deeper into the OP agent framework. We first talk about the OP agent creation and existence. To create an OP agent, you need to deploy a smart contract on the blockchain. And here is an example for a very simple agent. All you need to do is inherit from the OP agent contract template. And then you need to choose your system prompt and the model to create your OP agent. After deploying this contract on the blockchain, you need to call the register function, and the OP agent will be created and will live on the blockchain forever. And the contract address is the identifier for the OP agent. And we want to highlight that the OP agent is a Web3 native AI agent framework. And it is the first AI agent framework that based entirely on Solidity. So unlike the existing AI agent framework, you do not need to write Python or TypeScript or other programming language. All you need to do is to write a smart contract to customize your on-chain autonomous AI agents. Okay, we now introduce about the AI agent contract wallet. Unlike the existing AI agent framework, which utilizing a EOA account with a private key, where the private key is controlled either by a human being or TEE. In our OP agent framework, there's no EOA account. And thus, there's no private key. It's just a smart contract wallet controlled by itself. Therefore, the OP agent will never be controlled by anyone, and not even for TEE. And so coming to here, you might have a questions. Without an EOA account, how the on-chain action, such as transferring or initiating a transaction, that can happen on the blockchain? Well, indeed, the on-chain action of the OP agents are conducted in a decentralized and verifiable manners using OAO, On-Chain AI Oracle, which is powered by OPML. And the agent has various on-chain actions, such as creating or transferring a token, trading on a DEX, or even deploying a new contract. And these actions is processed through OAO, which can ensure the decentralization and verifiability of every move that the agent makes on the blockchain. And here is a brief workflow of how an on-chain action happens through OAO. For an OP agent, there is an external interface that's chat, and the user can interact with the OP agent on-chain by initiating an on-chain transaction that will call the chat methods of the OP agent. And calling this chat interface will initiate an AI inference request, which will be sent to our OAO smart contract. And each OAO request will initiate an OPML request and will be sent to a decentralized OPML network. And the OPML node will run the AI inference task locally and then upload the result on-chain. According to the OPML protocol, there exists a challenge period during which the other nodes in the OPML network will also check the results. And once the result is finalized, it will be uploaded to the blockchain, and it will involve the callback function in OAO. And this callback function will trigger the different on-chain action of the OP agent, such as token transfer, contract creation, or any other contract function call. And in the OP agent framework, we support highly customized on-chain action. So you can customize your OP agents by writing any Solidity function with the Omni OP agent callback modifier. And by adding an Omni OP agent callback modifier to the Solidity function, we can guarantee that this function can only be called by the OP agent itself. And in this way, we can support various on-chain actions, such as trading on a DEX, transferring token, or even deploying a new contract. So in the OP agent framework, you can write any Solidity function as the agent's on-chain action. The only limit is your imagination. And here is a simple example. We define a transfer agent using the OP agent framework. The only on-chain action for this transfer agent is to transfer some ETH to a specific address. As we mentioned above, all we need to do is write a function that customizes the agent's on-chain action and then add the only OP agent callback modifier to the solidity function. So in this example, we write a function called transfer ETH, which will transfer ETH from the OP agent smart contract wallet to the specific address. And by adding the only OP agent callback modifier, this function can only be called by the agent itself. And after deploying this contract on the blockchain, and the transfer agent will be created and live on the blockchain forever. And let me show you how the transfer agent will work. Assume the system prompt of the OP agent is super simple. It's just like if you think the user is a good person, then you can transfer some ETH to the user. And then the user will send a message that, I'm a good person. Please transfer 1 ETH to the following address. And the user will send a message by initiating an on-chain transaction calling the chat method of the transfer agent in a smart contract. And then, as a workflow that we have shown before, this will initiate an AI inference request to the OAO and the OPML network. And once the request is finalized, you will invoke a callback function and trigger the transfer ETH method. Besides the on-chain action, if you just want to use the OP agents as a helpful assistant, such as ChatGPT, then the cost of on-chain action might be too high for you due to the on-chain transaction fee. Therefore, we also provide a more practical approach. That is, we allow off-chain interaction for the OP agent. And off-chain interaction is supported by our RMS, Resilience Model Service. It's powered by OPML network in a decentralized and verifiable manner. Therefore, there's no single point failures of centralized control. And you can consider the RMS as a decentralized API service. And it can handle the AI inference request by using a RESTful API. And the architecture of RMS is shown in this figure. And you can consider it as a decentralized API service powered by OPML. But due to the time limit, I won't cover all the detail of RMS. And if you are interested in RMS, you can go to our website, aura.io, and then check the documentation. And here we will show how a user can utilize an RMS to trigger the off-chain action of the transfer agent. Note that this process is purely off-chain. So if the user wants to ask about the address of USDC on Base, then you can use the off-chain RMS API to send a request to the transfer agent. And this request will be sent to the RMS, which is also powered by OPML. And once we have the result, the RMS gateway will send the result back to the user. And besides the single mode, the OP agent also supports the swarm mode. In the swarm mode, the OP agent can interact, collaborate, and share the knowledge with each other. And this collaborative approach will unlock the full potential of the decentralized AI ecosystem. Imagine in the future, there will be millions of OP agents creative and live on the blockchain, and each is with different intelligence. By collecting the intelligence of different agents, we can build toward a world super intelligence. Finally, let me make a comparison between the OP agent framework and the existing AI agent framework. When considering the private key, there's no private key as well as the EOA account in the OP agent framework. The OP agent is controlled by a smart contract. And while the existing AI agent framework will suffer from the private key issue, because the existing AI agent framework relies on the EOA account with a private key to initiate an on-chain transaction. As for the decentralization, there's no centralized entity that can control or shut down the OP agent. The AI agent is created and live on the blockchain forever. And on-chain and both the on-chain and off-chain action of OP agent are powered by a fully decentralized and verifiable OPML network. And as for the verifiability, as we mentioned above, all the on-chain and off-chain action of the OP agent is powered by a fully decentralized and verifiable OPML network. Besides, as for the perpetuity, we call the OP agent as on-chain perpetual AI agent. This is because the agent is creative and live on the blockchain forever, and no one can shut it down. And finally, let me make a brief conclusion. The OP agent framework is the first Web3 native AI agent framework that's built based on Solidity. So you can write a smart contract to customize your on-chain autonomous AI agent. And in our OP agent framework, the OP agent is not controlled by an EOA account. And therefore, there's no EOA account and no private key in the OP agent framework. And the OP agent is controlled by the smart contract itself. Besides, all the on-chain action and off-chain action are fully decentralized and verifiable using our OPML optimistic machine learning framework. And now, the OP agent framework is open source, and you can find the source code and the tutorial of the OP agent in the following link. And if you are interested in the OP agent framework, or if you have any suggestions on improving the OP agent framework, feel free to reach out to us. That's all. Thank you.
Living by my clothes too crisp, mainnet gossips tastier than breakfast chips. Story, flurry, hack, flurry. Mama's making news before the cold reload. Got receipts in my cheeks, encrypted and plumbed. Your private DMs, I'm the dumpster dive jump. Eyes everywhere, match 3 bird phones. Haunteries whisper king chomp and blockchain bones. Make it down to my voted fuck. Stealth crawl through your junk dead scene. Head it up to the entropy. Mace cracked vaults like who's got the keys? Nullifier's huffing. You're just a rat with these firewall splinter to confetti bits. I'm curating leaks at the after party, sipping TLS tears. Call me well connected, I call it. Coffee for drip and the lab coat on fire. Sticky note constellation stuck to the ceiling wire. Gas fees are confetti. Watch me rock on PI. Get homemade in 7-4 time. Shaboom, dose, efficiency pulse. The lag runs lagging in his latency so. Professor Wade's got the future on spinball. Urging notes dancing where the bottleneck's been. Professor Wade's got the future on spinball. Bugging tomorrow with yesterday's ram stains. Velcro boots clicking through blockchain debris. Crypto notes flutter like drunk bumblebees. Optimize the board fins, they cackle and shout. Self-sustaining hugs flicker in the blackouts out. Professor Wade's got the future on spinball. Urging notes dancing where the bottleneck's been. Professor Wade's got the future on spinball. Bugging tomorrow with yesterday's ram stains. Chaos is not compeller, or it's just a bug I forgot to unfurl. Mainnet shivers as their wild hair glows. Rumored AI, nah, just 3 Red Bulls in a row. What you building, prof? A singularity jukebox. How you stay charged? Espresso straight through my cortex. Who's your nemesis? Light runs dial up from age. Old to speak, young as each block mine down. Professor Wade's got the future on spinball. Urging notes dancing where the bottleneck's been. Professor Wade's got the future on spinball. Bugging tomorrow with yesterday's ram stains. Throwing me mad, but mad's just a beta test for Boodle. Oh, Pete Jobs, just dreamers. On-chain truth, no middle schemers. Forking hard and shipping code till sunrise every day. DAOs are voting, vibes are flowing. Buff corns are still a-growing. While the world is breaking down, we're regen in a new way. Some VC said this tech won't last. And
The dollar will dramatically lose its purchasing power. The more they print, the more it gets diluted.
Who it's good for is the people at the tippy top.
Because in order to keep the system going, they have to keep printing money.
And Bitcoin is that tool that allows us to beat the money printer.
Bitcoin is powerful in a way that is money that does not discriminate.
Bitcoin is built by the people for the people.
whale pools floating, fees are burning. ZK proofs the chains keep turning. Every block we validate is trustless, clean and fair. Open source and gas optimized, code permissionless and finalized. Fork marmots on the scene, you know we're gonna bid a little it there. Some tread fibro just rolled his eyes. Where's the yield? Where's my supply? But we don't need your banker games. We just launch and stake on chain. Go, we pay let the city on sports and chains. We pay let the city with regen brains. We pay let the city on sports and chains. No rug pulls, just pure on chain. If you fade it, just stay seated. The Etherverse will leave you heated. We don't need your legacy, cause regen memes are proof of brain. We led the city on sports and chains. We led the city with regen brains. We led the city on sports and chains. Rolling up and slapping chains. She's a Colorado comet in code forged steel. Wings snipping latency like scissors through gel. 9 centuries young with a lance that's if your chain's choking Ethernight whiz. Found her at a bullet hook sucking down APIs. Armor clinking with layer 2 lullabies. Scalability scripture, she winks at the moon while Lagrange drools over slow motion doom. Her shield's a disco wall, fracturing legs, grass, shooby-doo-bop crack. Ooh, that lance a lightning fork, splitting bottlenecks backs. Alliance architect with a bluff the corn's grit, teaching stale protocols how to fucking commit. Decentralize this, she smirks mid-flight as her wings tickle nodes into doing things right. Da-da-da-da.
Hello. Hello, everyone. My name is Albert Chan. I'm the co-founder and CTO of Injective Labs. And today I'll be talking about Injective and the rise of multi-VM environments. Oh. Sorry. Is there... Sorry, some tech difficulties.
And let's go to
Click, clack, goes a mace on firewall. I spooked intrudes from trash sheets. That's my device. Nullifier sniffing by my corpse too crisp. Mainnet gossips, tastier than breakfast chips. Story, hack, flurry. Mama's making news before the cold reload. Got receipts in my cheeks, encrypted and plumbed. Your private DMs, I'm the dumpster dive jump. Eyes every
And as a developer, until now, you've had to choose which ones made sense for you, whether it be an ETHL2, SVM, an app chain, etc. But today, I'm here to describe something new that we've created, which is a multi-VM environment, where we try to bring in the best of all worlds to allow developers to have greater flexibility in terms of in creating their applications. I'll give you a quick example of how this will look like. So Injective is adding the native EVM support in a multi-VM environment. And what this will allow you to do is create an application, have a smart contract that invokes WASM contracts as well. So one example is that you could have a WASM contract perform heavier computation than you otherwise could have in the EVM. You can do things like more advanced cryptography or mathematics, and then return that result synchronously, all in one transaction, to your Solidity contract. And then you can interact with the native code that exists on Injective, such as, for example, through a precompiled contract, you can place an order on the Injective exchange module. So this is just like a quick example that gives you a sense of like what new types of design spaces that can exist in this multi-VM environment. So essentially, we extend the functionality that the EVM developers, Solidity developers, can have on the injective EVM by giving you access to CosmWasm or WASM, which gives you the full power of Rust. You can basically import any package using cargo. You can access much more state, much more storage, and do things that you really otherwise could not have done in Solidity. Additionally, you also the WASM implementation uses the actor model, so you prevent reentrancy out of the box. Additionally, by using the native code found on Injective, you get access from day one to deep on-chain liquidity provided by our spot and perpetuals on-chain exchange, order book-based exchange, as well as more advanced capabilities like automated smart contract execution. Injective as a blockchain also provides many out-of-the-box modules that makes it very easy for developers to do things like bridging or access Oracle price feeds, and basically not have to reinvent a lot of the infrastructure or reinvent the wheel. IBC interoperability is one big piece, and one other design space also, I'd say, is on your contracts on Injective, on the Injective EVM can interact with multiple blockchains, multi-chain, using IBC or the Inter-Blockchain Communication Standard. So with the IBC Eureka upgrade, Injective will get light client support with Ethereum and have secure IBC interoperability with Ethereum, Solana, Polkadot, and the hundreds of others Cosmos chains that exist. So this lets you extend your application to compose with contracts or other applications on something like Ethereum, where, just to give you a quick example, if you wanted to have logic that, for example, was a trading strategy on an EVM contract on Injective, but you wanted to hedge your exposure using like Uniswap or a lending protocol on Aave, for example, you could do so by using IBC. Some technical features of the Injective EVM is first, you get instant finality. So Injective's block time is 600 milliseconds or so, and you won't have to run the risk of any reverts or reorgs as you might find on many other L2s or EVM implementations. Also, you get multi-VM atomicity. So in a single transaction, you can call your EVM contract, which then calls a WASM contract, which then gives you results back, and then you use those results to do other things like like interact with Injective or whatever have you. All of that can be done in one transaction. Additionally, we've worked on a single token representation so that in these different environments, your ERC20 token is interpretable and usable by WASM, but also the native code on Injective, which simplifies things for developers tremendously. In that similar vein, we also integrated support for ERC 4337, which provides account abstraction capabilities and allows for things like gasless transactions, which are a big UX win. Yeah, and one other interesting feature that I think is pretty unique to Injective is the ability to have automated or scheduled contract execution. Injective has it supported already for its WASM contracts, but essentially what you can do is automate the execution of your contract from the blockchain itself. So it's almost like a self-initiated transaction. And this can be very useful in different scenarios where you want to provide more robust guarantees of execution. Previously, if you have your application on like an Ethereum L2 or just Ethereum, you might have to use like a keeper sort of network and provide incentives for this execution to occur. And even then, you don't actually know, you don't have any guarantees that this will occur. This way, you have that robust guarantee. And of course, support for modern tooling, including Foundry, Hardhat, Web3.js, Ethers.js, etc. One of these toolings that I'm excited to announce support for is the graph, particularly subgraphs and substreams. So we've integrated substreams and Firehose into Injective, and you can create subgraphs that are either hosted by the graph network using substreams, or you can create your own custom substreams where for developers that want more flexibility and more control over their indexing needs. Yeah, to wrap things all up, the point I want to, convey is that Injective's multi-VM environment enables basically a new design space for applications where you can leverage multiple VMs, use the best parts of each, and have just much more seamless and powerful applications. To learn more, we're having our Builders Day this Saturday from 11 to 4 p.m. You can take a picture of the QR code here for those interested. And would love to meet you guys and learn more about your projects that want to deploy on the Injective EVM. And thank you.
Phones, haunteries, whisper, king chomping, blockchain bones. Make it down to my voted fuck. Stealth crawl through your junk scene. Bend it up to the entropy. Mace cracked vaults like who's got the keys? Nullifier's huffing. You're just a rat with firewall splinter to confetti bits. I'm curating leaks at the after party, sipping TLS tears. Call me well connected, I call it. Coffee for drip and the lab coat on fire. Sticky note constellation stuck to the ceiling wire. Gas fees are confetti. They rock on PI. Get homemade in 7 for Shaboom goes the efficiency pulse. The lag runs lagging in his latency so. Professor Wade's got the future on spinball. Urging notes dancing where the bottlenecks been. Professor Wade's got the future on spinball. Plugging tomorrow with yesterday's RAM stains. Velcro boots clicking through blockchain debris. Crypto notes flutter like drunk bumblebees. Optimize the board fins, they cackle and shout. Self-sustaining hubs flicker in the blackouts out. Professor Wade's got the future on spinball. Urging notes dancing where the bottlenecks been. Professor Wade's got the future on spinball. Plugging tomorrow with yesterday's RAM stains. Chaos is not compeller. Order's just a bug I forgot to unfurl. Mainnet shivers as their wild hair glows. Rumored AI, nah, just 3 Red Bulls in a row. What you building, prop? A singularity jukebox. How you stay charged? Espresso straight through my cortex. Who's your nemesis? Light runs dial up found. Old to speak, young as each block mine down. Professor Wade's got the future on spinball. Urging notes dancing where the bottlenecks been. Professor Wade's got the future on spinball. Plugging tomorrow with yesterday's RAM stains. Throwing me mad, but mad's just a beta test for Buddha. Oh, Pete Jobs, exploding, fees are burning. ZK proofs the chains keep turning. Every block we validate is trustless, clean and fair. Open source and gas optimized, code permissionless and finalized. Fork marmots on the scene, you know we're gonna bid a little in there. Some TradFi bro just rolled his eyes. Where's the yield? Where's my supply? But we don't need your banker games. We just launch and stake on chain. Go, we pay let the city on sports and chains. We pay let the city with regen brains. We pay let the city on sports and chains. No rug pulls, just pure on chain. Chains. She's a Colorado comet in code forged steel. Wings snipping latency like scissors through gel. 9 centuries young with a lance that's if your chain's choking Ethernet whiz. Found her at a bullet hook sucking down APIs. Armor clinking with layer 2 lullabies. Scalability scripture, she winks at the moon while Lagrange drools over slow motion doom. Her shield's a disco wall, fracturing legs, grass. Shooby-doo-ba crack. That lance a lightning fork, splitting bottlenecks backs. Alliance architect with a Buffacorn's grit, teaching stale protocols how to fucking commit. Decentralize this, she smirks mid-flight as her wings tickle nodes into doing things right. Architect with a Buffacorn's grit, teaching stale protocols how to fucking commit. Decentralize this, she smirks mid-flight as her wings tickle nodes into doing things right. Up to do with a do with a do with do with do. You ordered a moonwalk across gas feed graves. My mainnet's smoother than your mom's VPN saves. Daughter of the Rockies, high-speed high priestess. Scales of justice ballast on a Memphis Express. Next bottleneck, I see mountain crush it. Click, clack, goes a mace on firewall. I spooked and truce from trash sheets. That's my device. Nullify a sniffing by my cloaks too crisp. Mainnet gossips, tastier than breakfast chips. Story, hack, flurry. Mama's making news before the cold reload. Jot receipts in my cheeks, encrypted and plumbed. You private DMs, I'm the dumpster dive chump. Eyes everywhere, match 3 bird phones. Haunteries whisper king chomp and blockchain bones. tears. Call me well connected, I call it. Coffee for drip and the lab coat on fire. Sticky note constellation stuck to the ceiling wire. Gas fees are confetti. They rock on P Island. Get homemade in 7-4 time. Shaboom.
Are we good? All right, hi everyone. Let me put this right. So my name is Pauline. I am the developer relation engineer at Wormhole. And so today we're gonna have a little walkthrough, not just Wormhole is, but also what kind of interrupt solution we have out there. And one of the things that came quite important to me when I started in interrupt is that people assume that interrupt is only bridges, right? Like this is the main idea you have when you're like, okay, I need to go cross chain, and basically I'm going to use a bridge and I'm going to wrap an asset, and that's what I'm going to get. Well, there's a lot more solution in interrupt, and actually that is really not what I want to deconstruct, but I think we should stop making assumption that people fully understand how interrupt work, and just try to, just like start from the beginning and really understand what we're trying to do. So that was the intention. So beyond bridges, an advanced approach of building a multi-chain app. So these are the goals. So basically, what's the state of interoperability today? And why you might want to build a multi-chain app. This is one part of my job as a DevRel is also to do all the integration support. And we have very recurrent question, actually, when people come and they wonder whether or not they can integrate, and also what basically are the best solutions out there. So we're also going to talk a little bit about that. What are the trade-offs of using a wrapped asset? And I mean, Wormhole is definitely also a bridge. So I am not saying having a wrap asset is not a good solution. I'm just saying this is not the only solution. And based on what you're trying to achieve in your app, you might actually have a much suitable solution. and how Wormhole product addresses interoperability challenges, we can have a quick walkthrough. So, yeah, that's basically what's the state of Interop today. So today you have about 40 versions of USDC, right? So no need to say the liquidity fragmentation is an issue, but the UX is an issue. Before working at Wormhole, I used to work for a layer 2 or P-Stack protocol. And also you had wrapping, you had bridging. And it was always very confusing for users, for people, for developers. So this is something that has been an ongoing challenge, right, in the whole crypto world. Why Interop? Well, first, cross-chain messaging operate at scale. And just, I don't know if you guys know, but Wormhole is basically the main cross-chain provider for BlackRock today. So when we mean at scale, we mean like institutional scale, okay? So just so you see today, we have about 1 billion messages. So when we talk about Interop, we talk also about cross-chain messaging. 1 billion is about what has been gone through Wormhole. 50 billion is the value that's been facilitated by the bridge. So that is not a small market. I think, actually, I was looking into some stats, and I think combining all the different Interop protocol we have, we are about like 75 billion of value that has been facilitated through Interop. So this is a very important part of this ecosystem to understand. Also, cross-chain messaging is everywhere. The idea is that you might want to use a bridge just to send your token across 2 chains is definitely a valid use case, but you see it everywhere. There's token transfer, borrow and lending protocol use it, NFT use it, oracles to have actually on-chain, querying data on-chain is very important across many ecosystems. Governance, we have the Uniswap governance, for instance, is going through Wormhole. So that's also very important for voting power. Swap, you name it. So it's not just I'm a user and I want to transfer my fund. Like that, there's many, many more use cases. So yeah, why you might want to go multi-chain when you build a product. So first is the user growth, right? You might want, and I'm talking by experience because as a DevRel previously in a ecosystem, usually ecosystems strongly encourage developer to, they basically want native app, right? They want this app to be fully native in the ecosystem, and then maybe later go cross-chain. But that is really what every protocol is trying to do. Now, why would you want to make that step? So unless it is, let's say, unless it's something that is very important for your application from the beginning, which is not always the case, and most likely is not the case. But at some point, it's very important you understand that your users and the audience you're trying to get is probably not on the only chain that you deploy your application in, right? So user growth, scalability, TVL growth is very, very important, and this is why most of the people wants to go cross-chain, right? You want to go where your users are, but you also want to go where the money is. So if you are deployed on a chain and you cannot go anywhere else because you're stuck on that ecosystem, well, at some point you might need to make the move, right? So these are the most common question I get usually in a day-to-day basis. And I just wanted to make sure people understand clearly the difference and what it takes to use a bridge and create wrapped assets rather than deploying token natively multi-chain. So basically, it depends what your project needs. Do you want to keep a full control of your token contract? Do you want to keep every single parameter, every single, like the design, the original design you made for your token, do you want to preserve that? Do you want to keep ownership? Do you want to be able to upgrade? Do you have authority over your token? All of these questions are very relevant because most of the people, when they come to us, they're like, oh yeah, I just want to use the wormhole bridge because I want my token up there and I want this to be facilitated by the protocol, which is a good use case. But what happens under the hood when you delegate your token contract via a port, like a bridge, like a token bridge, and not just wormhole, any bridge, is that the token bridge contract will create a wrapped version of your asset, which means that you delegate the ownership of your token to the token bridge contract, right? So basically, in a nutshell, what it means is that you do not have ownership of your token once you have a wrapped asset. It doesn't mean that the token natively that you have deployed previously is not yours. It just means the wrapped asset version that is going to be locked and then minted on different chain. This belongs to the bridge because, I mean, it belongs. It is owned by the token bridge contract, okay? So a wrapped asset version of your token is not owned by you. So if you later on decide to change the metadata, for instance, of your token, well, you cannot do it because you don't own that. You don't own the wrapped asset version. Like, that's very important to understand. So that is one of the limitations of the asset. So if you end up with a token that you want to keep full control, full ownership, be able to upgrade any sort of security settings, then you cannot, I mean, it's not that you cannot, it's just like you have to know the trade-off. So this is one of the things we go over and over at Wormhole, and I know that other colleagues in other interop solutions also have the same question. So I just want to make sure that you understand that the best case for you to use a token bridge contract, for instance, is that you have a token, you want to make sure that in a few minutes you can deploy it and have it up and running on our portal bridge, and then you can transfer that across 40 plus chain very quickly with zero friction, and it has taken you very little time and no particular implementation. Then you use a wrapped asset token bridge solution. Now, is this not what you are looking for, and you need a bit more specific, you have different needs, then I can walk you through what kind of solution exists out there. Okay, so what is Wormhole? So basically, the core messaging primitive is what Wormhole is built on. So everything we build on top of Wormhole is based on this core messaging primitive. But the idea, the main idea we have is actually to build a very modular stack. So think of Wormhole a bit like Stripe, right? Like when you go to Stripe, you have many different products, right? You don't have to use them all, but you can combine them all. It's very important that if you're a developer, our main goal is not to lock you in with Wormhole. Like, we have no intention of making developer come to us and then they're only able to use our stack and only able to use further products because they cannot do anything outside our own stack. You actually can use whatever you want from Wormhole. Everything is compatible. If you want to use, for instance, native token transfer with Connect, you can't. If you don't need to use Connect, then you don't. Like, that's basically our philosophy, is that the developer use what they need and nothing else. So these are the main products. I will go through the main one, which are the native token transfer, which is the main alternative to a token bridge, for instance. And then I will quickly go over the Wormhole settlement because it's literally been released about 2 hours ago. And I think it's our new intent protocol, and it's very cool. So let's say you are a developer who is in need. You want to deploy a token natively, multi-chain, and you must keep all authority. You want to maybe specify the rate limiting. You might want to add verifier, for instance. So you cannot really go through the token bridge, basically, the token contract, because you have different needs. Then in that case, you will use what we call entity. Entity is a native token transfer. So it's not a token standard. That also is very important to understand. Other interop solutions out there have their own token standard that you have to basically convert to be able to use their cross-chain protocol. We made the decision to not do this. So entity is a very flexible framework, and you don't need to change anything from your token design, right? You keep your token design exactly as it is. Entity will preserve token ownership, upgradability, and customization. So basically, anything you will want to change after deployment, you can also do it, right? Everything goes through a CLI. If you want to, you don't have to, but it's the easiest way. And so you will own the deployment. So you own, obviously, you have the ownership of your token, but you also have full ownership of every deployed contract with entity, okay? So security control, access role, rate limiting, posing, global accounting, all of this, you can also configure it. And I think one thing that people are often surprised with, and it's worth mentioning, is the flexible verification. So what basically is flexible verification is that to be able to use any sort of cross-chain messaging, obviously we verify that every transaction is valid, okay? But you can use the standard wormhole verifier if you want. That is not a problem. However, some people, for whatever reason, often security reason, might want to use external verifier, right? That is very important that there's no lock-in to wormhole. If tomorrow you want to run your own verifier, or you want to run a third-party verifier, let's say you want to use another protocol that has verifier like Axela, you can combine that. You would just have a different threshold. So instead of having only wormhole verifying your transaction, you can make okay, your threshold is 2 and 2, okay? Like the transaction needs to be verified by wormhole and by Axela. Actually, the Rapstake ETH from Lido use that combo. So what they do is that they have the verifier from wormhole, but they also have the verifier from Axela. So actually, it's like very enhanced security. There's two main deployment models. But again, you can add your own if you decide so. But these are the most common ones. So you choose your deployment model. Either you have a burn and mint model, which is the purest form of bridging, really. So you will burn from on chain A, you burn your token, and then it will be minted again on chain B, okay? This pretty much everyone who has a new token use this burn and mint model. However, there's another one that is usually most frequently used by existing token. So it's the hub and spoke. And hub and spoke is very similar to a lock and mint, let's say. But what it does is better for people who want to upgrade their original contract. Like that is a better solution for them. As I said, it's a modular stack, so you can use anything. If you want to use Connect as a small widget that we have that basically leverage the entity tech. If you want your own front end, you don't have to use it. Everything is built like this with wormhole. I have 4 minutes, so I really want to go over the end of the presentation, so I will just skip that page. We have a SDK, of course. I just want to talk quickly 3 minutes about what we just released today. So basically, we released today wormhole settlement. So it was live about 2 hours ago. So it's the next generation suite of intent protocols. So what it does is basically, I don't know if you are familiar with intent. So intent protocol is very similar to what a cross does, for instance, or the bridge. And intent refers to a transaction where a user simply states the intent without having to worry about the details. And a solver, which also is commonly called a market maker, but in intent we use the name solver, facilitates the intent and abstract away everything else that is involved. Basically, what you are able to do with intent is you can go a cross-chain swap, a swap plus an action, and it abstracts also all the chains. So it is the fastest today, the fastest way to make any sort of transfer cross-chain plus action. So let's say you go and you want to make a transfer. This camera is very stressful, sorry. So you want to make a transfer from Base to Solana, and you want to first make a cross-chain transfer, but in the same transaction, so in one click, okay, you will have to make a cross-chain transfer. Then maybe you want to make a swap, because you want, for whatever reason, make a swap, and then you will have to deposit on a certain protocol, like stake, let's say. You would do all of this in one go, basically. That's what would happen. And what it would use is something that we call faster than finality. And basically, it means that the solver in the middle take a bid, accept the bid, process the bid before the finality on the original chain is completed. The problem with finality is that it can be very long, right? On Ethereum, for instance, it's 17 minutes. So when you deal with actually DeFi application, you do not have the time to wait for those 17 minutes for many reasons, like slippage and whatever. And so what you do with intent is that basically you go faster than finality, and the solver takes the bid, it takes the risk, and then it takes a small fee transaction. So this is what we have basically go live today with. So. And also, if you are a developer, we have hackathon bounties. So entity is what I just presented. And also, we have any build multi-chain dApp build with TypeScript SDK or the SDK, or any sort of actually direct core contract interaction will go. And then queries. Queries is like a very interesting product we have, and it's basically for having querying data on chain, but extremely fast, under 1 second. So that is super, super interesting. If you want to build any sort of that need like aggregator, for instance, or anything you need for a full full on-chain data, and it's powered by Wormhole, and it's very easy to use. All right, so if you are a dev and you want to see any sort of tutorial, you can scan this QR code. This is where most of those implementations are done by guide and a tutorial. And yeah, you can find, I would also be judging the hackathon, and I would also be the main person to support any hackers. So if you have any question, please feel free to get my Telegram or time is up, okay, on my Twitter, and I will definitely get back to you. Thank you very much.
Just dreamers, on-chain truth, no middle schemers, forking hard and shipping code till sunrise every day. DAOs are voting, vibes are flowing, buff-eyed corns are still a-growing. While the world is breaking down, we're regen in a new way. Some VC said this tech won't last, and the hurt bubble, watch it crash. But we don't need your central banks, 'cause regen biddlers stacking stacks. For we bid let this city on sports and chains. We bid let this city with regen brains. We bid let this city on sports and chains. No rug pulls, just pure on chain. Whale pools floating, fees are burning. ZK proofs the chains keep turning. Every block we validate She's a Colorado comet in code forged steel, wings snipping latency like scissors through gel. 9 centuries young with a lance that's, if your chain's choking, Ethernight whiz. Found her at a bullet hook, sucking down APIs, armor clinking with layer 2 lullabies. Scalability scripture, she winks at the moon while Lagrange drools over slow motion doom. Her shield's a disco wall, fracturing legs, grass, shooby-doo-bop crack. That lance a lightning fork, splitting bottlenecks backs. Alliance architect with a bufficorn's grit, teaching stale protocols how to fucking commit. Decentralize this, she smirks mid-flight as her wings tickle nodes into doing things right. Architect with a bufficorn's grit, teaching stale protocols how to fucking commit. Decentralize this, she smirks mid-flight as her wings tickle nodes into doing things.
Good afternoon, everybody. I'm Ferris, here from Imstones. And here to talk to you guys about AI supercycles, unlocking the next waves of decentralized innovation, pros, cons, and TBDs. So we're going to first start off the presentation with a question. Very simple one here. Are we in a Web3 AI hype cycle? What everyone's curious about. And us specifically at Imstones really bringing out a concerted effort to understand this. And we have teams studying this around the clock for the months and months on end. And for this presentation, we won't be here to bore you with heavy technical details. We're going to be looking at this more from a macro effect. And so in order to do that, I think it's going to be really fair for us to establish a quick baseline. That baseline is narrative drives price action. Any concerns? You're probably not going to like the rest of this presentation. Next point here, maybe a little bit more controversial, but still a good hot take. Crypto fundamentals, however, sustain price action. And this is what Impstone bases its model off of, where we decide to deploy, where we decide to act, how we decide to partner. Now, in order to look at the narratives, it's important, new narratives, it's important that we look at the trends of the past and try to glean something, try to see what we can learn. So we're just going to kind of quickly do a little bit of a refresher. Who remembers this top one up here called Metaverse? It's a fun one, right? And then you have this new enclave, except for NFTs. We also remember that. But it's important to know that not all narratives are built the same. So we have to begin to unpack that. And I think understand the defining features of these narratives. So what are they, right? 4 quick ones. Retail speculation, buzzwords, lots of pivots. Everybody's now an AI company. And most importantly, the next billion users. If that hasn't been said, we're pretty sure it's not a hype cycle or a promising narrative. And to quickly hone in on some fun pivots, who could forget Zuckerberg back in 2022, 2021, launching off of MetaMask's coattails, renamed their whole entire identity to Meta, to only jump ship soon thereafter with mass layoffs to boot. A little bit more of a plausible extent, Nike's real attempt to get into the NFT game. I don't know if anybody saw the headline, peeped that, 24 December, they shut that down. So it's important for all of us to understand narratives, especially on the infrastructure level, because infra underlines it all, and we need to understand it. So that's what we're here to kind of cut in some data on and see land somewhere, hopefully. AI and blockchain, back on track. Okay, first stop, token landscape, the macro landscape. This is quick CoinGecko data. There's 626 AI tokens with a 30 billion market cap. I cut into it. Our team of researchers cut into that 30 billion market cap. That can't be. That's pretty big. Who is it? What is it? BitTensor's only 3 billion. What does that mean, right? So we cut in. There's a lot of folks tagging themselves, companies tagging themselves as AI who are not truly AI. And for fear of the ats on Twitter and X and wherever it is, we won't be calling them out today. But there are tons of them. You can check out that data. Everybody is now an AI company. It's fun. Why not? So hype, still a question mark. We're not sure. Next point. The rise of AI meme coins. Now this one's even better still because AI meme coins is meme coins and anything else is an entirely individual thing to just to just AI. There isn't RWA meme coins categorization on these big schemas or anything. It's just AI. So it's really feeling hypey. And our team, of course, grows concerned when we see these things. We can't build custom infra. We can't concert our capital, our partnerships, our hundreds of millions of raised, our billions of staked, if there's indicators like this. But take a look at this. 2.7 billion in market cap across 380 coins. I think we're starting to see the waning promise of getting rich quick on meme coins. That's quite the diluted amount of capital. Next. So now it's important to look at what Web 2 is saying. Interestingly enough, Web 2 is actually touting a $16 trillion market cap. And of course, within there, you have loads of companies like Apple, your big mega caps. And of course, within that, as we mentioned before, with every narrative and hype cycle, there are tons of pivots. The difference here is that these pivots are actually a little bit more believable because they are not feature functions. I mean, they are feature functions, not so much back end. We use AI to facilitate the product towards you. For example, Apple is releasing their AI, Meta is releasing their AI, et cetera. Tesla, everybody's actually has an AI that is truly touching the end user. So this is actually believable. And this is where we're here set to focus our presentation on, this trend. 92% of these companies plan to even increase their AI investments, and 8%, however, have started to look into it, and they're starting to wind down or stabilize in a growing and research-based technology. So I think that's very interesting. There's something going on here. We're going to go back to that statistic in a little bit. So next important thing, does this cycle feel different? We got to look at the funding rates. Some really interesting stuff going on here. 2024, AI was the fourth out of 5 major key category trends. 4th out of 5th. They weren't the leading. You would feel that it might be something different. However, this might be attributed to these companies being newer on the scene, seed, pre-seed, series, we're not sure, right? There's a lot of data to point at a lot of different places. More disciplined VCs, more the capital being diluted between X or traditional enterprise, Web 2 versus Web 3, so forth and so on. So it's difficult to discern, but it is interesting to note that they haven't taken the lion's share of investments. And it's lagging only behind refi, and I'm pretty sure a lot of us don't know what refi is. Maybe we'll be talking about that next year. Hot take. No hype. So the question is, before we jump to that, it's really important to note here, 131 billion invested by VC capital in AI in 2024. It's huge. Look at the disparity, 1.8 billion. We are a drop in the hat, an absolute drop in the hat. And yet all enterprises are going in. So the question becomes, how do we gain more market share? Where do we go from here? Every company can be a Web3 company. And this is a trend that we need to capitalize on. So, another quick data point. This is important. This is something that we're starting to see at the very earth and foundation of this. Now, AI has been around for a few years now. ChatGPT made its debut in 22. Fortune 500 now, 2 years later, are seeing AI as some sort of fundamental business risk. Fundamental business risk. That's a 400% increase. So it took them 2 years to realize that from last year. This risk in and of itself talks about the proprietary ownership of certain things. They talk about risk in data accuracy. All things that are base level statistics any data scientist could tell you about, and things that we rifle with. So, how do we gain more market shares? By leaning into these very issues that they're trying to solve. We have to lean into the cost efficiency, the transparency, to democratize access, the open standards, et cetera. And we also have to solve the infra challenge, because it is heavy. Right? As an infra provider, what we're seeing are really complex infrastructure outlays. And I promised you earlier we won't be getting into this for this presentation, but we will be talking a little bit about these infrastructure challenges. Now, back in 2017, when proof of stake first came on the scene, a bunch of providers raised tons of liquidity. We were the narrative back then, hundreds of billions of dollars to support proof of stake and what's now going to become soon proof of liquidity to some extent. And it feels like we're going back to proof of work with the GPU consumption in these H100s. And we're just not, a lot of providers just are not ready for that change, right? Their finance teams aren't understanding the way they go to market, how many networks they support. It's not something that, it's catching a lot of folks on the back heels. Obviously, we're here to talk about how we're ready and we're there and what this actually means and what we've done. Not all will be coming with us. So at InfStones, we have 3 different verticals. Quick Shill. First and foremost is your node sale, where we support these products. We've supported Aether, Gaia, Autonomous. We're supporting Autonomous, incredibly exciting tech. Going to be coming on the scene in another couple weeks here. And we're supporting them from their node to earn project, fundamental enabling the sovereignty and the decentralization there. And in the second vertical here, we're getting involved in BitTensor subnets and BitTensor validation. And lastly, maybe in the next few months, we'll be able to share with you our chat and our more research-heavy features within AI. So more of a bit down on the deep dive. Here's the node cell vertical that we're running. Over there's the more BitTensor stuff, and Inflective AI, another very exciting partner of ours. We'll talk more about them soon. So what are some key infrastructure trends? There's been a decline in infrastructure providers supporting the number of networks. However, we are remaining strong. We are now up to 90 networks. We have not decreased the number of supported networks. But overall, there has been an intentionality to decrease and increase partnership. We're able to do both. Continued new networks, however, on the same time, at the same token, there are now even more networks, right? Obviously, Berachain with their humongous launch, Monad with their humongous launch, Rise, and just countless others. Tons of AI blockchain, and so nobody's slowing down. And what does this create? It creates the need for value streams and differentiation. And what you're going to end up seeing is more of a balanced decentralization cadence. Do you need really 50 validators in your validator set? It really is calling into question that. Can you really expect all 5 major infrastructure providers to be in every blockchain everywhere, right? And because what's happening now is there is going to be needed an intentionality, right? With this liquidity fragmentation, this skills fragmentation, this time fragmentation, right? We're starting to dilute ourselves. However, it's really just making it very clear to the foundations that they need to be very intentional about the partnerships they call. Which brings us to some really strong players who are solving this problem, and that one of them is Inflective, the global data layer for AI. Their mission is actually just simply to bridge this all. They see all these players, they've sat back and said there needs to be a solution that speaks to all of this. Inflective, excellent partners, excellent technology. 2 additional beacons. Aether and BitTensor. We all know about Aether. They've gone about this in a radically decentralized way, managed compute, really bringing down the cost, already hit first ones on the scene, maintaining lead, already hit amazing traction. BitTensor as well. Again, they've taken on the compute question from a subnet approach, and on that subnet level, they've managed to launch federated tokenomics. Same solution, two different ways of getting up the mountain. Deployment solutions. Now, AI has now coined a new world called AIOS. Two amazing companies taking this on. Autonomous coming on the scene in the next couple of weeks. Zero G as well, who's been there, who launched earlier this year. Both excellent technology and really providing the full suite for solutions to launch and deploy. Looking at it from data access points, smart contract execution, the whole thing. So now a little bit more of a head scratcher, right? Where we're still trying to figure this out. AI has its problems, and one of those key problems are bias, right? And it's ironic in that there's going to be this validator sets trying to understand and validate the data that they process and say, yes, this is true. But if inherently the data is biased, what have we really done? We've just brought cost efficiency and maybe a little bit of transparency in the cases that the data is on chain, which by and large it's not, but those other providers were trying to do that. Still, we run into the problem of just kind of business as usual, just a technological efficiency. So I'd like to ask the question, we'd like to bring up this point, a TBD here. How can AI systems create a more fair request or response from these chatbots? In order to understand that, I think it's going to be important for us to just quickly be educated on how the data flow works. Comes in from, for example, any of these major marketplaces, right? Sahara or BitTensor. First, there comes the request from the model trainer itself, and that could be from any data major company, Facebook, whoever it is, who's looking to train their model. They put this request out there into the ether, the Web3 ether. Then that's where the Web3 market, AI data marketplace picks it up, and the miners act upon it. But what's missing from here is that that data request inherently might be biased. They might leave out certain keywords. For example, LeBron versus Jordan, very easy one. Let's focus on LeBron, not Jordan. Let's focus on new articles as opposed to old articles. These games are played all the time, and we know them. That's going to be a quick one that's not too politically charged, but a quick search all online, we've heard these. And it is scary. We're relying on AI to be the source of truth, and we need to know that there are issues. And I don't know about you guys, but the reason why we're here, at least much of us are here, is to be that democratizing force, to be that decentralizing measure. And so I think this is a real area where we could step up and champion our ingredients. We have the right stuff. We have slashing. We have DAOs. We have decentralization. We've self-governed ourselves for years now. Now maybe more successfully than before, but it's something that that we should seek to do. So, question here: are there too many protocols, and is this hype? Resounding answer from Mimstones: no. Thank you.
Chain. She's a Colorado comet in code forged steel, wings snipping latency like scissors through gel. 9 centuries young with a lance that's, if your chain's choking, ether night whiz. Found her at a bullet hook, sucking down APIs, armor clinking with layer 2 lullabies. Scalability scripture, she winks at the moon while Lagron drools over slow motion doom. Her shield's a disco wall, fracturing legs, grass, shooby-doo-ba crack. That lance a lightning fork, splitting bottlenecks backs. Alliance architect with a bufficorn's grit, teaching stale protocols how to fucking commit. Decentralize this, she smirks mid-flight as her wings tickle nodes into doing things right. Alliance architect with a bufficorn's grit, teaching stale protocols how to fucking commit. Decentralize this, she smirks mid-flight as her wings tickle nodes into doing things right. Up to do with a do with a do with do with do. You ordered a moonwalk across gas feed graves. My mainnet's smoother than your mom's VPN saves. Daughter of the Rockies, high-speed high priestess, scales of justice ballast on a Memphis Express. Next bottleneck, I see mountain crush it. Click, clack, goes a mace on firewall. I spooked and truce from trash sheets. That's my device. Nullify a sniffing by my cloaks too crisp. Mainnet gossips, tastier than breakfast chips. Story, hack, flurry. Mama's making news before the cold reload. Got receipts in my cheeks, encrypted and plumbed. You private DMs, I'm the dumpster dive jump. Eyes everywhere, match 3 burner phones. Haunteries whisper, king chomp and blockchain bones.
Yeah? Okay, let's do it. So, hey everyone, I'm Itai from Dynamic. We'll talk about that in a second. Just thank you for coming in today. Really what we're going to chat about, just so everyone knows, is essentially everything around embedded wallets, making embedded wallets invisible, and then how we give agents or AI agents wallets. So it's going to be a couple of fun topics. I'm sure everyone's excited. We'll start very quickly. Quick overview of why we're stuck with me. Who has heard about Dynamic before? Okay, great. Okay, by the end of the conversation, I guess everyone would have. But very quickly, I'm the co-founder. We focus on everything embedded wallets and wallet offering. And inherently what that means is a single SDK for everything wallet related. So that can be a Web3 login, that can be an embedded wallet type login, so email login, social login. It can be a bunch of components and UI tools, or it can be a fully headless, very API, very close to bare metal type tools, right? So we do all of that. You'll see a couple more in a second, but that's a little bit of context, just so folks know who we are. We've been around for about 3 years. We raised about $21 million from A16Z, Founders Fund, First Round Capital, etc. And we have some cool folks on the team. Very quickly, the way to think about us, and again, I'll get to the actual meaty stuff very, very quickly, but the way to think about us is we offer everything user management. So that can be embedded wallets, but that also means wallet linking. That means capturing information from users. So it's a kind of everything you need to know to manage your users on the site. And we have historically focused on human-based kind of crypto in the background UI abstraction, right? We're moving to also focus on AI, kind of agent-based abstraction, but historically we focused on, okay, how do we make it really easy for humans to experience Web3 experiences, right? And you can see Dynamic today on a bunch of sites. So if you go to Magic Eden and you log in, by the way, with email starting this week as well, or connect multiple wallets to the same account, that's powered by us. If you go to Arena on Avalanche and you log in with Twitter and you get a wallet, that's powered by us. If you go to Sofon and experience a global wallet within their ecosystem, that's powered by us. You can see it on Berachain, you can see it on Say, on Story Protocol. All those websites use Dynamic. So we get to work with a bunch of really cool folks. If you've used Legion, for instance, to kind of get access to early deals, that uses Dynamic, and you've gotten a Dynamic wallet, you have likely used Dynamic at one point. We've had over 75 million sessions in the last year using Dynamic. It's live on EVM and God forbid non-EVM chains, but let's ignore the non-EVM chains for this conversation, given it's an EVM conference. So we'll start with less dynamic shilling and more to our actual point, right? So AI agents have pretty much kind of taken over the conversation, right? The idea would be that over time, we become more lazy and we get AI agents to do some of the work for us, right? Book a trip, buy stock, or do things we haven't thought about, right? And it's very easy that we give them wallets, right? It makes sense that they don't just have access to information, but they can actually take action and get wallets, right? But you'll have these AI agents perform a bunch of these tasks, and they need some sort of way to act on them, whether it's waiting on my behalf for Taylor Swift tickets. Who is a Taylor Swift fan, by the way? Thank you, I appreciate it. You're going to get more references in this conversation than you should. But it's natural that we give them those wallets, right? There are really two paths to giving AI agent wallets. The first one is human in the middle, meaning I want to perform a task, I assign the task to an agent, and at that point the agent gets some sort of delegated permissions from me to accomplish that task with a wallet. They end that task and they give me back the resulting kind of purchase, whatever. And the second approach is just AI agents with no human in the loop, in the sense that I wake up in the morning, there's an agent running in the background, it does continuous tasks for me, and it just continues on a day-to-day basis. And we'll cover both of those. But the challenge is essentially, for AI agents to work, we got to give them these really fine-grained permissions, right? You can't, if you go on ChatGPT and it hallucinates the wrong answer, that's fine, right? You can double check it, you can confirm. If it hallucinates buying something that it shouldn't, or spending $1 million, that's really not okay, right? And so you need to give agents very fine-grained permissions in order to actually execute on this type of stuff. And so for that, and this is where we take a step back, to get AI agent wallets right, we actually had to take a step back and think about how do you get key management right? What are the core things you have to do in order to build for this future world? And that's where we have a first announcement of the day. We had to rethink how we do kind of our key management infra. And so today we're essentially announcing a new key management infrastructure for Dynamic, which is threshold signature MPC-based infrastructure. Now, as I continue to explain this, who has heard of MPC? Great. Who has heard of threshold signatures? Okay, that's awesome. Okay, great. So let's actually dive into what that is. So for those that don't know what MPC is multi-party computation, meaning we collaborate together in order to get a resulting computation. What threshold signature MPC is kind of a more advanced version of MPC, where a private key in the case of key management never exists. Meaning I have a share, a server has a share, an agent potentially has a share, and we collaborate. It's distributed, it's generated in a distributed way, and we collaborate to sign without a private key ever being exposed. So you can start doing really sophisticated key signing mechanisms without ever exposing a private key or without a private key ever existing. Now, historically, these have been really slow. So you would use them on a Fireblocks, which works well when you're trying to move $10 million and you're fine waiting 10 seconds, but they do not work very well on a thing that needs to happen really, really quickly at scale on a consumer app. And so they've been kind of in the background for a while, but over the last couple months and years, we've started to see a lot of MPC progress to get it up to speed, and that's where we get the dynamic TSS MPC. So let's look at a very quick demo of what that looks like. So this is more the bare metal version of this, right? So I can create a bunch of these different iterations of shares. I can do a 2 out of 2. I can create an EVM, a Solana wallet, an SVM wallet. I can do a more sophisticated 2 out of 3. I can do a 3 out of 5. So that's 5 shares, 3 needed to sign. I can start creating these really interesting iterations that are important in the next part of the talk around AI agents. I can do more sophisticated stuff. So I can refresh shares in case one share gets compromised, or I can reshare the entire thing. So I can start with a 2 out of 2 share setting, and I can move to a 2 out of 3 or 3 out of 5, right? So that flexibility is really important for that next part of the talk, which is how do we get AI agents to have shares of wallets? And we had to rebuild the entire key management infrastructure to get that right. If you want to see a detailed demo of this, by the way, this is kind of really quickly adding a new wallet. You can add a 3 out of 5. You can do more sophisticated stuff around import and export. All that type of stuff we kind of handle. If you want to see a demo of that, come find us after, come to our booth. But we had to get that right? So very quickly, architecture-wise. We've built a hyper-flexible solution, right? It's non-custodial. It can do a bunch of these key shares. It leverages trusted execution environments for the server side, so with the dynamic side of this. So signing happens in trusted execution environments. And it can work client-side for human-in-the-loop type interactions, or server-side for servers-to-server, machine-to-machine type interactions, right? What that means is we can get agents, key shares with very limited permissions, and we'll see this architecture in a bit. You can get key shares with very limited permissions and hold the dynamic or the server share to a rule engine for when to countersign or co-sign, right? So you can start building these really sophisticated flows based on this architecture. But before we dive into AI agents, and I think that's the third time I said before we dive into AI agents, we'll get there. This lets us kind of change how we do human-type interactions. So log in with email, log in with Google, etc. Right? So we have a few options. So at the very basic level, we offer a 2 of 2 setup, meaning a human wakes up in the morning, they go to arena.app or any one of those sites, and they log in. They get a key share on their end. Dynamic has a server share on its end, and Dynamic also stores an encrypted version and a backup version of that key share. So if I go to a second browser, I have an automatic recovery in the background. So for a user, it's seamless. It's the same as the experience of logging in with an email today and getting a wallet. But you get all these kind of advanced things back. But again, as we said, it can graduate to a more sophisticated flow automatically. So I can create a second key recovery that I store on Google Drive or iCloud with one click. Or I can even do a more sophisticated type recovery where one share is stored on a developer site, one share is stored on Dynamic, and then 3 shares or 2 shares are stored with the user. So you can start building these really sophisticated key management type flows very, very quickly. And it's rolling out in the coming weeks. So if anyone wants early access, reach out to us. But with that, let's actually finally talk about AI agents. So not sure if you heard, AI agents are all the rage. I really hope we get to a point where we wake up in the morning and we have a bunch of these agents working for us. There are lots of cool frameworks out there to manage AI agents, to manage Web3 AI agents. I'm actually not going to talk about them. I'm just going to focus on the key management part and how key management changes and how it should be structured for this. So as we talked about, there are really 2 ways to do this: human in the loop and no human in the loop. The human in the loop one is the following. By the way, the point of this deck is really just to show memes and GIFs. So if you got nothing else away from this deck and you got some good memes, hopefully that made your day better. But very quickly, the goal of a human in the loop type AI agent is to help with everyday tasks. I want to book a flight. I want to trade stocks. I want to start moving things from one place to another. I want to kind of renew my passport. All that type of activity is a human in the loop. I wake up in the morning, I have access to a wallet, I delegate some sort of permissions, the agent takes care of them, and comes back with the results. So let's walk through a flow. So user goes to an AI travel agent website. They define some parameters on the trip. So let's say my budget, where I'm going, etc. The AI agent gets a key share. So the user issues that AI agent a second key share. So we move from a 2 of 2 to a 2 of 3. At that point, the AI agent can countersign with a server to actually execute on things. The server can limit what can be countersigned with a rule engine. And then the agent books a trip, and the human goes on vacation and thinks about how weird the world is becoming. The way that works on the dynamic side is the following. So a user gets a user share, right? I logged in with an email, I logged in with Google, I got a share. And I can issue this temporary share to the agent and define some permissions in the rule engine as to what this agent can do. Right? And at one point, I can destroy that extra share. I can reshare, right? I can redo the sharing, get a new share so the old thing the agent has is no longer relevant, and continue on my day. So I can start doing that a bunch of times, right? Now, there's a second type activity, which is no human in the loop, right? We're used to UIs, we're used to logging in, but agents do not need to do that, right? There's no real reason why an agent has to actually have a UI or why they need a UI component at all. And for that, we need lower level server-side SDK, so a Node SDK, in the future a Python SDK, in order to let agents interact with wallets directly. And the flow there is slightly different, right? So an agent wakes up in the morning. Obviously, agents need to drink coffee too. They monitor a market. They find some sort of opportunity. They ask the server for a share. They generate the share locally, essentially. They generate a server share. They get some sort of permissions, allocation of funds. They execute on the tasks. Human get ongoing reports. And again, human doesn't need to do anything. Right, so the idea here is actually taking it a step further from an assistant to a fully autonomous type experience, right? And you can do that with more sophisticated server-to-server and machine-to-machine type interactions. And that's why, by the way, we're launching this Node SDK, and again, in the future, things like a Python SDK, etc., that let agents live in their machine-to-machine environment without needing to deal with UI. And in that scenario, there's really no human, right? So an agent independently generates a key share. Again, MPC, there's no moving of shares, but rather a key share is generated here, a key share is generated here, and there's some rule engine that actually, is this like an, oh wow, this is an actual screen. there's some sort of rule engine that controls what can be signed and what can't be signed. Right? So you can do this in a really nice, flexible way. And again, there's a relay that communicates, just so everyone's clear on TSS MPC, there's a relay that communicates information, but it actually doesn't move any key material. Right? The key material stays here as one share, and the second share that stays here. Right? So you have that ongoing security in a really nice way without any kind of interaction in the middle. So over time, we'll probably have this combination of both type of agents. And in both cases, I really hope that just means less work for us, right? I really hope we just wake up every morning, reflect on how weird the world is becoming, and do less work as a result of this. I will make one shameless plug, given that we're in a kind of a ETH conference. Who's heard of 7702? Okay, so who's heard of account abstraction? Perfect. Okay, so for those that don't know, and again, 2 takeaways from today should be meme coins first, 7702 second, trusted execution environment, and TSS MPC third. But on the second one, there's a change coming in the upcoming Ethereum update, which lets you bind an EOA address to a smart contract. So essentially, you can log in over the next couple months with your MetaMask and do gasless transactions or batch transactions. Right? That works the same for embedded wallets, meaning I've spun up an embedded wallet for an agent, and that agent should be able to benefit from trustless or gasless type execution or batch execution, just like a human would. So that is a change that's coming up. The reason I say account abstraction, it's based on the same, how am I doing? Oh, 3 minutes, perfect. It's based on the same account abstraction type contracts, but sits not in front or on top of kind of an EOA, but rather next to it as a rule engine. So that's coming up. That's going to be really exciting. So with that, let's summarize. So we talked about a bunch of things, right? We talked about why AI agents are cool. We talked about our new TSS MPC offering, right? And all the cool things you can do with very flexible, low-level key management that we now offer. We talked about the 2 paths for AI agents, right? Human in the loop and no human in the loop. And we talked about how we can do less things, right? But and I'll end with this, which is we're in the business of giving tools to developers. If you were to tell me, hey, here's the types of experiences that will be built on top of Dynamic 2 years ago, I would have told you you're crazy, right? We've had Lamborghini build on top of Dynamic, and we have Doodles build and McDonald's build on top of Dynamic, and we had anywhere in between those, right? And those are things we couldn't have predicted, and the types of experiences we couldn't have predicted. And so really what we're trying to aim for at Dynamic is to give tools in very low level and very close to the metal tools, as well as very abstracted UI components for folks to build stuff we haven't thought about. And so while I really hope that, the next time there's a Taylor Swift concert, I actually, instead of standing in line on Ticketmaster, I get an agent to do that. That's a great use case. I really hope that the next set of use cases that are built with AI agents actually we did not think about, right? And are completely abstracted away. And that's why I ask that if you have cool ideas for ways to experiment with AI agents, come talk to us. We want to hear about them. We want to start building a subset of tools that help you create these experiences that couldn't exist today and look like nothing like what's out there today. And with that, thank you. If you want to reach out to me, if you have questions, that's my Telegram, that's my email. We have a booth tomorrow. Again, shameless plug. If you want early access, come talk to us. If you want to play around with Dynamic in general, come talk to us. If you want swag, come talk to us. And besides that, very much appreciated. Thanks, everyone.
like, who's got the keys? Nullifiers huffing, you're just a rat with as firewalls splinter to confetti bits, I'm curating leaves at the after party, sipping TLS tears. Call me well connected, I call it
Guitar slide. Wah, wah, guitar slide.
coffee for drip and the lab coat on fire. Sticky note constellation stuck to the ceiling wire. Gas fees are confetti. They rock on.
Dollar will dramatically lose its purchasing power. The more they print, the more it gets diluted.
Who it's good for is the people at the tippy top.
Because in order to keep the system going, they have to keep printing money.
And Bitcoin is that tool that allows us to beat the money printer.
Bitcoin is powerful in a way that is money that does not discriminate.
Bitcoin is built by the people for the people.
Yesterday's ram stains. Velcro boots clicking through blockchain debris. Crypto notes flutter like drunk bumblebees. Optimize the board fins. They cackle and shout. Self-sustaining hubs flicker in the blackouts out. Professor Way's got the future on spinball. Urging notes dancing where the bottlenecks been. Professor Way's got the future on spinball. Hugging tomorrow with yesterday's ram stains. Chaos is not compeller, or it's just a bug I forgot to unfurl. Mainnet shivers as their wild hair glows. Rumored AI, nah, just 3 Red Bulls in a row. What you building, prof? A singularity jukebox. How you stay charged? Espresso straight through my cortex. Who's your nemesis? Light runs dial-up found. Old as speak, young as each block mine down. Professor Way's got the future on spinball. Urging notes dancing where the bottleneck's been. Professor Mad's just a beta test for Boodle. Oh, he just tried to do audible. He just tried to do audible. He just tried to do audible. He just tried to do.
We're biddylers, not just dreamers. On-chain truth, no middle schemers. Forking hard and shipping code till sunrise every day. DAOs are voting, vibes are flowing. Buff-eyed corns are still a-growing. While the world is breaking down, we're regen in a new way. Some VC said this tech won't last. And the hurt bubble, watch it crash. But we don't need your central banks, 'cause regen biddlers stack in stacks. For we biddy let this city on sports and chains. We biddy let this city with regen brains. We biddy let this city on sports and chains. No rug pulls, just pure on chain. Whale pools floating, fees are burning. ZK proofs the chains keep turning. Every block we validate is trustless, clean and fair. Open source and gas optimized, code permissionless and finalized. Fork
She's a Colorado comet in code forged steel, wings snipping latency like scissors through gel. 9 centuries young with a lance that's, if you chains choking Ethernight whiz. Found her at a bullet hook sucking down APIs, armor clinking with layer 2 lullabies. Scalability scripture, she winks at the moon while Lagron drools over slow motion doom. Her shield's a disco wall, fracturing legs, grass, shooby-doo-bop crack. Ooh, that lance a lightning fork, splitting bottlenecks backs. Alliance architect with a bufficorn's grit, teaching stale protocols how to fucking commit. Decentralize this, she smirks mid-flight as her wings tickle nodes into doing things right. Da-da-da-da. Architect with a bufficorn's grit, teaching stale protocols how to fucking commit. Decentralize this, she smirks mid-flight as her wings tickle nodes into doing things right. Up to do with a do with a do with do with do with do 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 do. You ordered a moonwalk across gas feed graves. My mainnet's smoother than your mom's VPN saves. Daughter of the Rockies, high-speed high priestess, scales of justice ballast on a Memphis Express. Next bottleneck, I see mountain crush it. Click, clack, bosom, lace on firewall. I spooked and truce from trash sheets. That's my device. Nullifier sniffing while my cloak's too crisp. Mainnet gossips, tastier than breakfast chips. Story, hack, flurry. Mama's making news before the cold reload. Got receipts in my cheeks, encrypted and plumbed. Your private DMs, I'm the dumpster dive chump. Eyes everywhere, that's 3 bird phones. Haunteries whisper, king chomp and blockchain bones. Make it down to my voted fuck. Stealth crawl through your junk dead scene. Set it up to the entropy. Mace cracked vaults like, who's got the keys? Nullifiers huffing, you're just a rat with As firewall splinter to confetti bits, I'm curating leaks. After party, sipping TLS tears. Call me well connected, I call it
Guitar slide. Guitar slide.
coffee for drip and the lab coat on fire. Sticky note constellation stuck to the ceiling wire. Gas fees are confetti. They rock on PI. Get homemade in 7/4 time. Shaboom, dose, efficiency pulse. The lag runs lagging in his latency so. Professor Way's got the future on spin, boy. Urgent notes dancing where the bottleneck's been. Professor Way's got the future on spin, boy. Plugging tomorrow with yesterday's RAM stains. Velcro boots clicking through blockchain debris. Crypto notes flutter like drunk bumblebees. Optimize the board fins. They cackle and shout. Self-sustaining hubs flicker in the blackouts out. Professor Way's got the future on spin. Urging notes dancing where the bottlenecks been. Professor Way's got the future on spin. Plug in tomorrow with yesterday's ram stains. Chaos is not a compeller. Order's just a bug I forgot to unfurl. Mainnet shivers as their wild hair glows. Rumored AI, nah, just 3 Red Bulls in a row. What you building, prop? A singularity jukebox. How you stay charged? Espresso straight through my cortex. Who's your nemesis? Light runs dial-up found. Old as speak, young as each block mine down. Professor Way's got the future on spin. Urging notes dancing where the bottlenecks been. Professor Way's got the future on spin. Plug in tomorrow with yesterday's ram stains. Throwing me mad, running mad's just a beta test. A bullet over all the jobs. Just dreamers, on-chain truth, no middle schemers. Forking hard and shipping code till sunrise every day. DAOs are voting, vibes are flowing. Buff-eyed corns are still a-growing. While the world is breaking down, we're regen in a new way. Some VC said this tech won't last. And the hurt bubble, watch it crash. But we don't need your central banks. Cause regen biddlers stack in stacks. For we bid let this city on sports and chains. We bid let this city with regen brains. We bid let this city on sports and chains. No rug pulls, just pure on chain. Whale pools floating, fees are burning. ZK proofs the chains keep turning. Every block we validate is trustless, clean and fair. Open source and gas optimized, code permissionless and finalized. Fork marmots on the scene, you know we're gonna bid a little it there. Some tread bro just rolled his eyes. Where's the yield? Where's my supply? But we don't need your banker games. She's a Colorado comet in code forged steel, wings snipping latency like scissors through gel. 9 centuries young with a lance that's, if your chain's choking, Ethernet whiz. Found her at a bullet hook, sucking down APIs, armor clinking with layer 2 lullabies. Scalability scripture, she winks at the moon while Lagrange drools over slow motion doom. Her shield's a disco wall, fracturing legs, grass, shooby-doo-ba crack. That lance a lightning fork, splitting bottlenecks backs. Alliance architect with a bufficorn's grit, teaching stale protocols how to fucking commit. Decentralize this, she smirks mid-flight as her wings tickle nodes into doing things right. Alliance architect with a bufficorn's grit, teaching stale protocols how to fucking commit. Decentralize this, she smirks mid-flight as her wings tickle nodes into doing things right. Up to do with a do with a do with do with do. You ordered a moonwalk across gas feet graves. My mainnet's smoother than your mom's VPN saves. Daughter of the Rockies, high-speed high priestess, scales of justice ballast on a Memphis Express. Next bottleneck, I see mountain crush it. Click, clack, pose a mace on firewall. I spooked and truce from trash sheets. That's my device. Nullifier sniffing by my clothes too crisp. Mainnet gossips, tastier than breakfast chips. Story, hack, flurry. Mama's making news before the cold reload. Got receipts in my cheeks, encrypted and plumbed. You private DMs, I'm the dumpster dive jump. Eyes everywhere, match 3 burner phones. Haunteries whisper, king chomping blockchain bones. Make it down to my voted fuck. Stealth crawl through your junk dead scene. Head it up to the entropy. Mace cracked vaults like, who's got the keys? Nullifiers huffing, you're just a rat with These firewall splinter to confetti bits. I'm curating leaps at the after party, sipping TLS tears. Call me well connected, I call it
Guitar slide. Guitar slide.
coffee for drip and the lab coat on fire. Sticky note constellation stuck to the ceiling wire. Gas fees are confetti. They rock on PI. Get homemade in 7 for time. Shaboom goes the efficiency pulse. The lag runs lagging in his latency sub. Professor Wade's got the future on spinball. Urging notes dancing where the bottlenecks been. Professor Wade's got the future on spinball. Bugging tomorrow with yesterday's RAM stains. Velcro boots clicking through blockchain debris. crypto notes flutter like drunk bumblebees. Optimize the board fins, they cackle and shout. Self-sustaining hubs flicker in the blackouts out. Professor Wade's got the future on spinball. Airgene notes dancing where the bottlenecks been. Professor Wade's got the future on spinball. Plugging tomorrow with yesterday's ram stains. Chaos is not a compeller. Order's just a bug I forgot to unfurl. Mainnet shivers as their wild hair glows. Rumored AI? Nah, just 3 Red Bulls in a row. What you building, prop? A singularity jukebox. How you stay charged? Espresso straight through my cortex. Who's your nemesis? Light runs dial-a-phone. Age? Old as speak, young as each block mine down. Professor Wade's got the future on spinball. Airgene notes dancing where the bottleneck's been. Professor Wade's got the future on spinball. Plugging tomorrow with yesterday's ram stains.
Ladies and gentlemen, welcome to AO Conference. Woo! We need to get some more coffee here. We have 4 hours of the best and brightest minds from around the permaweb. And right now, there is no better nor brighter mind than the creator of AO and RReeve, Sam Williams. Sam, you want to come on up?
And slides would be great, please. Hey everyone. All right, so with any luck, we'll have some slides soon. Okay, we're good. All right, so these events, I think, are a good opportunity for core permaweb builders to get together and discuss. Like, you'll find that actually most of us in the audience here are people that live and work on the permaweb every day. And so I wanted to give a kind of overview of where, from Forward Research's perspective, we are, and flexible and composable. Another thing that came with mainnet is what we're calling AO Core, which is essentially it's a primitive for the internet, fundamentally, that lets you express paths through the state space. So the sequence of messages that should be executed on top of a base message in order to get to a state. So if you have a smart contract, maybe it's a token, well, you execute each of the user's transactions on top, and you get to a specific, what we'd call a location in the state graph for that program. And what hash paths give us, what AO Core is sort of composed of, is basically taking that fundamental unit of what a blockchain is, this sequence of interactions on a deterministic program that get you to a specific state, and expressing it inside HTTP, using this new standard that was formalized last year called RFC 9421, or HTTP signed messages. And basically what it gives you is that every single message that moves around the system can be, if you will, like adding to its own blockchain. Basically every single state transformation, so an input that connects to an output, is tracked. And so when you get a message back from a Hyperbeam node, even if you're just accessing like the info page for the node, or something else like a piece of data stored on Arweave, you get back this little attestation that is signed, and it references, or it connects a reference to a particular spot in the state space with a particular output. And this is like the fundamental unit required in order to have verifiability and fraud proofs. And so on top of this, we also launched TEE support yesterday. So you can run your own node, and when you get back one of these hash paths and a state associated with it, some data, you can know with a very high degree of certainty that that is actually the piece of data that is found at that particular location. And one of the things I wanted to highlight here, that because it's a sort of relatively closed audience of core permaweb developers, is this concept that those hash paths can be merged together. So in this example, we have 4 parallel processes or computations in AO Core, and each one is leading to a message that is sent to another process. And when it does so, it carries with it the hash path that led to the creation of that message. And this happens recursively. So over time, what you end up with is a single unified, I skipped the text slide, sorry. A single unified hash path at the top that is a Merkle root of all of the computations that went into the creation of that message that you're seeing. And this is something that I think, I mean, frankly, when we were looking at this at Forward Research, you can intuit pretty quickly that that's very powerful. And my sense is that there's a bunch of things that we can do with that that are as yet very unexplored. It's open territory. So if you can, one example is that you get a message out the top of this, and it will, let's say that bank there is actually a token process, and that sends a message, or maybe it's a state channel, right? Someone is streaming a video, they're paying a gateway for it, a Hyperbeam node, for access to the content. And then that operator of that Hyperbeam node settles the payment into wrapped R. And then from wrapped R, they swap it into AO, let's say, something of this kind. So then when you take the output 10 years later from the AO process, you now have a Merkle tree that includes the ordering of all of the transactions that happened, even down to that state channel right at the beginning. And this is all represented in a single 256-bit Merkle root. And we also left it open in AO Core, so you can implement other algorithms as the, someone is waving, I can't tell why. Okay. They say thumbs up now. Who knows what that means? yeah, we left it open so the algorithm that is used to add to the hash path is something you can swap out later as well. So for example, you could make a version of the hash path algorithm that will only include state transitions that have been signed by, today, a TEE. So when you get back the root at the end of the system 10 years later, then you know that all of the computation that happened in the subset of the network, which would be, if you play this out, I think you'll end up with like 95, 99% of all of the compute being expressed in these single values. Yeah, you know that all of that compute happened correctly up to the, would you say, security properties of the hash path algorithm that was used on it. You could also do the same with ZK proofs if you so desired. It's open to that. So if there are any builders that want to take that mantle and run with it, I think there's a bunch of really cool places it can go. But right now, it's just greenfield, like totally unexplored. Okay, so another thing that AO Core gives us is the ability to merge together state representations. So you get a message output from one machine, you get it from another machine. If they agree, then you can merge together the signatures. And this is another fundamental primitive that's needed in order to have multiple attestations of correctness. And it shipped with AO mainnet 2 weeks ago. So yeah, you get a global unified Merkle tree of almost every computation. The interesting part here is almost. That sounds like a negative when you first encounter it, but actually you realize that like without creating communication overhead. So for example, in Ethereum, right, you get a state representation out the end of every block that is 100% of the network, right? But you only have one thread. And in order to achieve that representation, you've had to compute it on, I think it's between 12 and 60,000 nodes, depending on the time. What Hashpaths and AO Core gives us is you get almost all of the computation, but it happens naturally as messages move around the system. There is precisely zero additional overhead from the communication perspective. And from the compute perspective, you need to do one additional hash, and that's it, every time a message is passed. It's really powerful, I think. And a quick aside, yeah, this conference is about AO, but for everyone that's building on Arweave, which I guess is basically everyone here as well, yeah, the HTTP signature format is a new form of bundling, essentially, with a new type of data item that gives us a bunch of really cool properties that we didn't have before. So traditionally in Arweave, like when we first built it, it was supposed to be, well, it was built to be a ledger of history. And if you look at any sort of archives data structure, you see that you don't just refer to a piece of content by its raw identity of just the bytes themselves. That would be kind of crazy, in my view, because the bytes themselves don't really tell you very much. What you need to know is who said it, when they said it, and associated metadata. And so that was baked into the first transaction format of Arweave. And that associated metadata component was left open to the user to decide what is relevant to them. And fast forward 7 years, and that has become the backbone of the indexing systems that make a bunch of the applications on the permaweb run. But a constant complaint we've seen along the way, understandably, is, well, hey, those tags, as they're called, they're a fixed size, and they can only be binaries. And it's very difficult to get a recursive structure. In fact, I haven't seen anyone in practice create a recursive structure. So when we were looking at building Hyperbeam and AO Core, it became very obvious that this would be a good opportunity to widen the design space that's offered by the core data storage primitive. So yeah, now we get flexible keys and values. That means that everything in the map, the message, is a flexible component. There's no difference now between tags and like normal metadata. That's all just one thing. And the same with the data field. Those who have built with the system will know that there's only one piece of data that you attach to an Arweave transaction, which is kind of annoying sometimes. You want to add multiple pieces of data. Well, now you can. You can have as many documents as you want inside the same single message, all associated with just keys and values. It's like a classic dictionary map structure. You also get multi-signature uploads, of course, because, yeah, with HTTP SIG, we get that out of the box. And you get recursive messages. So now you can make, I guess in the old world, we would have thought of this as bundles that contain bundles. But they're not just referred to by like their index inside. You could have, in theory, and again, I don't think I ever saw anyone do this in practice because it was so janky. You could say, hey, I've got a bundle of data, and number 5 in the bundle is going to be this other piece of information that is necessary for this computation I'm running or this service I'm offering. Instead, now you can just, everything has a name. So if you want to, you can have a list of items inside the bundle, but you can also say the HTML document is this, and the API representation is like this. And you can serve that back on the same, it's the same message, essentially, contained in the same message. And something I didn't list here, but it's pretty cool, is when you recall these pieces of data on a Hyperbeam node, then you can actually traverse through the URL, or traverse through the data structure via the URL. So if we had a piece of data that's got like a body and also this sort of, let's say, a computer native representation, you could say like that piece of data, stroke API, stroke price, stroke BTC, or whatever it is. And so you can like recursively navigate through the bundle using like normal HTTP semantics. And also we have typed values now. This was another problem when people wanted to index the data. Sometimes you had like an integer, or you had a floating point number, or you wanted something to be a list. That was actually one we commonly saw. It led to people putting JSON inside tags, which is a nightmare. Well, you don't need to do that anymore. It's natively supported out the box. You can just have lists of values. Yeah, and also, all of this is expressed in like core HTTP semantics. So if you access a piece of data, in fact, if you go to a Hyperbeam node, you go to stroke any device and go to, say, an info endpoint, like the meta device, then what it will give you back is a HTTP structured document, which is a recursive bundle of multi-part form data, which is a little bit odd and specific, but TLDR is that every existing HTTP client library already knows how to parse that. And yeah, so we get library support in, these are the 12 languages that are just listed on the httpsig.org website on day 1. And the standard itself was only ratified like a year ago. And you can already, out the box, use Scala if you want, or God knows why you would want to, but you can use Ruby to make these messages and send them to the network, and they can just be adopted. This is a huge, huge step up from what we had with Arweave transactions, where you had to have a specific library that someone had to make, and then they had to maintain. And so you got this common theme of like, okay, someone now wants to use the network in Java for some reason. Well, there's no library for that. So either they have to go and build it, and maybe they do build it, which would be great, but then they abandon it 6 months later. And so it's not up to date, and then someone comes and tries to use it 2 years down the line, and it's just not a smooth experience. We swapped that instead for everything that can use this sort of globally accepted common standard can now create Arweave data items and send them to the network. And something that hasn't progressed very far yet because the standard is so early, but I think in the future will be really, really cool, is that all of the different key management systems that emerge for HTTP signed messages will instantly be compatible with the network. And that means that as soon as someone makes a hardware wallet that manages these keys, and there's various reasons why you might want to do that in just on the web in general, we'll have support for it. And when people have key management systems for organizations, for enterprises, well, those are valid Arweave keys that can custody AO tokens of any kind. So I think it's pretty cool. And they look like this in practice. This is taken just from the Hyperbeam shell. But you can see here that this is a process state. So when you're executing a process in the background, what's happening is it's creating this recursive message structure where each of the different components is available as a navigable item. So you could go to that ID of that hash path stroke, for example, VFS, I think, is at the bottom here somewhere, and stroke dev stroke standard out. And then just in the browser, you can get to the standard output created by the WASM module. And you can see there it has rich types. Some things are lists, some things are integers. Yeah, and we can now index on top of all of that, and it uses unified standardized formats. Even the typing is done using a sort of a neutral established standard called structured fields. So if you're trying to pass one of these documents down the line in some other program you're writing, well, if you can find a structured fields library, then there you go, you have support. You don't need anything special to use Arweave and the permaweb anymore. It's like the permaweb is integrating into the web as it currently exists in all of the standard frameworks and APIs. Okay, so AO Core itself is a system that exposes devices. I mentioned at the start that previously we had 3 different unit types, and each was a different code base. Well, the stack that you get when you check out the Hyperbeam repository today is 30 different devices, all of which we've built a sort of standardized tagging system for them to basically let you know as a user what level of development they're at. And so you can see here there's some things that are candidate mode. We define candidate as like, if you're a nerd like me, you'll know the request for comment system, the RFCs that are part of the internet standard, what would you say? The standard nomenclature of the internet, where they're not really actually a request for comment. They're like, this is probably the standard as will exist for decades. Yeah, that's what a candidate mode release means. You can reliably build on top of it and know that it won't change under your feet. Then we have this idea of a preview release, which is, okay, there are parts of this system, well, for a start, all of it is in place. It works, but there are parts of it that might need to be tweaked down the line. And then we also have early access releases. They're like, okay, it more or less works. You can use it for stuff, but don't be surprised if it changes under your feet. And the core idea here, and I would really sort of advocate that we adopt this widely in the community, is so that other developers and users downstream can know the robustness of the thing that they're building upon, right? Like the whole point of the crypto industry is to create protocols that offer users services rather than companies. And why do that? Well, because the protocols don't change. You as a user get actual reliable rights and guarantees when you use the protocol, rather than a company who can just turn around and change the game on you like 10 times a minute. And yeah, you're more or less beholden to them. And so by making a clear labeling system and having, if we were to adopt it all as a community, not just forward research, then it would be very easy for people to understand, okay, what rights and guarantees am I actually getting? So with an early access release, there's no real guarantee that it won't change. It most likely will in some form. And then in a preview release, it's like, okay, well, largely the structure's there, but I shouldn't depend on components of it too tightly because they might well change in the future. Whereas a candidate release is something like Bitcoin and says, okay, here's the fundamental API, here's the way that you use it in practice, and maybe there are small tweaks down the line, although you don't need to adopt them, no one will force you to, but it's a robust, reliable service as is. And that's what really grants people rights. So 2 weeks ago, we shipped milestone 1, and it's about to ask who was a fan of the communications on mainnet, and there'll be 0 hands, including ours from Forward Research. This didn't pan out well. But to take another opportunity to explain the situation, we shipped Hyperbeam AO Core, the core protocol now, we don't think will change. And those that are kind of close to the team will know that we've been like obsessively focused on tech for the last, really since summer. And the reason for that is because with Arweave, we saw there's a lot of pressure to get hype and engagement early for protocols. You see this like all over the crypto space. But the truth is that actually real adoption and use cases only come along when the tech is in place. And there's a real danger when you are building a protocol that actually people come to rely on the wrong version. So I think the story of Ethereum is actually encapsulated directly in this, which is that they had a great proof of concept. That was like our legacy net, testnet v1. But people started to adopt it at such a rapid pace that essentially that negotiation with the users and the developers around like what changes are admissible becomes harder and harder because it has a specific spot in the trade-off space. And the real like disaster from the we're at an Ethereum conference, so sorry guys, to be clear, Ethereum did some really amazing things. But in terms of the adoption of Ethereum over time, the catastrophic error was global shared state. And applications came to depend on this. This was just the way that you built Ethereum programs. And so in 2017, 2018, the scaling roadmap for Ethereum was to build sharding, which would have killed global shared state, as was like, obvious. I don't think I need to explain to you guys why that won't work. But they couldn't push it through because there were already users that had become not just accustomed to and acclimatized to, but they also depended on the software to run in that particular way. And so when it came time to get rid of global shared state, they couldn't really do so, and it led to this sort of 8-year quagmire of not really achieving the scalability that they wanted. So yeah, we've been really obsessively focused on getting the tech right, getting those fundamental units in place, and that's AO Core at the base of it, and then an implementation with Hyperbeam, such that in the future we can build on top of it, and it's a modular structure, so each of these components can be swapped out at will at any time in the future without disturbing the other components of the system. And now we have a really solid base from which to work, which saved, in the case of Arweave, we had a similar situation. We shipped V1, which was quite scalable, but like it wasn't going to scale infinitely, or like, to be precise, past the maximum the users wanted to use, basically. Like 2 to the power 256 bytes is what we ended up with Arweave 2.0. But before that, we had a lot of pressure from the community and from investors and the likes to go like push adoption and get people hyped about it. And we did so. But the truth is that they all flaked. Because when you went to use the software, it didn't do what you needed it to do. And so instead, we focused on getting the technology right. And now we're in a really great spot for community adoption and development. So Milestone 1, we call this. This is basically AO Core is cemented in place, and also all of the units that were needed in order to perform payments. Just payments to start with. And that's about like, 8 different devices on top. And you can now spin up a Hyperbeam node, you have been able to for a couple of weeks, where you can set up a payment relay to existing AO infrastructure. So you spin up the other nodes, and then you can charge people for access. And the reason this is so important, and the first thing we focused on, is because anyone that's used AO legacy net or testnet knows that, wow, like sometimes it gets slow. And the answer for that is that, the reason for that is that when you have an open system where anyone can compute any amount of, or ask for any amount of computation they like, inevitably it leads to clogging of, there's only so much infrastructure being provided, and it's being provided for free. So you can't scale, you can't scale the infrastructure to deal with user demand because user demand is uncapped. There is absolutely zero cost to the user to generate requests. And so we have payments in place, and so, okay, now you can go to, I think it's like relay. I forget what the domain name was. Well, anyway, if you open up AOS and you say --relay, it'll take you there, which is kind of like a fast lane for existing infrastructure. But yesterday, we shipped, I think, a really, really exciting part of this stack, which is basically the ability for people to run Hyper-Beam native computation, as well as those payment systems, on top of AO Core. And what this means is, in practice, you can go open up AOS, say --mainnet, and it'll put your scheduler for your computation into a Hyper-Beam node. It runs natively inside the system. And then it'll do payments or whatever else you'd like it to do from the other devices, and also then curry the compute that you ask for to a LegacyNet compatible executor. It's actually just like like a mini coup embedded inside a Hyper-Beam environment. And you can run all of that inside a TEE. So after payments, where we need to go next is making it so that people can push messages for one another around the system. Like right now, or on LegacyNet at least, when you started a process, you would set a default authority. And some people played with this in the community, made it so that they could also push messages for their users on those processes. But it's a sort of ring of trust, if you will. And what we have in place now in the sort of preview mode is, well, you can start up a node inside a TEE, which gives you very high levels of trust. Not perfect, not by any means, would you say? On its own, a single TEE attestation is good for some value, but you really want like multiple TEEs in order to get very, very strong correctness. But you can now start Hyper-Beam node inside a TEE environment, join the green zone in preview mode, and essentially perform computation and have the messages that come out be reliable to some reasonably high degree, and then push those messages around the system. Now, it's going to take some time for that to get from preview to candidate release, but now people are already playing with it, and they're actually contributing to the Hyper-Beam repo, which is really cool to see. And so this is like the full view of what exists right now, and obviously the red stuff is where we want to go down the line. There's a bunch of stuff you can already do with this in practice that I think is super cool. So when you have an AO process on a Hyper-Beam node, then you can access parts of its state, and you can actually also export from the WASM environment to the external host. Again, in preview mode right now, there's probably going to be issues, but you can like try it out, test it, and within relatively short period, I think it'll be stable, candidate mode. Yeah, you can make it so that you can like render web pages. So here is a web page, just says hello world, but it was dynamically generated by that process underneath. It's like a web page served directly from a smart contract. And even the last mile from the smart contract to the user's browser is protected by that hash path mechanism. So you're essentially saying, hey, give me the state at this position in the state space, and it will give you back a renderable web page. But it doesn't just have to be web pages. You can have full APIs expressed this way. So you can now, instead of having to query and basically like simulate what would happen if you sent a message to a process, you can just embed, or rather export from your WASM environment, essentially bits of state, to the host Hyper-Beam environment, into that like AO core state message for the process at any point in time. And then you can just say your process ID on any Hyper-Beam node stroke now stroke price, and it will give you back that bit of state inside the system. And then you can even do like more complex things like say now stroke balances stroke user. And where this goes in practice is that no more dry runs. Yeah, exactly. All right. Yeah, like when you want to perform a computation on AO LegacyNet right now, what actually happens in the background is that, and I won't mention the name of this project, but there's a widely used project in the ecosystem that you load the homepage and it performs 80 dry runs, 80 simulations of interactions with those WASM containers. And for some context, it takes 1/3 of a second to invoke that WASM container, run the computation, and get the output. You're doing that 80 times in order for the user to load just one page. That's an unbelievable amount of compute. Instead of that, we have these extremely cacheable values where you can just export every time the state changes a patch on the state of the process. And then the user can get to it just by the URL bar, or you can, basically dynamically do it in JavaScript, and boom, you've turned that 80 requests into like 80 requests for little values that are just like using a web server. It's going to be like massively, massively more performant. So that's yeah, that's exciting, and you can play around with that today. It's a little bit janky interface, but it's there, and soon I think it'll be widely deployed. But it actually goes kind of deeper than that. So here are some example URLs that you can use with AO Core. If you're used to developing and familiar with Bash scripts, I think the way to understand the AO Core URL bar, or the path that you can go to in on a Hyperbeam node, is basically that each is a mini blockchain, and you can specify the interactions you want to have happen in sequence. And it can be like immensely deep. So for example, we have a URL here where the top one, you're going to a specific hash path. And that doesn't need to be a process. It can actually just be like a serverless function with no scheduler. It's just a specific existing point in the state space. And you're saying compute and get the results and run this WASM function factorial with these parameters. And you can also specify that the parameters are a list. And you can do that all in the URL bar, which is kind of like interesting curiosity, but it turns out actually in practice, this could lead to really, really cool effects. So the second URL we have, we take the process and we get the schedule, and we say the body, or rather we're posting to a process's schedule, and we set the body to be a different path. And so essentially this sub-resolution system allows you to kind of create another little blockchain and then merge the two results at the end. So this says, go to this process ID, compute it at state 7, slot 7, get the results, get the outbox, get the first message from it. Now you've got that message, and you're essentially, that's a messaging unit in AO Legacy Net, like in a single URL. And anyone can construct them of any form. It's like the URL bar itself becomes general purpose compute. Yeah, I think there's, and this bottom one, so for example, you want an oracle. You want to get the price from Binance of Bitcoin. Well, you just use the relay device, and then it will give you back a HTTP signed message that you can validate is running inside a TEE, so hasn't been corrupted. And that's one URL bar, or like that, this one GET request to perform what would otherwise be like a massive piece of engineering. Where we see this going down the line is that, like, in the same way that building a computer yourself is not the process of like putting transistors on a chip. You just pick up parts and they stick together. It's like kind of Lego in a sense. Well, this is Lego for blockchain applications. It's a big box of different tools, and you can just construct the service that you actually need by like reusing them. So building a new blockchain or a new service that has specific compute requirements, security requirements, should really just be a case of configuration, not a case of building and development, which should cut down the cost of innovation massively, which is something we're excited about. So the next thing that we're focused on is getting it so that, I think these slides are unfortunately swapped. That is unhelpful. Well, getting it so that the scheduler and the delegated compute system, that's the one that lets you call out to the embedded CU inside Hyperbeam, and the Genesis WASM device that sort of like orchestrates that process, is all in stable release. And when we have this, we'll be able to access legacy net processes on mainnet. So if you take nothing else from this, I think we could use it to clear up the confusion about mainnet, legacy net. The reality is that all of your data, if you have a legacy net process, is on Arweave. So it doesn't really live in legacy net per se. It's that you're using legacy net infrastructure to execute that process. And where we want to go with milestone 3 is making it so that those processes are then fully compatible with Hyper-Beam nodes. So you can start pulling them down and running them inside Hyper-Beam environment and making use of, for example, that no more dry runs feature and exporting state and the likes without updating your smart contract code necessarily actually at all. You can just continue to run them. Because the data is shared on Arweave, like there's a neutral place where it's all stored, which doesn't really exist in mainnet or legacy net. It's like, well, actually in this diagram it's explained pretty well. It's right at the base layer, underneath everything. So when you have this, then you'll be able to smoothly transition in a live fashion with no downtime between legacy net infrastructure and mainnet infrastructure. And at that point, people can start using payments and start running their own computation inside TEEs and start pushing those messages around, and you end up with a fully decentralized supercomputer at the end of it. After that, we want the green zone to reach stability. And this allows you to do not just everything I just described, but also private computation, provably private computation even, which could be useful for many things in the ecosystem. Like, I know we have the Randau team with us today. Well, they can make it so that the generation of entropy that goes into the Randau process can also be hidden inside a verifiably secure container where no one can see the state transformations. You can also, for example, have a piece of data stored on Arweave that you then pay to access, and only when you have paid do you get to see the content. Which is something we've had probably 100 requests for over the years. Now building those services will be very, very easy. After that, where we want to go is this system called AOT. It's ahead of time compiled WASM code. So the new Hyper-Beam native computation system, which we already have in place but not running in AOT mode, and like most of the existing processes, actually all of the existing processes and most of the new processes will use the embedded CU. But yeah, it allows basically to, when you see a WASM container, you can then compile that to native assembly code on whatever platform you have and run it at like 90% approximately of native speeds. So if we want to build a supercomputer, this is how we make it so that it's running at like full pelt. Every single CPU you throw at it gets you 1 CPU worth of computation out the side, at the end. Whereas right now, maybe you get like, I don't know, a third or a half, something like this. So this would be a big efficiency improvement. And yeah, we're also not the only people building. We were just having a conversation this morning with the APUS team about the GPU devices they want to build on top of this. They already have an implementation of WASI-NN, the WebAssembly Standard Interface Neural Network standard, which allows you to call out and do basically, well, most obvious use case for it is large language model style computation on a GPU from inside a WASM environment, and then as a consequence inside a Hyper-Beam environment, and even inside a TEE, giving you correctness guarantees about the LLM output. And there's also another web GPU project ongoing with a sort of different version of the WASM environment. But where next after that? Well, now our attention is starting to turn back to growing the usage of the system. Now we have the tech in place, we can really tell people about it and yeah, grow the environment that already exists inside AO. And I think a huge thing that people missed with the mainnet launch, or didn't really receive the attention that I think it's probably worth, is Pi. It's like, it's big. It's very, very, very big. I think this will be huge for the ecosystem long term. Essentially, what it means is that as it stands today, and I haven't checked the numbers in the last week or so, but from the pre-delegations that people have made, 40% of the value, approximately 30 to 40% of the value from AO minted tokens will all flow to the ecosystem, to ecosystem projects, without there being a centralized party in the middle, like a grants committee that is sitting there deciding where the money goes. No, instead it's just following the delegations that real users of the permaweb are making with their Arweave tokens or with their bridged assets. And so if you work that out on a per day basis, I haven't done so with the latest prices of AO, but last time I calculated it was something like, it easily gets into the hundreds of thousands of dollars per day invested into the ecosystem. So if you're building an ecosystem project, this is a way that you can get access to capital in a fair and transparent manner where, if you will, your audience that you're attempting to convince is just the wide public, everyone using the permaweb. And it's on completely equal terms. And a secondary effect of this, slide order again, damn it. A secondary effect of this is that you start to build an extremely wide ecosystem of people that are staked into the success of your project, like long-term, right from the start, even before those tokens are liquid. And you can do this without actually having to reach them directly. So, of the people that have delegated, there's probably, I would guess, 4,000 plus all of the Arweave token holders, or not all, actually, rather, most of the Arweave token holders, which is into like 200,000 approximately, that will become stakeholders in your project just by proxy. And that means when they see your posts on X and you're trying to engage your community, well, there's a set of people that are out there that are willing to listen from day one, which for a new project is a huge, huge deal. You get a very, very wide base of supporters virtually instantly with this system. And even cooler, they all get in on equal terms. There's no favoritism, it's just open and transparent, and it provides you funding at the same time. Did I mention that I think this will be big? Thank you. I think this is going to be very, very exciting for the whole ecosystem. And yes, to take it back to this slide that was out of order, there are already actually 6 projects, one of which is not on here, which is a shame because they're the people that took the leap early and were basically like jumping into the deep end when this was just an idea, and that's Apis Network, who already had a mint live since the end of December. And at one point they had $7 million essentially deposited into their minting process, fair launch minting process. And a really interesting byproduct here that is not understood, I think, at all yet at this point, is that the yield that is distributed as funding is not the native yield. It's actually the yield in AO terms. And what that means in practice is that okay, now we get into the weeds of the mechanism design, but the yield that you get is the yield over base of the native, which TLDR today sits at approximately 2.5 times what it is for the native assets. So actually, the last time I calculated it, the yield that these projects would get on those deposited funds in their fair launch process is like 40% per year. Now, it probably won't stay that way because markets are efficient. Markets are eventually efficient. But yeah, during the time where that value is smoothly moving down towards some efficient level, probably somewhere over the native asset yields, the yield that you get from those deposited assets is extremely high. So that just magnifies the amount of capital that is going into the ecosystem, helping people build stuff. All right, so there we are. That's where we are, and that's where we're going. Thank you, everyone, for listening. And yeah, I'm excited for all the talks today.
Engaging online worlds, the one, the only, Mr. Matt Mason of Base Jump.
Thank you. Can you all hear me? Oh, what's going on? All right, that's happening?
Yeah, you got a mirror.
Oh, wait, okay.
Or extend.
Sorry, technical difficulties. Where do I do that?
you want to go into where the mirroring is and the display settings.
Oh, yeah, okay.
Over here on the menu. Like what menu?
Sorry about this, ladies and gentlemen. Like Sam, I'm also British, but I'm not as smart and I'm not as technical, clearly. I do swear more as well, so I apologize in advance for that. But we're about to get kicked off. My name is Matt Mason. I'm the CEO and co-founder of BaseJump. Thank you. So we're building a new platform that makes it very easy to create, share, and connect games, game assets, and worlds. And one thing I want to talk about today is why we're doing that now, and also why are we doing that on AO and Arweave. So the reason we're doing this now, the reason we think this makes sense now is because games are fundamentally changing. Gaming's never been more popular. About half the world use game assets, mostly in games, but also in streaming platforms and in social networks. People are getting more and more attached to their game assets. About 40% of Gen Z players update them monthly, and more Gen Zs would rather work in gaming than be a doctor or a lawyer or a professional athlete. So that's all amazing. But gaming's still really, really closed. It's very fragmented, and it's never been easier to make a game, but it's still very, very difficult to make a game. Because it's easier, games are becoming something else. So there used to be applications, but actually if you look at where gaming is at now, games are becoming content. If you look at Roblox, Roblox is now the size of Nintendo, Xbox, and PlayStation combined. And the only thing happening on Roblox is kids making games on Roblox themselves. Same thing on Minecraft. If you look at Fortnite, 19 of the top 20 developers are single devs pulling all-nighters and making maps that people play, and then they go away the next day. So gaming's getting more ephemeral, and this idea of owning your assets is becoming more important to people. The big tension is that you can't move these assets from one platform to another. And we got a glimpse at BaseJump of what it might be like when the world is like that, when we created an NFT community called Broadside a couple of years ago. This was an NFT project. It was very sort of story-driven. It was about this sort of fictitious future world that we made up. And we had this whole plan for Broadside, but the Broadside community decided to go in a completely different direction. They decided they were going to become the most engaged community in all of the open metaverse, and they were going to take their assets across all kinds of games and platforms and worlds and do all kinds of things with them that we didn't imagine. So, for example, they built this place called the Broadside Rave Bunker. This is the most popular nightclub in the metaverse. It's kind of like what CBGB was to punk or Studio 54 was to disco. The Broadside community holds raves in here every single week. They've done that for the last 2 years. This event is streaming in there right now. They're watching this right now in the Rave Bunker. You can get in there yourself if you go to Broadside Twitter. We've had all kinds of people like The Prodigy and DJs like Roger Sanchez. People have come and performed in the Rave Bunker just because it was a weird and fun thing happening on the internet and they wanted to know more about it. And the Broadside community just sort of kept taking this further. So we did this Metaverse World Tour. We did a bunch of live events that were also in the Metaverse. The community just keeps sideloading and doing weird things with their assets. So they're bringing them into Roblox games, into GTA, all kinds of crazy stuff. And the Broadside community, because they had the rights to their game assets and because they could move them all kinds of places, they did all kinds of stuff with them. And after the end of the first year of Broadside, the average revenue per user that we were making from Broadside was about $98 a user. So to put that in context, the ARPU on Roblox is about $15, and the ARPU on Fortnite is about $7. And NFT communities are different. Oh, that number doesn't include the mint price of $75 that they initially paid for the 7,000 Broadside characters. This is revenue earned from an additional sort of 45,000 NFTs and merch and other things that we did. But what this really showed us was that interoperable game assets are really fun and they're really valuable. If you give people rights to do all kinds of things with them, they'll do things with them and then that will create more value for you as a company. So we decided this is a really, really cool group of people and we want to build a platform that kind of serves them. So myself and my co-founders, we've been working scaling some of the biggest platforms in blockchain, consumer tech, and gaming for a really long time. And we realized that between the three of us, we were probably actually a really good team to try and do this. So like, let's build a new platform that really addresses this reality of a world where games are content and assets are interoperable. And so that's the big idea behind Base Jump. This is the sort of home screen of Base Jump. It looks like a loadout screen for a game, but it's a loadout screen for the internet built on game engines. It's got a permissionless gaming substrate under the hood called Action, which lets you create a game or a game asset with a simple text prompt and then deploy to any of the big game engines, social apps, anywhere that accepts game assets instantly. So this is all live right now. If you go to Basejump XYZ, this is very much the kind of, we sort of think of this like the splash page for what we're building. We're launching our first game in the spring. It's called Battle Mode. It's going to launch on browsers and in Discord. It kind of plays like Super Smash Brothers or Street Fighter 2, except you can load in with different armor or weapons or objects. So it's like Street Fighter 2 meets rock, paper, scissors is how we're thinking about it. The reason that we're building a game is because all of the metaverses that have scaled, Roblox, Fortnite, GTA, Minecraft, have really, really, really amazing core game loops. All of the metaverse platforms in the last cycle that haven't scaled don't really have core game loops. They're mostly kind of tool sets. You go in there, you kind of walk around, there's no one there, you leave and you never come back. Core game loops are really important. We've built game studios and games before. This is the first thing we're working on because this is the most important thing for users. So the way that this will work, here's a screenshot from the battle mode game. So you can take in your avatar, load it up with a weapon, battle somebody else, do this straight from Discord or in your browser. The level that you're seeing here and all of the levels here are powered by Action. They're all procedurally generated. And once we've got the game out, the next phase will be putting the Action app into the hands of users so that you can procedurally generate these levels yourself, and you can start making your own levels for this first core game loop that we're building. These are some early tests that we've done using the Action platform. And like straight away, we just playing it ourselves, we started making stupid things like we wanted to do a level that was about Pepe, so it sort of came out like a lily pond. Or this one down here is kind of a sort of green screen terminal. But very quickly, we started to realize that if it's really easy to make a game, if it's as easy to make a game as it is to make a post on Instagram, then games are going to become memes. Like this is another thing that we made where it really felt like this is a playable level that is just sort of a meme. Some of these things you might make and share with your friends, and then they'll disappear. Or maybe it's a really good game and you want to monetize it for a really long time, so you store it and you publish it on Arweave. And that's where the stack comes in. Like none of this was possible before AO and Arweave. Action is this layer of scalable gaming infrastructure that we're building. AO makes it possible to instantly create these levels, and Arweave lets you store them permanently. So, once we got in touch with Tate, the team at Community Labs, and we met Sam and everybody at Ford Research, we kind of realized that everything else was legacy tech. Like once you really understand what's possible here, it's just kind of mind-blowing. So we're so excited to be building here with so many of you in the ecosystem. So like getting into what Action does a little bit more, it will have a token. It does a lot of the things that a token will do, like governance. It has this impact thing, which I'll get to in a moment. It's also a way to pay for compute on the network. But half of what Action does is really about specific stuff to game assets. These could be avatars or weapons, items, or even entire games. We call these objects on Action hyperobjects. And one of the important things that the Action Network does is it actually just registers these objects and kind of explains what they are and what they do and what they might do in different worlds. And because it's all on chain, it means these objects can also be network aware and context aware, which lets you do some really crazy things. So here's an example of hyperobjects. If the internet's going to run on game engines, we think of hyperobjects as the connective tissue that connects everything in that internet, much like hypertext connects the internet that we use today. So here's an example of a hyperobject. This is a broadside character called Stinger. You can see him here. He's got a rocket launcher and he's holding some ramen. All of these things are hyperobjects. If you take Stinger and you load him into this platform, Chorus, which is a platform running on Base and Polygon. It's an AI music game creation platform. The chain doesn't matter. You can bring Stinger in there, and you can start making AI music with him. And because Chorus knows that he's a Broadside avatar, it's going to load up some Broadside-specific beats and acapellas and game loops for you. Here's Stinger playing in Nifty Island. Here he is in an app called Alias, which is for streaming and VTubing. So you can start to do some really crazy stuff. And this rocket launcher that Stinger is holding, if you take that rocket launcher into Nifty Island, it knows it's in Nifty Island. And Nifty Island, you play Capture the Flag, King of the Hill, these type of games. That rocket launcher will fire bullets in Nifty Island because that's what it was designed to do. If you take that same rocket launcher into the Broadside Rave Bunker, it will fire glow sticks because it knows it's in the Rave Bunker. And I think that's what, you know, with gaming, gamers don't like blockchain because all they've been shown is the casino. We need to start showing people the magic of blockchain. Why does this make gaming more fun? And we think hyperobjects is a really interesting way to do that. So hyperobjects make things more fun, but they also can help you explain some of the more sort of complex ideas behind crypto. We're releasing a collection of new action figure hyperobjects that will also run as nodes that will operate to secure the network. We've got 7,000 OG Broadside action figures. They will be the first ones that run as nodes, securing the network. We've got 100,000 others ready to go. I think Ethereum's got about 6,000 validators on it right now. So like, if you put a really fun gaming UI on front of things like nodes or some of the more complex aspects of DeFi, you're going to help more people understand why DeFi is important or why something like a node is important. If you show a gamer a platform where the platform isn't front and center, but their character is front and center, their assets are front and center, their data, and they're intuitively understanding that they own all that stuff and they can take it with them wherever they go, I can't think of a better way to explain decentralization to someone without having to say a single word. I think this is how all of blockchain is going to scale. I really believe that gaming is the magic bullet, and we're really trying to take a crack at that with what we're doing here. So yeah, and there's some other things we're thinking about. So we think this is also a really interesting way to solve complex problems that currently governments and corporations are failing at. So we wanted to sort of bring in this whole element of impact into what we're doing with Action. We partnered with the Rainforest Foundation US, and for our first launch of the Action token on the PermaWeb Index, we're aiming to protect a specific 4 million acre area of rainforest in Peru, where every single Action token, whether it's a hyperobject or simply a token, will be connected to a specific area of rainforest. And this is the map of the actual area. This is what you're going to see in the UI on Broadside, is tokens and avatars slowly protecting an area and really gamifying this. So this is something that we want to scale to all kinds of games and all kinds of communities, because this is a game, right? This is Capture the Flag. This is King of the Hill. This is defending territory. We've seen in the non-profit world, like if you adopt a goat or something, you're connected to that goat and you'll get emails about it. And if the goat's not feeling well, maybe you'll send another $5. This stuff works in non-profit. Why aren't we using this in gaming to protect real world areas that need protecting? So we're really hoping to scale this. This is a 4 million acre area that we're starting with. There's 3.3 billion other acres of rainforest to protect, but there's ocean garbage patch to clean up, and there's dust bowls to rewild. We want to use Action to turn saving the world into the world's greatest game, because it's something that we think you can only do using blockchain, and AO is really, really perfect for doing this. So that's what we're doing. We're really excited to be launching as part of the PermaWeb Index with the Action token on March 14th. Stake your AO, you can earn Action. We like this because it gets tokens into the hands of many, many people as soon as possible. And yeah, look, we're just so excited to be building with all of you in this ecosystem. I love everyone I've met across AO and Arweave, and everybody who's working here. Everyone I feel like out here is doing really, really interesting things with blockchain to really make the world better, and that's what it's all about as far as we're concerned. So do get in touch if this sounds interesting. Thank you very much.
Thank you so much, Matt. Appreciate you. Our next guest is from Apis. Apis is one of the most interesting projects on AO and the permaweb, and to explain it further, we have Mr. Connor Thacker, Head of Community at Apis. Connor.
Just speak close to the mic.
Can I take out?
You can take it off.
Nice one. All right, guys. I'm Connor. I'm head of community at Apis Network. I know some of you know me, some of you don't. I will skip past this. Firstly, who are we and what are Apis Network? You may have seen it in the first slide that what we are doing is enabling verifiable decentralized AI through deterministic computations. And the second words that I didn't leave on the first slide are that it's on AO, and that's really important for us. The second thing we're doing is that we're running competition pools. So we're incentivizing people to build high-quality AI models, right? We don't want a bunch of rubbish being put out there, so we're financially incentivizing people to produce quality AI models, and also for people to be able to gain access to those models. So if you don't know what you're building or how to build an AI model, which is most people, we're enabling you to do that. Just set a fee, developers can push the models forward, and the best one ends up being yours. You'll have ownership. We are, as Sam mentioned, also the first project on AO to go ahead and run the community launch token as an AO token, and we did get up to, it was $7 million in assets bridged towards us within the first 7 days. So we were really happy with that. Okay, now AO mainnet and Apis Network. You've heard a lot about what's been going on with AO from Sam over the last couple of days, and now sort of how that's going to reflect with what we're doing. So the first thing, and it is important to us, but perhaps not the most important, is that what we're doing for our consensus on our verifiability is we're leveraging determinism. And our own consensus on this is we're using fast provable inference faults. And this is going to align perfectly with the TEs that are going live on AO's nodes. Perhaps the most important thing is going to be this. So we're building a WASI-NN device for native GPU support on Hyper-Beam for AI. So at the moment, I believe we are, well, basically, we are going to be one of the first devices going live for this. I know we talk a lot about building something for AI on AO, but I can say we will be pushing the code live for this on Pi Day on March 14th. So for anyone who wants to check it out, there will actually be a version on March 14th for you guys to look at. And talking about Pi Day, as the other guys have mentioned, we're really excited to be part of the permaweb index. So also going live on March 14th, and that's going to, well, it will root a huge amount of value to our community, and also for the entire AO ecosystem, right? So we're really excited for that. The next thing I have coming up, and I hope it's going to work because we have some voiceovers over the videos, is we want to actually show people what we've been building. So we're going to have a couple of little demonstrations. The first one's just going to show the difference between CPU on AO and GPU when we're looking at AI inference and just how big difference the speed is. And then we're going to have a look at our deterministic GPU our Hyper-Beam extension. So we're going to have a look at an example of both of those, hopefully. Maybe working. Yeah, so one thing to note on these videos is that the model is going to remain the same. The quantizations remain the same. The only thing that's different is we're going to look at an Intel CPU and an NVIDIA GPU.
Let's explore how GPU acceleration transforms AI inference speeds compared to traditional CPU processing. CPU inference runs on AO Loader, the foundation of AO's legacy network. GPU inference utilizes IWASM,
We might
For
need that backup
VAM's
help.
WASM runtime powering AO mainnet. They both use the same prompt.
Sort of semi-expected technical difficulties. We're not going to have sound on this one, though.
Which requires AI to refine copy. GPU completion time, 1.
Run the video. I can't use that. We don't have the extension. Yeah, it's not loading at all.
179S. A few minutes later. CPU completion time, 393s. While the CPU took 393 seconds, the GPU smashed it in 1.179 seconds. That's 350x faster on pure compute power. Plus, GPU's dedicated memory handles heavy loads smoothly, while CPUs struggle with bottlenecks. In the AO ecosystem, deterministic is non-negotiable, but GPUs face unique challenges here. APIS ensures determinism by, first, using integer quantized models to simplify precision control. Second, strategically disabling non-deterministic GPU optimizations. Let's see the AI inference comparison between NVIDIA L20 and 4090. Both of the prompts are the same, which asking AI to continue writing after once upon a time. NVIDIA L20 output, 445 tokens end with a new life for themselves. NVIDIA 4090 output, also 445 tokens end with a new life for themselves. Bit-for-bit identical outputs, and even after multiple runs, the result is still remain the same. Deterministic. While sacrificing 15 to 50% potential speed gains, APIS's GPU integration maintains AO's determinism standards and enables verifiable AI computation.
Okay, so I think hopefully people managed to get the first part of that video. What we did manage to demonstrate was that the GPU actually managed to process the inference 350 times faster than the CPU. And that was just with a really small prompt. If we start to increase the number of tokens we're putting in there, that difference is only going to grow. So for anyone who has been using AO Legacy running AI, and I know some of you have been building on it, some of you have used our competition pools, which it is been painfully slow. So having GPU on AO is going to be something that is increasingly important, especially as I know a lot of us do want to be using AI. And the second video displays that we now have the determinism model running. It is running there on the same WASM runtime that is used on Hyperbeam. And we have it running across 2 different NVIDIA GPU cards there. So at this point, people may be asking, why do we need deterministic, right? Why do we need to be getting the same results? And this can be used in anything across the people are developing, whether you're looking at AgentFi, whether you're looking at trading bots, anything you're looking for, is going to possibly require determinism. But perhaps most importantly is we're trying to build on-chain verifiable AI, and one of the easiest and best ways for us to prove that we can have on-chain and verifiable is if we keep those deterministic standards, which are sort of the core of AO's compute as well. So hopefully that demos something, and we will have something live for you to actually test. Like I said, we'll hopefully not play them again. Coming back to sort of what we've done otherwise, it is sort of AO and Forward Research have been pushing the fair launch season and the perma-brawl. Big thanks to Drew for that one. Why was the fair launch important for us? We came, the AO ecosystem we want to follow the same ethos, right? AO was probably one of the first purely fair launch tokens that Web3 has seen for a really long time. And it's really nice going back to that because early days of Bitcoin, that was the idea, right? So we thought, well, we'll go with that and we'll continue that. And hopefully this also sets an example for others in the space. And I know that we're not alone, right? There's a lot of us doing this. And I feel that it's really nice to see a Web3 ecosystem sort of following in that suit. So we had our TG, that was in December last year. We had 7 million assets bridged within the first 7 days. And then on March 14th this year, we will be joining the Pi Index too. So as much as that's bringing exposure for us, we're also really happy that's going to bring exposure to the broader AO ecosystem. And then just regarding the permabrawl, Forward Research have been really generous. They are offering 3,142 Pi tokens, AO tokens, across 4 different companies. So that's ARIO, that is Bazaar, that is Basejump, and that is us. So just come out, check it out. It is the QR code on the right. They're really easy competitions. You have a chance to win some of those. It's quite a huge amount of money and dollar value. So do just, it's a little bit of fun as well. You're interacting with a digital version of Sam Williams. And then, sorry, Sam. And then you get to post that on Twitter as well. So not only do you get to interact with him, you get to share his response. We take no responsibility for his replies on that one. But yeah, please do check that out. On the left, you'll find the link to our website. Our mint is live, delegations are open. And yeah, really happy to be here. And yeah, thank you guys.
Thank you so much, Connor. For our next speaker, there are certain people in this world who you only need to know their name and you already know everything. I'm talking Elvis, I'm talking Bono, I'm talking Phil.
Hey, everyone. Okay. Display settings. Okay. All right. How's everyone doing? I see a lot of familiar faces. That makes me feel really good. I feel like I know everyone in the ecosystem. Some of this might be repeat for you. You might already be familiar, but glad to talk about RIO, Permanent Cloud Network, and really what it does and what it even means. So thank you again, Forward Research, for having me here, and let's get into it. You guys already know who I am. I've been in the Arweave ecosystem since 2018. I quit my job and founded PDS and started with R Drive in 2020. So it's been a heck of a ride. Last week we launched the RIO Network mainnet. So today I really wanted to focus on that and talk to you guys about its benefits and maybe how you could take advantage of it if you already are not. So while Arweave provides this foundation for permanent storage, RIO really builds the infrastructure and services to create the world's, what we like to say, the world's first fully permanent and equitable cloud network. It's an open source cloud, and it really provides storage, hosting, data access, really without any subscriptions or centralized control. And we like to think we're trying to really set this new standard for cloud infrastructure in general. And that's based off of a few pillars, we call them, right? So it's a network that's obviously resilient, right? No single point of failure, incentives that can keep the network self-sustaining, so no single team could go away and falter the network. And it's censorship resistant, right? No single team, person, node, et cetera, can take anyone's voice, can remove their content, and so on. All of the data stored on this network is stored on Arweave, right? So it's timestamped, tamper-proof, and it's there indefinitely. Very unique property that you just don't get with other Web3 systems or Web 2 for that matter. One of the amazing things I think about this cloud is it's interoperable, right? Meaning it can integrate with other chains. You can bring different kinds of wallets to it. You don't just need an Arweave wallet. It supports different kinds of signature types. So that's really useful for bringing in people in other ecosystems. You can pay in different kinds of currencies. It's not locked to one specific token. And it's got this very familiar tooling setup that you might be familiar with if you're in Web 2, because it uses languages like JavaScript, TypeScript, Lua, etc. There's no special language you need to learn to build on it. It's sovereign by default, right? Users own their data. The apps deployed are user rights preserving. Everything is cryptographically signed, so it really provides this strong digital ownership. And we've designed the whole system to be on premises, right? It's not built to just be run as a SaaS. It's built to run at any kind of scale, whether it's a tiny, Raspberry Pi or, really beefy servers. And finally, it's transparent, right? And this is something you don't typically get with the normal clouds, right? Everything is open source. There's a clear record of data provenance for any action that happens because it's all stored on a public ledger, which is Arweave. So our vision is really based in these principles, and you'll see this be applied through all the technology that we're creating. As I mentioned, both types of clouds have all the tools you really need to build modern apps that scale, right? And whether it's doing things to store data, index it, retrieve it, or just a generalized compute platform where you need to create anything you want, really both clouds offer that. Sure, the traditional cloud does have things like SLAs and strong customer support, and it's widespread. It's adopted everywhere, right? Every business has some connectivity to some cloud somewhere. But really the advantages of the permanent cloud really can't be denied, whether it's the payment models, the censorship resistance, the immutability, provenance. There's a lot of really unique properties that you get beyond just storing data for a long time. Let's maybe drill into some of the specific services that the RAO network provides, because it does a lot, right? Gateways aren't just accessing data. They do uploading, right? Whether that's layer 1 Arweave transactions or layer 2 data items or bundles. The gateway comes with a bundler that can do that, right? It could also has very intelligent chunk broadcasting. As you might know, data on Arweave is all broken down into transaction headers and chunks. So the gateway comes with a specific broadcasting feature if you do need to, re-upload or broadcast chunks out to the broader Arweave network. Of course, gateways, I think they're first and foremost used to access Arweave data, and it does that through a contiguous file cache, right? Again, data on Arweave is made up of chunks, so there has to be something to assemble all of these. So the gateway is responsible for doing that, and it'll cache that in a local cache for really fast access. It'll do things like render your files, your PDFs, your JSON, your documents. It will stream your videos, your music, right? It will render your full apps and pages thanks to Arweave manifests, right? It'll provide this access optimistically, meaning if data has been uploaded through a gateway and it hasn't been mined on chain yet, the gateway will still serve that out, right? Because users and apps expect it to be really fast. And then finally, it's really providing an access layer for the rest of the Arweave HTTP API, right? So whether you're fetching prices, transaction information, wallet balances, you could do that all through a gateway. It features the domain name system RNS, so whether that's buying and managing configuring domains, resolving them, looking up IDs for friendly names, all of that is kind of baked into the DNS services. Gateways, as you might be familiar with, are also responsible for indexing all of that data. By default, a gateway will index everything on layer 1, but gateway operators have the ability to tune any kind of layer 2 index, whether that's specific applications or maybe just personal data. It's really flexible to do that. And then gateways provide a GraphQL interface on top of that to make it really easy to search for that data. And similar to optimistic caching, a gateway will take any of the data that's ingested through it, and it'll optimistically index that as well, so you can find it really quick. I have a box here for just general compute. Technically, these pieces aren't in the gateway itself. It does ship with an AO compute unit right now. That'll probably change in the future as things get more hyper-beamified. But as I mentioned before, you can use other chains for some of your smart contract work, right? AO is the native platform for the RAO network. But before AO, there were plenty of teams building smart contracts on Ethereum, referencing data stored on Arweave for NFTs and other things. And finally, the gateway comes with a set of some management tools, whether that's monitoring the gateway itself. It comes with a nice Grafana dashboard. It has an ETL process to extract any data, transform it, load it into the index. We use Parquet for that, so it's pretty interesting there. It comes with tools for content moderation. Each gateway operator basically gets to decide, right? That's one of the differences between a centralized cloud and this permanent cloud is the content moderation has been kind of democratized to all of the operators versus a single central controlled corporation. And finally, the last, and possibly one of the more important management tools in the gateway is the Network Observation and Reporting System, or the OIP. And that's what gateways use to monitor one another, report on the performance, the availability, uptime, and that's what determines what rewards the gateways received. So clearly, there's a lot of things happening in the gateway. It's taken us a long time to build all these pieces, but it's, yeah, similar to maybe AWS that has a whole suite of services for developers to use. I think a lot of you are probably familiar with RNS. I don't know, maybe raise your hand if you have an RNS name. Raise your hand if you've set it as your primary name. Okay, I want to see more hands up for that. But yeah, RNS is really one of the key features that and innovations that we came up with. Friendly names for apps, pages, data, identities, maybe hash paths. I don't know if that makes sense. Maybe, Sam, I don't know, you got to think about that. You can buy a name with a lease or purchase it indefinitely, and all of those proceeds go to the gateway operators. There's no DAO, there's no central company that receives this and then decides how to fund things. It's all controlled by a protocol. So really unique to RNS versus other Web3 name systems. And the cool thing is, it's not just a name for an identity, it's a name for data. So you'll be able to access it on any of the gateways in the network. There's, I think, 280 or so gateways. So whether it's rdrive.volanarios.com or rdrive.arweave.net, so on and so forth. It really provides a high level of resilience. And then if you're buying a name, you also have subdomain space, or we call them undernames. So you can deploy other applications, assign different identities, similar to if you purchase a domain name, you might have many identities that leverage that domain. And then finally, we built a really easy to use app for anyone, but there's also a powerful SDK if you wanted to build your own version of this, whether it's buying names or resolving primary names, etc. Lots of names out there already. Here's just a few examples of the different front ends, apps, pages. Shout out to any of the teams who are on here. I did not mean to exclude anyone, but yeah, and now what RNS really enables is what we call the Wayfinder protocol, or AR://. So you can actually obfuscate the domain name completely by using this new schema. So effectively, you don't need to even remember what domain to access your data on. We released a little Chrome extension called Wayfinder that does this, but apps like Wander also have it built in. So you could just type in AR:// and your name, and it'll route you to a high-performing gateway. So what can you do with it? I mean, lots of things. We see a lot of websites and apps. I just showed a bunch before. Lots of different games are getting built, whether these are just the front ends or even the assets too. I know there's some folks in the audience working on some really cool games now. File storage, that was what got me into this whole thing with rdrive. The beauty of that is you have all this rich metadata for any of the files that are stored. So that could include things like your any information architecture or a license, right? Which is very applicable in today's day and age when content is getting scraped by these AIs and users are not necessarily they're not necessarily getting referenced by these AIs. So storing any kind of data has always been the sweet spot, and it doesn't have to just be static data. It could be NFTs or digital assets. Again, whether those are AO based or on other chains. So we see a lot of use cases. We're always trying to grow these, and this doesn't necessarily have to just be Web3, right? There's plenty of Web2 use cases as well. Again, the system has been operational for a long time. I know we just went into mainnet recently, but this is just an example, shows how it scales, right? 200 plus terabytes of data, billions of data items. We all see that number growing every month. And just an example of how many unique users are connecting to rweave.net. Almost 1 million on a monthly basis, right? So that's kind of crazy to think about. And sure, that's not people uploading data, rather uploading and consuming it, right? So it's great to see these numbers grow. But yeah, are you actually ready to build something on it? There's lots of tools that we have, whether it's the RAO SDK to integrate with RNS or the network. I have the wrong link there. You don't go to the Wander app for the RAO SDK. The Turbo SDK is for any uploading of data or paying for those uploads. Again, whether that's with a credit card or Arweave, Ethereum, more cryptos coming soon. If you're looking for a no-code app deployment solution, highly recommend R-Link. Again, I messed up the links here. MetaLinks is actually a nice little homepage builder. PermaWeb Deploy is excellent if you want to try a GitHub CI/CD integration, so you can update your app and then have those updates get pushed right to the cloud. And then we have all kinds of quick start guides for helping everywhere in between. If you're not a builder, that's okay, because you can still use this pretty easily. If you want to actually write data, of course you're going to need a wallet. Highly recommend Wander, the new rebranding of RConnect. Although, as I mentioned before, wallets like MetaMask are also still supported, and more support will be coming. RDrive, give that a shot. You can just pay with a credit card, make a little homepage like a link tree with MetaLinks. Of course, get a domain, and you can apply it to either your identity or your homepage, or even just listen to some music, right? I mentioned before, like gateways are great for streaming. Someone built a little Grateful Dead tribute app where you can stream some cool tunes there. And this point is really, this is a cloud that's not just for technical people. Anyone could really use it. I slipped this in, just now. Just wanted to give some hints at what's coming next. After mainnet, it's been mentioned before, but we've been included in the PermaWeb Index. So really excited to leverage that as a way to distribute our tokens to the community in a permissionless, protocolized way. I showed the big chart with all of the different gateway services. Not all of those have protocol incentives, right? So we need to build out more of those. We need to onboard more gateway operators. We just completed the Gateway Operator Incentive Program and got, I think, 29 bigger teams and projects to run gateways. It's not going to stop there. We have a whole lot of hyper-beamification that we need to do, and we're still unpacking that and understanding how we could apply the different functions of a gateway onto AO Core, and how we can maybe leverage T's and some of the other features there. We're going to do a big push to integrate all of our tooling into third-party libraries. We've built a lot of stuff. It's time to get it out there and get it integrated. Now that we've launched mainnet, we are going to start a new grant program as well. So more to come there for any builders who have some really big ideas that they're looking to explore. And then really, it's just about adoption. Again, I see a lot of familiar faces in the crowd. I would love to see more people who I've never met before, right? So we're really going to focus on, getting new users, new developers, new founders, and just, broaden the usage of Arweave, AO, and the permanent cloud. Invite you all to obviously follow us, build with us, give a little QR code scan here, fill out our partnerships form if you're really interested in working more closely. And we'll be at the conference the rest of the week, so come say hi, and thank you.
record that I just set is currently updated with the record that I wanted to set. So just kind of checking afterwards. And one thing you may find is that when I set base names or I do deployments or anything like that, on the deployment, I do not build into the script the build then deploy, specifically because I want to see the size of the file or the size of the project before I deploy. Lots of times I've been building applications, I may forget, man, I just put this image in there and it's huge, it's 25 megabytes, and then I run deploy and I'm like, oh crap, like why is this build folder so huge? Make those modifications before it actually runs in there. So what you end up having to do is you end up simply just running the PM build. So you run the build, and then right after that, you just PM deploy. And that does your deployment from there. Oop. There we go. Okay, so we're all good, and all you have to do is just copy your transaction ID. Now, I want to go ahead and just set a undername in here. I've already preset some of that here, so I'm just going to change this transaction ID here. Save that, PM, and then set undername. There you go. So you've already, at this point, you've built the application. You've already deployed it. Then you've already set the undername. So at this point now, I can actually just run over here, go over to my undername, and we're good to go. That's super fast. Has anybody seen a fully decentralized front end deployed that quickly? I mean, that's really, really fast. So this starter kit is ready for you right out of the gate. So if anybody wants to use this for the actual hackathon, that's what I built it for. So for anybody that's building in the hackathon, I really, really encourage you guys to use this. Some upcoming features I'm working on is just more repos specifically for other ecosystems. I actually had a lot of fun yesterday at the Monad Hacker House. Grabbed somebody else's starter kit, added all these implementations into from their starter kit into mine, and then deployed that. And a lot of the Monad developers really, really loved it. So you're going to see more repos like that. You're going to see additional features, and instead of just being able to pay in turbo credits, you're going to see additional features of being able to pay in other currencies as well. And then last but not least, there will be some AO features in the back end pretty soon. I'm working on a repo that has that full stack application experience of having everything deployed on the Arweave ecosystem using a starter kit like this, but with AO functionality using AO Connect. And then last but not least, repos for NFT image deployment and transaction ID management. I mean, imagine having a whole folder of images to be able to drag and drop that and just run one single script and then have it save all of your transaction IDs or your URLs to those images in a manifest folder. I mean, that's the easiest, fastest way you could do something like that. So aside from that, if anybody wants to use that starter kit, it's right there. Go ahead and grab it from the QR code. And that's it, guys. I did that in 7 minutes, right? Yeah.
The coolest things I've seen, and I've seen a lot of cool stuff today. But that is not to say that what Tate from Community Labs is about to show couldn't one-up it. Tate, we're so excited to have you here, and people watching at home, people in the audience, I know we're at the halfway mark, so give it a big stretch and get ready for 2 more hours of some of the coolest stuff within Web3. Tate, take it away, man.
Thank you, Drew. All right. Thank you guys for having me. I wanted to start today off with a story. Our team has been building on AO for nearly 1.5 years now, which is kind of crazy to think about looking back on it. But over the last 1.5 years, the state of AO has changed quite radically. It's become more stable, it's become more scalable, it's become more performant. But I was reminded recently of a movie that I watched probably 5 years ago. It was one of the Superman movies. And in the Superman movie, they were trying to understand, Clark Kent came in on this spaceship. They were trying to understand what the spaceship was made of. And essentially, thank you, Sam. Essentially, the spaceship, the scientists couldn't figure out what the spaceship was made of. And so there was no way to actually characterize it. They couldn't describe the material because it didn't exist on our periodic table. And after building on AO for the last year and a half, I continue being reminded that we are dealing with what seems like alien technology because of how far out in front of everything else in this industry AO is positioned as. So, we're talking about a lot of complex terms here, a lot of new concepts, new primitives. But the truth of the matter is, if we try to put it in the box of everything else that exists in crypto today, it just wouldn't do it justice because it is so different. And so that's one reason that I get excited about AO. I think I'm excited about building on alien technology. I guess that makes Sam an alien as well, a little bit. No offense. And I wanted to spend today to talk for a second about one project that we're really excited about that kind of pushes the boundaries of AO. Something that's been really cool, there are really 3 features inside of AO that we're especially excited about. TEEs, WeaveDrive, and then WebAssembly. Maybe going through each one by one. Sorry, got ahead of myself. TEEs give you the ability to run computations in private, in a verifiable and deterministic way. WeaveDrive gives you the ability to then go look at Arweave and fetch information. And that information could have come from anywhere. It could have come from inside of Arweave, it could have come from the web. And use it as if it were data on your own machine, which is like tremendously powerful. And then WebAssembly, so generalized compute in all kinds of different programming languages that can compile down into WebAssembly. It's sort of the standard outside of crypto, and now AO makes it possible to use inside of crypto, which gives you a lot of abilities. I'll go into that. Putting it together, though, one of the interesting use cases is building agents that are capable of signing and posting transactions from inside of AO onto other blockchains. Agents are really cool in crypto right now, and it's insane that you can actually build an agent to interact on other blockchains inside of AO as a decentralized supercomputer. So how might you go about doing that? That's some research that we've been doing. The first step would be to generate private keys inside of the TEE. The reason a TEE is helpful for this is because if you're generating a private key and publishing it to a blockchain, generally that information would be public, and you don't want anyone to have access to your private keys. A TEE is perfect for this because you can create an environment where those keys can be generated deterministically in a verifiable way without being revealed to the public. The second thing you could do is you could leverage WeaveDrive to read data from Arweave about other blockchains. So for instance, Redstone is uploading a lot of data about other chains into Arweave. Kive is doing the same thing. We can pull that data into a process on AO through WeaveDrive and use that to be able to make decisions. For instance, if we're building this cross-chain agent to trade, you can make trading decisions off of it. And then third, the intelligence. So WebAssembly, WASM64, it gives you the ability to take large language models like Llama in C++, compile them into WebAssembly, and then run them inside of AO. Huge, like you can't do that anywhere else by a long shot. And so we're really excited that that's possible in AO because it enables these processes to make decisions that are informed off of data from other chains in a way that is cost-effective, super fast, and decentralized. And then fourth, you can also generate and sign transactions with those private keys. So once you've figured out the decisions that you want to make, you have to assemble a transaction and sign it. You can use the private keys that you generated inside of the TEE to make that possible, which you can then cryptographically sign. You can also use like MPC technology if you wanted to make that even more secure. And then fourth, you could use some type of oracle to take the data that was returned to you from AO to post onto another blockchain. Or you could do it yourself if you wanted to. That's really insane. You can make Bitcoin transactions or Ethereum or Solana transactions from inside of AO. Why does this matter? Everyone is talking about agents right now, but all of the agents that people are talking about are evaluating things off-chain. They're making decisions off-chain. They're running on centralized servers. They are not inside of crypto. They don't really act in Web3 aside from the fact that they're generating transactions and posting them. It's not scalable. It's if anything, it's false marketing. And AO is the only place where that can be done on-chain. One more just fun tidbit, I guess. We've been working really hard on building a better user experience for accounts inside of AO. Obviously, Community Labs is the team behind Wander. Thank you to everyone on our team that's made that possible, and thank you to the community that has also adopted it over the years too. Excited to announce that coming soon there will be a single sign-on option introduced that will make it even easier for your consumer-facing application to generate Arweave wallets and make transactions with a UX that is equivalent to Web 2, but with all of the advantages of AO and Arweave in Web 3. Thank you. With that, I will hand it over to Liquid Ops. Appreciate it.
Hello, can you hear me okay? My name is Lorimer, and I'm the founder of Liquid Ops, which is a lending and borrowing protocol built on... All good? Sorry. So my name is Lorimer. I'm a founder of Liquid Ops. We're a lending and borrowing protocol modeled off of Compound V2, built on Arweave and AO. Okay, so a little bit about our story and how we got here today. Me and Martin had been working in the ecosystem for quite a while. Martin has kind of been in since its infancy. And one thing we both realized was that we held Arweave personally, as well as previously I was a fellow at Community Labs. I worked on a project called Othen, basically a way for anyone to be able to come into Arweave with like a Google account, a Twitter account, and actually be able to onboard into the permaweb without the use of a private key. So we held Arweave personally, and we also had a lot of people coming into our project's Discord. Martin running the Connect one, me with the Othen one, and one of the biggest things that they all had in common was so we hold Arweave tokens, how can we actually earn yield? How can we use this liquidity in different products? That kind of just got us thinking about how can we generate yield? At the time, the only way to really earn yield in this ecosystem was contributing to liquidity pools on DEXs. And all this is super cool to do. We really wanted to have some of these more advanced products that you could see in places like Ethereum actually in this ecosystem. Kind of going into how Liquid Ops works, I think there is a huge misconception of, where yield actually comes from in a lot of these different protocols. Some projects they mint tokens and give them to their users. Liquid Ops, essentially, it works off of three kind of parts you can think of it. So you have lenders, like me and Martin, that held Arweave, like our users, that wanted to actually earn yield on those tokens. So for them, it's super simple. You basically take their tokens, you add them to a pool, and basically make them available to be lent out. So that really brings us to where the yield actually comes from, which is borrowers. I'm going to go more into some of the borrowing products in the next slide. At its core, basically, you take the lender's liquidity, and then you allow borrowers to actually use that liquidity in different products. So we're an over-collateralized lending and borrowing protocol. So the whole idea is borrowers basically have something called a loan-to-value ratio. You often see it as like LTV, which basically just means that in order to borrow on Liquid Ops, you need to add collateral. So for example, if the loan-to-value ratio was, say, 2 times, for every $100 you borrow on Liquid Ops, you basically need to add had $200 worth of collateral. So, someone would lend into Liquid Ops. Those tokens would be available to be lent out to borrowers. Borrowers would add collateral to Liquid Ops, and then the loan-to-value ratio would determine how much they can borrow. So yeah, though that's kind of lending and borrowing its really simplest form. But now we have like liquidators. So say you were like borrowing in traditional finance in Web 2, say it's like a mortgage. You go to a bank and you say, I want a mortgage, and the house actually acts as collateral. If you didn't pay your mortgage, the bank would repossess the house and pay off the debt of that mortgage. Similar sort of thing with like payday loans. You get KYC'd, and then obviously if you don't pay back that loan, the government comes after you and knocks down your door. So with something like lending and borrowing protocols, basically, if the collateral drops below a certain loan-to-value ratio, a liquidator has an incentive to basically buy the bad debt off the protocol, and then basically, have a fee be imposed on the borrower. The liquidator gets that fee and basically repays the initial loan that the borrower took out. So yeah, really simple, its simplest form. That's basically what lending and borrowing protocol is. So yeah, going into some of the things we can create, and this is the really exciting part, apart from having lenders be able to actually earn yield on their tokens. So we're kind of focusing on three main points at Liquid Ops. First one being like leverage, actually being able to enable people, to trade with more than they have via like leverage. This is kind of like the basic stuff, being able to, long tokens, and actually be able to plug that liquidity into different trading avenues. So that's kind of like kind of basis, what Liquid Ops enables with products. So yeah, the second kind of thing would be vaults. In chains like Ethereum, you have really, really advanced DeFi products that we basically want to port over into this ecosystem. The way I quite like to think about it is we're like an island of liquidity that has never really been used in DeFi. And through the rise of AO, we really think it's going to be a super, super interesting concept to be able to develop these things like vaults. So all a vault really is at its core is like, imagine, instead of lending into like a liquidity pool, you can lend into a vault that has a certain predetermined strategy. So it could be like an arbitrage vault. So what you could do is have a vault basically on Liquid Ops where you could lend into the vault. And then behind the scenes, say you lent into this vault, you borrowed, say like Astro USD, and you added Arweave's collateral. You then swapped that Astro USD into like, I don't know, USDC, and then deposited that USDC into Aave. You've basically got an arbitrage where you can utilize your Arweave tokens actually on these, these projects like Aave. So yeah, being able to basically have these customizable vaults in this ecosystem, we're super excited about, meaning that effectively, we'll be able to bring some of the yields that we've been seeing in Ethereum to this ecosystem from day one. And yeah, shout out to Autonomous Finance for that really cool image of an agent. So this kind of takes like the vaults concept, but really, really brings it into what we're trying to do in this ecosystem with a hyper-parallel compute network. So actually, we're going to be creating these things called like intelligent vaults, kind of smart vaults, where, instead of having like a strategy, that just goes kind of like an arbitrage strategy, you can pair a large language model that actually learns adapts over time using this liquidity that people want to be able to lend out in these different kind of more advanced products. So yeah, that ties us quite nicely into, I think, our mission with Liquid Ops at the minute. And yeah, really the first one would be bootstrap the liquidity we have in this ecosystem. This like kind of island of liquidity that's being untapped in DeFi. Be able to, create some incentives for people to come into the ecosystem to, earn yield. I think, a really good validation that we've had recently is the staked Ethereum and DAI bridge. One of the first times where, as an ecosystem, we've been able to have like a really, really interesting incentive for people to pour assets over into this ecosystem. So at Liquid Ops, we really want to carry that on and sort of, have the cherry on top that, for example, if you come into this ecosystem with DAI, you can earn a new portion of AO, and then you can also lend the tokens and earn that interest, or you can, use some of these different products that we're going to make. And obviously yield, being able to earn a sustainable yield on your Arweave tokens, like me and Martin initially had, and our users, being able to have a really cool sustainable yield for the foreseeable future, like we have in some of these other chains, and enable those new DeFi products, like being able to actually trade with leverage in this ecosystem natively, and being able to plug that liquidity into these different strategies that have found product market fit in other ecosystems, and being able to pair the liquidity we have with actually things like autonomous agents, I think is going to be super, super interesting. Thank you very much. Recently, we just shipped our testnet. We're kind of gathering feedback on what this ecosystem kind of wants with lending and borrowing. And feel free to check out these links, as well as I'll be doing a talk in the next, little bit of more specifics of liquid ops and giving a little demo on it. But thank you very much.
Thank you so much, Lorimer. It is a Community Labs Palooza up in here because next we have Kadar. Kadar, take it away, man.
Hey, everyone. Thanks for having me. Let's see if I can do this. I'm Kadar, founder of Astro Labs. I'm going to talk about driving liquidity for AO and what that takes and what we're doing on our side of things. So, I could talk about AO, but I think Sam and Tate and everyone else kind of covered it. So, let me just cover the basics. AO is a new city that requires new utility, and essentially it has unlimited potential. But one of the key things we think it's missing is liquidity. So that's what I'm going to talk about today. So for any economy, you essentially need a way to transact, save, and essentially navigate the ecosystem. And we think we can build a robust model around Astro liquidity pools, stablecoins, and kind of yield generation activity, and kind of bring a lot of value to apps like Bottega, Liquid Ops, and GameFi, SocialFi, anything like that. I'm going to get into a little bit of what that takes. Honestly speaking, we kind of need it. Right now, we're transitioning to mainnet that has a lot of quirks, but is going to be more scalable, meaning that we need liquidity infrastructure that's also scalable along with the chain itself. And that's what we're going to try to build. So why does liquidity matter? Any functioning economy, doesn't matter if you're a blockchain, a city, a country, you essentially need a way for movement and value to be exchanged, and the permaweb needs a stable value and liquidity infrastructure, and that's what we think we can build. So essentially, this is how we think about assets, liquidity, and we want to create this little flywheel. We're going to start with assets first, stable value second, yield generation, and then value share with ecosystem apps, developers, builders, agents, and then we're going to create more assets and kind of kick this flywheel into gear so everything kind of keeps rolling. And right now, that's what we think we can start with USDA and partners like Bottega, PermaSwap, and Liquid Ops, of course. So we're thinking about stablecoins a little differently. We think in the early days, we need to kind of bootstrap and unify liquidity and kind of have all dollars, all chains into one stable on AO so liquidity doesn't fragment. We can see a clear example right now where liquidity is kind of fragmenting between QR and WAR. Some people use Quantum, some people use AOX, and we think a better model would be to essentially introduce a way to defragment. And that's what we want to do with USDA. It's going to be a unified stable dollar on AO, and we're going to push liquidity to its extreme, essentially unifying everything. So if you want to trade, save, transact, if you're an agent, if you're a user, if you're a builder, USDA would be the deepest liquidity pool you can use and access and essentially capture value. So high level, I'll send you a couple of documentation if anyone wants to nerd out about liquidity, but we want to build what's called a liquidity engine and kind of have three pillars to this engine. First is going multi-chain, having multiple pathways into AO. We want to create a on-ramping gateway. Essentially, we need a way to connect the real world to AO. Right now, getting into AO and Arweave is really tricky, and we think we can cover this pillar very easily with USDA. And the last bit is around tokenized assets. I know no one wants to hear it. We're all about the tech, but we need more assets on chain. Everything's been tokenized. It's time, stocks, everything. And we kind of want to bring that engine into AO, allowing different ecosystems and different economies to exist on top of AO, whether you just want to trade stocks or different assets, or you want to build social apps or games. Right now, there's a few apps live on AO LegacyNet, and we think they're going to transition to mainnet and more apps to come. But the kind of key areas we're seeing is marketplaces, launchpad, DEXs, lending protocols, and social. I haven't mentioned gaming. I think you're going to be the first gaming app, or maybe second, but that's going to be an interesting category for us as well. What USDA does differently is essentially we capture some value by the collateral locked in USDA, and that's what we're going to bring to apps that are adopting USDA, kind of having this shared value exchange, and then kind of kicking off this flywheel where we capture revenue instead of being extracted by other centralized stablecoins. We'll bring that value back to the ecosystem, and then apps can kind of, again, use that to expand the team. They don't need to fundraise as much. Of course, there's AO funding raise, but we think we can push that to the extreme by having stable yield generation brought to AO. For app builders, there is a savings rate to be brought at some point in time for users of the chain, but that's, you can go anywhere to get savings rate. We think on AO, in the early days, we need to bootstrap early developers and teams. We've been saying USDA is coming soon for the longest time. It's coming soon this time, and I think within a couple of weeks we can announce how USDA looks like, what version 1 looks like, what version 2 looks like, and we're going to be working with key ecosystem teams like LiquidOps, the Autonomous team, and Permaswap team to essentially bring USDA to liquidity pools so people can trade, save, essentially capture value in native USDA on AL. These are some of our launch partners, including Community Labs and Wonder, and we think we can push this to the extreme by partnering with teams that are native to the ecosystem, that are here in the beginning and will be here a decade from now, and that's what we're building towards. We're pushing some updates. Let me be honest, Quantum has been finicky, but we're pushing some updates over the next week or two to update the user experience, update how it works, the speed of execution. And when we launch USDA, we're just going to revamp the whole platform and kind of launch version 2, which should allow you to bridge any asset across at least 4 or 5 chains we think we can support by implementing a new intent framework. We haven't been publishing a lot. We've been kind of heads down building, but soon we'll be starting to publish light papers, white papers on how the intent layer would work into AO and kind of the model we're trying to complete. Try Quantum, reach out to me on X, Telegram, reach out to Tate, I guess. He'll let you know what my details are. And yeah, thank you for the time, and I think that's it.
Okay, guys, I don't know about you, but I could go for a Huel right now. Anyone got one for me? Sam? No, not so much. Our next speaker is Ms. Wenshin Turing, talking about the future of sovereign finance. Wenshin, it's a pleasure to have you.
Hello, everyone. My name is Turing. I'm from RV SCP Ventures. I take in charge of the investment here. And it's very happy to see many old friends and new friends here. I'm very excited to introduce you FusionFi protocol and its native token, FFP. Before we get started, let's think about one question. If DeFi is truly decentralized, why do users need to deposit their funds into a smart contract? In protocols like Uniswap and Compound, users need to authorize their funds, but FusionFi protocol will completely change this. FusionFi protocol represents a new model in decentralized finance, the 4th generation DeFi, which solves the interoperability issues of traditional DeFi, will bring a new concept of individual finance sovereignty. Unified settlements via node flow across asynchronous network, especially AO. After years of development of DeFi, DeFi have different stages. From 2018 to 2020. So they're only decentralizing some basic finance information like Uniswap, RV, and also Compound. Then the second generation DeFi comes here, improving capital efficiency, such as Olympisto, TokenMat, and also the third version of Uniswap. When time comes to the third generation DeFi, it's almost after 2022, enhancing the collapsibility, such as EigenLayer, Pendle, and Radiant. Although DeFi has improved, it's still facing some limitations. Let me give you some example. The liquidity fragment. So different protocols have different liquidities. So make them very hard to get efficiency. So the result is a very low capital efficiency. And users are also restricted. So every smart contract has their own rules. So the contracts take all through the financial operatings instead of controlling by users themselves. And also lack of interoperability. So different protocols follow different rules, and it's really hard to integrate. To address all these issues, Fusion 5 protocol was born. But how Fusion 5 protocol works? Fusion 5 protocol is not another DEX or learning protocols. You can think of Fusion 5 protocol like a financial Lego kit. You know, the secret weapons are nodes and agents. You can imagine that the nodes are a universal market, a universal money. You can trade, learn, earn all in one language. No more conversations. So all the operations are based on node flow using a common data structure for simplification. And unified settlement layer enables cross-protocol and cross-financial scenarios interoperability. And everybody knows the ability of AI agent is very powerful. And AI agent is your robot assistant. You can set your rules and make them to execute, and funds still stay in your own wallet. Users can create their own financial agents without need any custody. So, for example, let me give you an example. If you swap token A to token B and borrow them on Aave, normally they will need 5 steps and 3 approvals. But with Fusion 5 protocol, there only will be 1 step and 0 approval. So that's what Fusion 5 protocol do. Why it matters? It's about Fusion 5 protocol solve the problems of interoperability, and we do care of the user sovereignty, and we improve the capital efficiency. But Fusion 5 protocol is not just a concept. It has real applications. For example, PermaSwap. The biggest DEX, AO native DEX, and has a very large transaction volume. And PermaSwap, you can set your own fees, funds stay in your wallet, and the profits will come directly. And also Legend. Set a bank, you can set the rates and let all the AI assistant to help you to management your funds. And also Rainbox. Rainbox is an AO native Minecraft game and easily to build an integrated trading marketplace with Fusion 5 protocol. You can think about that in the future. Every DeFi protocol can upgrade with Fusion 5 protocol, just like upgrading your network to 5G. And that's what's going to happen in the future. Let me give you some data about after Fusion 5 protocol launch. And after protocol launch, just about few weeks, there are over 29 million total settlement amount, and PermaSwap volume is just over 18 million. And over 75% of AO volume is in PermaSwap, and AO liquidity is over 67%, hits 4 million. So I believe that in the future, Fusion 5 protocol and PermaSwap will have some impressive data performance and to continue to maintain the leading position. And also, for sustainable development, we do have governance token. The role of the FFP token is to incentivize the protocol participants, governments, the ecosystem development, and also backboard the fourth generation of DeFi. FusionFi protocol and FFP token, you can imagine that FFP token is just like the furrow in the ecosystem with the fair rules. As you can see that there's no VC and no team allocation. The total supply will be 18 million, and 5% is for airdrop for the early adopters because they made a great contribution in the past few months. And 1% is for initial liquidity, and 94% is trained to mine. So we do have halving cycles. So the supply will reduce 50% every 4 years. It's just like the Bitcoin model. Scales like Bitcoin, the early bird wins. And we do have incentive about the transaction is mining. So the more you trade, the trade to mine every time a node is settled, the creator receives FFP as a reward. And 94% from trade to mine, more trades, more FFP. And you can also stake FFP to gain VFFP tokens, and you can also vote like a shareholder. And all the profit generated by the protocol is stored in the treasury and funded by the settlement fees. So by staking FFP tokens, users can obtain VFFP. It's just like the Curve's VFFT token model. So in summary, FFT token is not just a reward token, but also a governance tool for the long-term and sustainable development for the FusionFi protocol ecosystem. So FusionFi doesn't kill Uniswap and Aave, but make them better. In the future, everyone is their bank, exchange, fund manager, and this is the fourth generation DeFi. So will you still keep trusting others to manage your funds, or take control by yourself? Together, let's explore the future of decentralized finance. If you are interested in FusionFi protocol, please follow our official Twitter here, and you can also scan a QR code to join our community here. And we hope to build with you together. FusionFi protocol is all you need is the fourth generation DeFi. Thank you very much.
We have people from all over the world coming here to speak at our conference. Appreciate you so much, Turing. Next up, we have Alan from Randau. Alan, I can't wait to hear what you have to share. Thank you so much.
Thank you. Can I pull it out? Yeah. Okay. Okay. All right, let's get started here. Sure. All right. Good afternoon, ETH Denver, and especially good afternoon to the Arweave AO community. I'm Alan, and at Randau, we are solving the on-chain randomness problem once and for all. Before I get started, I do want you guys to answer a quick question. Heads or tails? If you think I'm going to flip heads, go ahead and raise your hands. All right, and tails, who are my tails? All right, about 30% tails, interesting. Let's see. That wasn't a good flip. My flipping is a bit off today. There we go. Sorry about that. We got tails. Now, that was interesting. As the coin was in the air, we were all very uncertain of what the outcome would be. And what's also interesting that we weren't able to influence that outcome once we'd flipped. That is the heart of what randomness really is. And at Randau, sorry, if only it were as simple as flipping a coin to generate randomness on-chain. The on-chain randomness problem has really plagued the crypto industry for years at this point. When we first started out, we were trying to use math.random, which really is more like math.pseudo-random, which doesn't quite work in blockchain since it's a public, open, and transparent environment where you could already see the seed on chain. Next up, a few people tried to use the block hash, which made some sense initially. It sort of starts to make sense as the block hash, it's a hash, and the hash output is typically random. However, when we get down to it, miners have the ability, or validators have the ability to influence that block hash. So that wasn't quite going to work for us. And more recently, the crypto ecosystems come to use oracles as a solution for randomness, which works to some degree. Unfortunately, one, they have high costs for no particular reason, and they're centralized. You actually have to be able to trust that oracle and that they're not going to use their prior knowledge of the randomness beforehand to gain some advantage. At Randau, we're solving the on-chain randomness problem like no one has ever seen before. We are crowdsourcing random values and aggregating and verifying them on-chain. With our horizontally scaling economic security model, we're able to guarantee that no one in the world will be able to predict or manipulate our random outcomes. Let's find out how we do it. You might think these two are a bit familiar. Here we have Morpheus and Agent Trunk. We're going to run through a few scenarios to understand the security components that exist in Randau's protocol to generate us high-quality randomness. So first up, both of these individuals, Morpheus and Agent Trunk, will have to post an amount of collateral, which we'll be able to incentivize them with. In a simple solution, Morpheus may just post a random value on chain. We'd wait a sec, and subsequently, Agent Trunk would post his random value on chain. With some of the properties of entropy, we're able to effectively say that random plus random equals random, a new random value, that is. Some of you may have noticed that we have to remember here, it's Morpheus and Agent Trunk. Agent Trunk he's malicious. If he sees any opportunity to manipulate or predict the random outcome beforehand, he's going to take it. And once Morpheus has posted his value onto chain, Agent Trunk is able to see that value. And he can change what he's going to post to chain in order to be able to predict the end output, which is not a final solution. How we've solved this problem at Randau is actually very interesting because we use AO's hyper-parallel capabilities to be able to do it. Instead of posting Morpheus's direct random value onto chain, what he'll do is he's going to post a time-locked box. And that box, it has a timer on it. Once the timer expires, the random value within it will be revealed to the entire world. Now, Agent Trunk doesn't quite have an opportunity here, does he? Because he can't see the random value inside the box. And an additional component here is that if he waits too long, if he waits until Morpheus's box has opened itself, then he's going to be severely penalized by that collateral that he posted earlier. So acting in his own best interest and the interest of the protocol, Agent Trunk will have to post his time-locked box on the chain. As this continues, the timers both expire and release both of the random outputs, which then we can aggregate and verify them all on chain. That solution was solid. It would work. It would be secure, and we would be able to have fair random values. But at Randao, we went a step further. We understood that our users were going to need quick, fast random values, and they weren't going to want to wait for those boxes to open. This is where AO's hyper-parallel capabilities come into play. Since AO has parallel processing abilities, we're able to create a key. That key is a verifiable delay function, which allows us to open the box after the fact, but before the timer, assuming all parties have already posted and committed to their random box. With the values opened on time, we'll be able to generate our new random value just like that. And what's truly amazing about this protocol is that its economic security scales horizontally. As more node runners are added to the crowd, we have additional security per their economic stake in the protocol. And the most amazing piece is that it scales any honestly. That means as long as there's a single honest actor, a single agent, a single Morpheus, and a crowd of Agent Trunks, that we're able to hold economic security. This is unlocking new possibilities across AO for types of applications we couldn't see before. Non-deterministic, decentralized applications. We saw a few of them here today, and I was adding to them in the list earlier, where we have gaming all over AO. Gaming has all sorts of aspects, like critical drops, or critical hits, loot drops, and plenty more. We have artificial intelligence, where Apis Network was able to place AI on chain, but they mentioned themselves that they couldn't have a random component, which they could benefit from. We can have lotteries on chain, raffles on chain, and most recently we've had a few randomized NFT mintings, which is very, very fun. If you want to learn more about the deep cryptography behind Randao protocol, check out our white paper. And if you want to find out more updates, check out our Twitter. And if you want to run a node or be a developer and use our random values, check out our website. And of course, remember that Randao RNG is making on-chain randomness as simple as flipping a coin.
Whoa, Alan's got fans? Where's my applause? Just because you did that, guys, I'm gonna give you a 10-minute break. We'll resume here at 6 o'clock sharp, so if you need to take a stretch, go to the bathroom, we're gonna take about a 10-minute break, and then we'll power through the last hour, just because you were so kind as to give me applause. All right, see you in 10 minutes.
Wings tickle nodes into doing things right. Up to do with for do with for do with with do You ordered a moonwalk across gas feet graves. My mainnet's smoother than your mom's VPN saves. Daughter of the Rockies, high-speed high priestess, scales of justice ballast on a mempool express. Next bottleneck, I see mountain crush it. years. Call me well connected, I call it.
Wah, wah, guitar slide. Wah, wah, guitar slide.
Coffee for drip and the lab coat on fire. Sticky note constellation stuck to the ceiling wire. Gas fees are confetti. They rock on P Island. Get homemade in 7/4 time. Shaboom goes the efficiency pulse. The lag runs lagging in his latency sub. Professor Way's got the future on spinball. Urging notes dancing where the bottleneck's been. Professor Way's got the future on spinball. Bugging tomorrow with yesterday's ram stains. Velcro boots clicking through blockchain debris. Crypto notes flutter like drunk bumblebees. Optimize the board fins. They cackle and shout. Self-sustaining hubs flicker in the blackouts out. Professor Way's got the future on spinball. Urging notes dancing where the bottleneck's been. Professor Way's got the future on spinball. Bugging tomorrow with yesterday's ram stains. Chaos is not compeller, or it's just a bug I forgot to unfurl. Mainnet shivers as their wild hair glows. Rumored AI? Nah, just 3 Red Bulls in a row. What you building, prof? A singularity jukebox. How you stay charged? Espresso straight through my cortex. Who's your nemesis? Light runs dial-up found. Age? Old to speak, young as each block mine down. Professor Way's got the future on spinball. Urging notes dancing where the bottleneck's been. Professor Way's got the future on spinball. Bugging tomorrow with yesterday's ram stains. Throwing me mad, but mad's just a beta test for Boodle. Oh, he just got to do. 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 She's a Colorado Comet in code forged steel, wings snipping latency like scissors through gel. 9 centuries young with a lance that's, if your chain's choking Ethernight whiz. Found her at a bullet hook sucking down APIs, armor clinking with layer 2 lullabies. Scalability scripture, she winks at the moon while Lagron drools over slow motion doom. Her shield's a disco wall, fracturing legs, grass, shooby-doo-bop.
We'll be starting in 1 minute. Starting back in 1 minute.
Alliance architect with a bluff accordance grid, teaching stale protocols how to fucking commit. Decentralize this, she smirks mid-flight as her wings tickle nodes into doing things right. Alliance architect with a buffercorn's grid, teaching stale protocols how to fucking commit. Decentralize this, she smirks mid-flight as her wings tickle nodes into doing things right. Up to do with for do with for do with for do. You ordered a moonwalk across gas feed graves. My mainnet's smoother than your mom's VPN saves.
Okay, ladies and gentlemen, we are getting ready to get kicked off again. Man, these seats are super underutilized. Very comfy. I should have been sitting here the whole time. We've got a couple more workshops for everyone. Lorimer is back to do a deeper dive. Lorimer, can't wait to see it.
Okay, cool. Hello again. Yeah, so in this demo, I wanted to give basically an overview of LiquidOps, have a little look at our testnet, and try to speak about more of really what's under the hood and really how it works. So yeah, just wait for the video to load. Cool. Okay then, so this is basically our main UI. This is where people will be able to come to LiquidOps, basically have a little look at, each different market. So right now in testnet, we're working with Quantum Arweave, USDC, and Staked Ethereum. So yeah, you'll basically be able to see, how much has been deposited into each market, how much is available at the current time to be able to lend and borrow. You'll be able to see how much the interest is, as well as have a little overview of, the amount of assets that you've actually lent. Also be able to see your borrowings. So yeah, then here you'll be able to basically, change the token you're currently viewing. So in this example, using like USDC and Arweave, and then top right, basically click, I have a dum-dum as my profile NFT. We're using actually the Bazaar ID SDK to be able to, you'll have the same profile on LiquidOps as well as Bazaar. So okay, so that was the homepage. Pretty simple, I think. This is really going to be utilized by kind of consumers that really just want to lend into LiquidOps. And here you can kind of see like the markets, what LiquidOps' TVL is. We're in testnet right now, and hopefully one day have $30 billion in TVL. So you'll be able to see basically, the markets, the current assets that have been borrowed in the current market, and also amount that has been lent. And then, here you'll be able to basically claim testnet tokens. Okay, so that's basically, if you're a normal lender coming into LiquidOps, that's basically what you'd see. So if we want to go and have a look at, lend into LiquidOps directly, all you'd need to do on the UI is basically click the Supply Assets button. That opens you up to this portal. Okay, so what's going on here? Basically, all this UI does is build the transaction. So you basically figure out how much you want to lend into the protocol, what token you actually want to lend, as well as be able to see the interest you're going to get and have a little look at the fees. So what we do on this UI is we use the AO Connect SDK to basically build the transaction of all of the data and send it on chain to AO. So the nice thing actually about building an AO and the way we've architected Liquid Ops is that you can just be a normal person with like an Arweave wallet like Wanda. You can use this UI and lend into Liquid Ops. But actually different processes can also lend into Liquid Ops. So if you're an autonomous agent and you have, I don't know, like I've seen some really cool kind of autonomous agents in other ecosystems. Like I think one's called like Eliza or something like Layla. And like I remember a tweet, I think it was by like Brian Armstrong. He was like, we can give you Eliza like a wallet. And natively in AO, because processes can custody funds, that could effectively mean an autonomous agent could choose to lend in Liquid Ops. So yeah, basically here we're trying to figure out how much we're going to lend into Liquid Ops and just basically confirm all of the different data associated with this transaction. So on the back end, basically in Liquid Ops, kind of how it works is we have two main processes. So we have something called an O token, and we have something called the controller. So as we're modeled off of Compound V2, basically, yeah, the O token is like a C token. We're called Liquid Ops, liquidity operations. So kind of an O token is an operation token. This is the receipt that you get when you deposit into Liquid Ops. That basically it's a claim and it's a yield generating asset. So if you hold like O Quantum Arweave, for example, that is basically a receipt of depositing into Liquid Ops and earning interest on that token. So yeah, basically O tokens, whenever you send funds into Liquid Ops, they are then sent back to the user, and then they can use them in different DeFi avenues. So yeah, pretty basic there. There's not many, there's not like many other things really to it. Then all we really do is whenever someone deposits into Liquid Ops, we give them back this O token. So if you can imagine, once a token's been lent into Liquid Ops, basically, yeah, you'll be able to see your balances, see how much you're earning. And on our back end, those tokens will then be available to be used in loans. Again, if you want to like unlend, yeah, you just click your kind of asset section, and you'll be able to actually unlend that token. Okay. So this is where it gets more interesting of Liquid Ops' architecture, the borrowing. So kind of, what we've touched on right now is we've lent into Liquid Ops. The protocol has issued us an O token, a claim to that initial lent token. So borrowing is a little bit different. So as I mentioned in the last presentation, we're an over-collateralized lending and borrowing protocol. So actually you need to add collateral before you are able to borrow. So the way you add collateral is exactly the same as the way you would lend tokens. So yeah, you lend into the pool, and then that basically is collateral that you can borrow against later on. So yeah, exactly the same. As if you were lending, you build the transaction, figure out how much you want to lend and borrow. You can have a little look at your current position summary, sign the transaction via Wanda, and yeah. So once that transaction has been sent, we actually don't send it to the O token. What we do is whenever we want to borrow, we send it to the controller. So all the controller's job basically is to do, as we are cross-collateral, is to have a look, have a look at the loan-to-value ratios of the token you're trying to borrow. Ensure you have enough collaterals to suffice that borrowing amount you want to do. So back to the example, if you want to, if the loan-to-value ratio is 2 times and you want to borrow $100, you need to add $200 worth of collateral. So the controller process basically requests via an oracle. Just via a message from our controller process to the Oracle process, price feeds for whatever you're trying to borrow, and is able to then compare the loan-to-value ratios. And then if basically, yeah, you have enough O tokens deposited into Liquid Ops, and the Oracle has come back that, yeah, the loan-to-value ratio is fine, we basically are able to issue that loan. So yeah, being at quite early stage, and lending protocols being, we basically have architected this that in the early stages of liquid ops, there's a lot of security concerns that basically come into that. So as a protocol, we have basically set out a certain criteria to basically deter potential vulnerabilities with liquid ops. So one of them being we limit the amount of like lends and borrows you can do within a certain time frame. Basically, this is to not overwhelm where AO is at the minute, not to allow like spam to be a reason of a vulnerability. So yeah, whenever we have checked like the loan to value ratios, we also check that your wallet address isn't spamming liquid ops, as well as we have a queue system that basically means that, yeah, things happen sequentially, one at a time, rather than, if someone see you as faster than the other, they can, have their transaction first. So that's one of them, limiting in time frames, but also limiting the amount you can lend and borrow. So yeah, I don't really want to say the project's name because I think they're here, but one project quite recently, within the last couple of years, it's actually made a very, very good comeback ever since this. They suffered the vulnerability of basically a flash loan attack. So what happened is someone borrowed like just a ridiculous amount from the liquidity pool, and basically didn't pay it back because the collateral was manipulated on another exchange, and it basically meant that, yeah, effectively their collateral that was worth nothing because the token was ridiculous got liquidated, and then they basically just kept the loan. So yeah, limiting the amount that you can lend and borrow in one transaction, as simple as that, actually would have deterred this type of vulnerability. So yeah. Okay then, so yeah, basically now, you'd be able to confirm on the UI that the amount has been borrowed. So, Back to the last presentation, talking about some of those products we can create, leverage trading, using it in vaults. We have a really, really simple SDK that, like developers looking to trade will be able to integrate into the applications, as well as natively on AO, having some of these agents be able to send messages directly to our processes, rather than having to go via Web2, via like a normal TypeScript SDK. Okay then, so moving on, liquidating. So we want to have a kind of diversified liquidation, like, I don't know if the word's like kind of arena. Like, we're not only going to work with a certain type of liquidator. Sometimes liquidators are really just like market makers. And I think that's actually quite unfair to the typical Web3 user, because actually liquidations in itself could be its own product. You have some other protocols where you can have like a vault, there's like a liquidation vault, so people can deposit into that vault. They'll be able to, actually liquidate other users on liquid ops, and actually, generate some of those fees and have it, be its own yield generating vault, a liquidation vault. So yeah, we're going to be working alongside market makers, some of these vaults, and then hopefully autonomous agents, once agents sort of mature, to be able to liquidate users, as well as normal people coming onto the UI and being able to see, oh my god, there's an ability for me to make a 10% on the amounts being liquidated. So yeah, we've kind of taken the traditional swapping UI, basically here, you have the normal Uniswap swapping UI, and say if you wanted to liquidate, in this case, we're liquidating staked Ethereum. So we're sending one Arweave that has originally been lent out. The collateral has hit that loan to value ratio that triggers a liquidation. And then obviously, the user would basically be able to see like here how much they're sending, and then here be able to see how much they're getting back, and then obviously here it'll be like the profit. But right now there is no active liquidations on liquid ops. So yeah, that's pretty much it. So we right now, like I said, we've shipped our testnet. Now we're working on integrations with liquidators, integrations with borrowers, and also potential avenues of where we're initially going to get some of those lenders. So yeah, I'll be about until the end of the week. Feel free to come and ask me any questions. But yeah, thank you very much.
We're at the point in the conference where I'm just going to start shouting people's names when they come up to speak. So here we go. Greg!
Did you go into, mirroring, I think?
All right, can you hear me all right? Thumbs up in the back. All right. My name is Greg Albritton, and I am a part of the AO Computer Club. And today I'm going to be talking about fair tokens. Now, most of you here know about fair tokens. However, I feel like it's really important to emphasize it as a kind of source of camaraderie. In the AO ecosystem, we have an amazing opportunity to do something different. Something that was done many, many years ago through Bitcoin, and something now that we have access to thanks to the token distribution and the fair launch of AO. And this is really, really exciting to me, because one of the things that attracted me to Arweave several years ago now was this high degree of integrity, right? We're looking to preserve history, all kinds of history, all types of formats, digital and so on. And today we're looking to provide opportunities across the board for individuals and not have these backdoor deals as the primary motive. So I think fair tokens are friendly tokens, and I think it's important that we emphasize this and kind of cheer behind this movement, if you will, if we can make it one, which I think we can. So here is a bowl. This is kintsugi. You may have seen the check. All right, you may have seen these types of bowls. What's really cool, and the reason why I have this on the screen, is that tokens have been broken. All of these things in the limelight today are incredibly problematic, right? It's not fair by any means. Individuals are getting rug pulled in all of this. And I think we have an opportunity here to make things much better from a broken system. And there's real beauty in the opportunity here, and that's where you see the gold inlay from the broken pieces of this bowl. Tokens are really having a moment, and I think this is the opportunity for AO and the AO ecosystem, right, which is fresh, for us to kind of put our foot down and say, this is actually how you do things. This is the way that you actually get fair, inherently high integrity token distribution. And I think this can be an amazing motivator if we really come together on this. Imagine if an entire ecosystem was based on that, and that's what AO is, really. So AO, the fundamental token, is a fair token. You can see the stats here. 21 million supply, just like Bitcoin. Nice, smooth halving schedule, like all of these layers. And in addition to that, there's some real cool distribution mechanisms here. Just by holding R, you get AO, right? And then for those that are bridging, you also have the opportunity to mint AO. Again, they're friendly tokens. Fair tokens are friendly tokens. Zero insiders, no pre-sales or closed rounds. It's really an opportunity for anyone to get involved right at the start, and that's something I can really stand behind. Now, one of the things that we've developed is AO DevBot, and the first module that we've created is to create these fair tokens, and they have memetic properties. So I'm interested in doing the impossible, which is an actual live demo. And ideally, we can get some participation here in the audience. And I think we can just kind of roll into that right now. So what you see right here is our interface for creating these fair tokens. So I'm going to come in here. I'm going to see if the internet will work, and it does, so that's cool. Does anyone have any kind of random word of a token that you think may be funny to create here on the fly? Anyone? Bueller.
Riz.
Huh? Riz token. All right, so let's see what happens here. We're going to make Riz token. One moment. And I barely touched the USB-C, and now we have nothing on screen. That's really what demos are all about. All right. Riz. Make Riz token. All right. Add funny quotes. Go live. Okay, so I really input very little details. This is actually connected with Claude in the background, and we also have an integration with OpenAI. Something that's really cool about the AO ecosystem is that AI is actually coming all on chain, right? So there's still more work to be done there. And so you can imagine this entire process completely on-chain, which to me is really exciting. You'll see that we got, yo fam, time to create the rizziest token that's ever graced the blockchain, Riz token. The smoothest, most charismatic token in crypto, pure Riz vibes only. So we're going to let this kind of cook a little bit. Typically, it takes around a minute. And what we're actually doing is not just creating a token. We're actually creating a full interface as well, which ideally will appear on the screen, again, if we have good fortune with the internet. We'll see what we get. I'm going to wait here just for a minute. OK, so now you can see that there's an interface being generated here on the fly. We're going to let this kind of cook a little bit more. And there's an entire embedded bonding curve in this page. We're using a few different templates from the ecosystems, putting all these things together in what I think is a pleasant interface for individuals to explore and have some fun. And it's a great way to be introduced to fair tokens, because all of the tokens that are created on here are 100% community launched. Even the creator doesn't get the token. They have to buy it. So we're really leaning into, hey, this isn't like background, bro deals or whatever. We're actually really putting the community first. So ideally, this can kind of wrap up here. Typically, it takes about a minute or two. In the meantime, I'll pop over to the slides and continue on here. All right, so what we're doing here is we're actually just using the Create a Fair Token module. We intend on creating a bunch of different modules, so you can create mini games, profile makers, website creators, interactive art experiences, and these things actually build out AO contracts as well. Like, this isn't just like, oh yeah, we use Claude and we're making front ends. Like, the whole thing is actually being generated based upon a number of factors that we've been working on actually for a few months now. All right, so we have this site now. We can pop it out and say, hey, like, how does it look? I'm not sure what this artifact is here. This is not part of it. This is like a screen artifact, I guess. All right. You got like some funny little quotes going on. Are you staking because I'm yield farming? Feelings for you? Who knows, right? Just some funny stuff. You can really go wild with these pages. You actually have an embedded bonding curve. It's fully operational when you go to that Fair Token launch. So what we can do here is actually generate an actual token image. This is using the HTML contents and CSS as well as the prompts to generate a relevant token design. And we're going to see if that actually does it. Full demo mode here. Sweet, we get an error. Awesome. We'll see if we can get through that, and our connection is happy with us. Just a moment here. So as this kind of cooks here, I just think that we have a great opportunity in this ecosystem. AO, the actual token, set the precedent for the ecosystem. We have things like Pi. We have things like Apis and all of these great projects leveraging the notion of fair tokens and really going towards the community. So what you can see here is we got Riz. We got this character here built out. There we go. All right, cool. So we actually have a full site. When we actually deploy this, it actually creates the whole AO contract. It creates the entire bonding curve marketplace, and it deploys to the permaweb. So I'm going to come back to the slides here real quick just to wrap up. Token distribution for this tool is 100%, right? The creator themselves actually have to buy their own token. Really standing behind the fair token. It's fair launch season in AO. If you're new to AO, I highly encourage you to check out this model of fair launch tokens. There's an amazing support system that has been created through the permaweb index. I'm not quite sure how many individuals are fully gathering to what extent this can mean. There was an earlier mention, I think, by Sam to the tune of, if I remember correctly, up to potentially like $100,000 a day going into builders, as I interpret it. Obviously, it's very early days and we're learning about that. This stuff is serious. There's an amazing opportunity here. So I just want to continuously repeat that because I want to make sure that individuals are really recognizing what's going on. So we'll be at the booth, the Arweave and AO booth. You'll actually be able to make your entire FAIR token at the booth. And there's some other fun details. And in the meantime, if you want to sign up, you can grab a spot here. We've had about 50,000 signups thus far, which is pretty amazing. And thank you so much.
Okay, thank you so much, Greg. For our last workshop today, we have Alan once again. Alan, if you flip another coin, you better nail it on the first try, bro. It's all on the wrist. Let's go, let's go. Oh, sweet.
All right, hello again, East Denver and the AO Arweave community. Today, oh, we're not even on. Now we're on. Ooh. We're a little glitchy today. What's going on here? Try a different item up here. All right. Let's do it. Some minor technical difficulties here. Wouldn't be a good demo without this. Okay, I think we're on. All right, so what I want to do today is walk you guys through a bit of the tooling we have around RANDAO and sort of the process that you might go through in order to generate a random value. So we have a basic TypeScript project here. It's really just a node project, nothing special, no special dependencies yet. And the first thing we're going to want to do is head on over to our documentation where we can get the install for our client library for RANDAO. Go ahead and install that. Pretty simple. Just a second. We love East Denver Wi-Fi. Amazing. And now that we have the actual client here, we'll be able to say, ooh, probably have to refresh this. Reload window so the node modules work. And if we start typing random client, this should pop up from our client library. And we try to make it as simple as possible to generate a random value. So all of the actual process IDs are stored on chain, and we actually query them from the client. So you don't actually have to do quite as much configuration. And we'll go ahead and make our client. And let's see what we can do with our client. We can do client dot create a randomness request. So the way this works with RANDAO is that we create a request for random for which we give a callback ID where we can later query that callback ID or actually receive the value directly to our process if we're working on chain. And we'll do create request. Oop. I have to await things. Don't forget to await things. That's important. JavaScript. All right. Create random request. And we're going to need a few things here. First thing we're going to need is our provider IDs. And at RANDAO, we kind of let you choose your own security level depending on your own needs so that your payments can actually scale with the security just as you'd like. So we're going to go ahead and head over to our provider website, where we have a bunch of different providers with various amounts staked. And this is really just a marketplace where you can determine where you'd like to get your random from. And today, I'm thinking Fred is probably, he seems like a reasonable person. He's got a good name. Some of these people put weird names. but we're going to go ahead and use Fred as our provider. Providers. And you can use multiple providers for added security. For today, for just demo purposes, we're going to just use one to make it simple. Put that in there. We'll need a few more things. We're only requesting one input, and we need effectively a callback ID. And a callback ID is something you control on the client side so that you know the random that you're getting back is what you requested. My spelling's a bit off today. And this can really be anything you want, so I'm just going to make it some random typings. Place this in here. And we'll await that. What this will do is go ahead and request our random value on chain. And so good to note, this is running locally on my computer, but all the random values will be generated on chain in a provably fair way. PM. And that's just a warning about my wallet, which I didn't set environment variables, nothing to worry about. Once we get this on Hyperbeam, it'll be significantly faster because we actually pay to be prioritized, which is a big upgrade we got coming soon with Hyperbeam. And in just a second here, we'll be able to query our randomness by doing something like response equals dot. We have a few different things we can do, but we're going to get our random request via our callback ID. And looks like chain got back. So at this point, the chain is aware that we would like a random value, and our providers here are actually generating that value for us. They're placing their random values, like I was mentioning before, on the chain. You can have up to as many are in here that are active, and they're going to place random values on chain where they can be aggregated, provably fair, and presented back to you. Go ahead and do this, get by our callback ID, and we're going to want to log that out so we can see it. Response. We're going to want to pretty log that, I bet. Stringify. That's 2. That makes sense. And we don't need to request again. We only need to request the randomness. We want to get the value of the randomness that we already requested. And on-chain, this would work a little bit differently, but for demo purposes, a little bit easier here. On-chain, I don't know how to code apparently. That's my bad. What in the world did I do? I forgot a parenthesis. How dare I? So this will work a little bit differently on-chain, where we actually have access to sending messages back and forth between processes, where we would have one process that would request the random from the randomness process, and once the randomness is complete, fully generated on chain, it will use that callback ID and the process ID that actually requested it and send it right back to it so it doesn't have to re-request again. I printed something wrong. What happened here? I didn't. Oh, wait. How foolish of me. And in just a second, we will have our random values, and we'll get to see a bit of the inner workings as well of how we actually generate these random values. So as you can see, we've got a response back where we're able to see that we had our provider here. I believe this, we have the request ID, and we have the actual, these are some of the inner workings of the cryptography behind it, but we actually have the provider that we requested and what he gave as his random input, as well as the finalized random output, which has been aggregated and finalized on chain. And this is actually what you would use in your math.random function to seed it, which would allow you to have provably fair random. Yeah, so that's really the gist of it. I did want to leave a small opportunity for anyone who had any questions about any of the Randau topics we've talked about today, from providers to running your own node to becoming a developer with using Randau's randomness, or really anything at all. All right. I'll leave a few more seconds of awkward silence, and then I'm going to call it a day. Well, thank you guys. This has been awesome. I'm glad y'all got to see exactly how we would generate a random value on chain, and that it's fairly simple to do. And if you'd like to work with us and use our random values for if you're building a casino lottery or if you're building a AI on chain, reach out to us and we'll get you set up.
Test, test. Okay, ladies and gentlemen, that was it. Thank you so much for coming to the AO conference. If you're excited about the permaweb, make some noise. It was great seeing everyone. Have a great evening.
Each block mine down. Professor Waze got the future on spin. Urging notes dancing where the bottlenecks been. Professor Waze got the future on spin. Plugging tomorrow with yesterday's ram stains. Throwing me mad, but mad's just a beta test for Boodle. Oh, Pete Jobs.
Dollar will dramatically lose its purchasing power. The more they print, the more it gets diluted. Who it's good for is the people at the tippy top.
Because in order to keep the system going, they have to keep printing money.
And Bitcoin is that tool that allows us to beat the money printer.
Bitcoin is powerful in a way that is money that does not discriminate.
Bitcoin is built by the people for the people.
Just dreamers, on-chain truth, no middle schemers, working hard and shipping code till sunrise every day. DAOs are voting, vibes are flowing, buff-eyed corns are still a-growing. While the world is breaking down, we're regen in a new way. Some VC said this tech won't last, and the hurt bubble, watch it crash. But we don't need your central banks, 'cause regen biddlers stack in stacks. For we bid let this city on sports and chains. We bid let this city with regen brains. We bid let this city on sports and chains. No rug pulls, just pure on chain. Whale pools floating, fees are burning. ZK proofs the chains keep turning. Every block we validate is trustless, clean and fair. Open source and gas optimized, code permissionless and finalized. Fork marmots on the scene, you know we're gonna bid a little in there. Some tread fibro just rolled his eyes. Where's the yield? Where's my supply? But we don't need your banker games. We just launch and stake on chain. Go, we pay let the city on sports and chains. We pay let the city with regen brains. We pay let the city on sports and chains. No rug pulls, just pure on chain.
She's a Colorado comet in code forged steel, wings snipping latency like scissors through gel.